Hey friends, so now we're gonna speak about the most important chapter in the whole Power BI, the data modeling, because if data modeling is weak in your project, everything else is gonna suffer and fail. So in this chapter, we're gonna do a full deep dive into data modeling in Power BI, but the right way.
There's a right way to do this.
So I'm gonna do it with you carefully, step by step, as usual with the fundamentals, using sketches, and then we deep dive as we progress. So now, let's get started. Alright, so now let's have a look to the main phases, the main components in Power BI. So we start by connecting the data from the sources, and after that we transform it using Power Query, and then we build the data model, and on top of it we write DAX calculations. Then the next step we start building visuals, report and dashboard and share it with the others. So now by looking to this, we have like clear separation between like back-end work and front-end work. But now what happened in real Power BI projects in many companies is that people try to skip things in the back-end and jump immediately to the front-end things, because building visuals are more fun, right? Colors, charts, dashboards, and it is the thing that the end user is gonna see from you. So they try to speed up the backend process, and especially one thing, they skip the data modeling. So they might do some transformations in Power Query, build some DAX, but the data model step, it is totally skipped. And this is, my friends, where many Power BI projects start to fail over the time. So everything in the project is gonna start be heavy, expensive, slow, and hard to maintain. And I can tell you many stories about this at work. I got invited many times to save Power BI projects that are suffering and failing, so they ask me to review the project and suggest fixes in order to save it. And I can tell you, after reviewing and auditing the whole project, almost all of them are doing the same mistake. They are skipping the data modeling. They are really huge projects, but they rush it, so they go immediately from the sources and start building visualizations and dashboard, and over the time they start failing. So in many cases we just built the data model and saved the project, but there were some projects where it was too late and they died over the time. So data modeling is very important, and I understand why this happens, because data modeling can feel hard, and many courses out there, they just show you simple star schema and they move on to the next steps. But with me, we will not do that.
I will not be beat. I will never give up.
So now let's start with the mindset and understand why data modeling is so important, and if you skip it, everything gonna fail. Let's go.
Let's get the party started.
Let's get the party started.
Okay, so it starts like this. Someone gonna ask you for a new report, and you're gonna start connecting the data and create one big flat table with all columns that are needed. Then you start adding some DAX calculations, build the report, and then share it with the user. So that's it, and this might take like maybe 1 or 2 weeks. At the start, you're gonna feel that everything looks fine, and you're gonna feel that you are fast and flexible, but Power BI projects don't stay small. The data gonna grow, you're gonna get more requests to extend the report, you're gonna get more users are using it, and you're gonna start feeling things are getting like out of control, because this one table, my friend, it is not a data model, and it's gonna cause a lot of issues. So now, the first issue is all about the size. Things might work if you have like 10,000 rows, you won't feel the problem, but if the sources are like providing 100k or million, 10 million rows, you're gonna feel the issue. This one table gonna get bigger very fast, because the same information like the product name, customer name is repeated over and over, which gonna make the whole Power BI heavy for no good reason. Instead of storing the product name only once, you are storing it thousands or millions of times. So the size of your one table gonna grow very fast, and this gonna lead, my friend, to many other issues like the performance. And here two things gonna get slow. First performance issue is the load process from the source to Power BI. So refreshing the model gonna move quickly from few minutes into half hour or hour. So it's gonna be painful to bring a new data to the Power BI. And the other performance issue is the report performance. Power BI gonna need more time to scan the one big table, to build the visualizations, the filters, and to react to the interaction from the end user. So your report gonna be slow, your users gonna suffer, and I can tell you in real projects, if the report doesn't open in like 2 or 3 seconds, your users gonna say, you know what, the whole project is slow, and they're gonna start complaining about it. So performance issue gonna be everywhere. Now we come to another big issue, the DAX. I met a lot of people in projects that think DAX is complicated or they are bad at DAX, but actually this is not the problem. The one big table forcing them to write complicated formulas and calculations in DAX. The rule is very simple. Bad data model gonna lead to bad complicated DAX. Because of not having a data model and having one table, a simple measure that should take only one line becomes 10 lines because you have to twist things in order to get the right results. So having no model gonna be the issue for the size, the performance, and DAX. Now, what is the solution? Is of course to build a data model. So that means we stop putting everything in one big table, we split the data into meaningful tables and connect them with their relationships. This is gonna solve all those issues because it's gonna make the model smaller. So the same product information or the customer information will not keep repeating because of the sales. So the text is not repeated for no reason million of times. The size is gonna stay small, and this of course means you're gonna have good performance. So you can load a new data to Power BI, you can refresh faster, and as well the performance of your reports gonna be faster. Like for example, if you have a slicer in the report, Power BI doesn't have to go and scan one big table. Instead, it's gonna go and read one small dimension table, which gonna be way faster to build the visual for your users. And as well, because of having relationships between those tables, DAX can become easy. So the data model and the relationships gonna do big part of the work, and your calculations on DAX gonna become smaller and easier. So those are the big wins and the first reasons why we need a data model. But there is another problem. Now the thing is, if you skip building solid data models and you go with the one table, this gonna lead over the time to very bad habit, or let's say bad system design, that's gonna be the main reason of why your project is meant to fail. And by the way, I saw this in many projects at companies. Now the thing is, you will not build like only one report and that's it at companies. You will get requirements to build another report, another dashboard. And now since you don't have a data model and you just build one tailored table, this gonna lead you to build another one table for the new requirements, for the new reports. So you're gonna do the whole process from the scratch, connecting data, building one table, building one dashboard, and then sharing it with the user. And this design gonna continue. So you're gonna get a new requirement for new reports, and you're gonna do the same thing over and over, one table for one report. And my friends, if your project start looking like this, one table, one report, then I can tell you this is gonna be the beginning of the end of your project. Now let me tell you why. Now for you, the one that is building the project, this is gonna be a nightmare to maintain. So let's say that you found an issue in the transformations, or you want to change something because you got a new requirement. Now what's gonna happen? You're gonna go to all Power BI files and start editing this one table one by one, and you're gonna try your best of course to do the same thing over and over to have the sync between those transformations. But I can tell you this is a lost battle because one day you're gonna forget to update one of them. So one small change is gonna be a lot of work for you. It's gonna become days or weeks until you finish. So really hard to maintain. And this is gonna lead as well to another issue. Your calculations and transformations gonna start be different from one report to another. And this is a big issue not only for you but as well for the business, for the users, because now your reports are showing different numbers. In one report you show the sales as 1.2 million, and another report could show the sales 1.4 million. At the end it is the same thing, it is the sales, but you're gonna calculate it differently in all those files. And I can tell you, when your users gonna start seeing that the numbers are not matching, they will stop trusting the whole Power BI project. They will not see that the data model is wrong. They're gonna see, okay, the whole Power BI tool, or let's say the whole project is wrong. And this is exactly the turning point. This is how projects starts to fail, to die, where people stop using the dashboard and they go back to their old tools using Excel. Now of course the question is, what is the solution? Of course, building a solid data model. Now the thing is, one big table is usually built and tailored around one report. But once you start thinking in models, you go and start building things around the business. So you're gonna say, okay, we need sales, we need products, customers, dates, and connect them together. You are not tailoring anything for a report. You are actually building a solid model for the business that can answer analytical questions. So naturally, you're gonna start reusing this model for multiple reports, because usually the next reports are for the same business. So what I'm trying to say here is, once you start building data models, you start thinking how this model can serve multiple reports. And this is a big win if your project start looking like this. First of all, it is easier to maintain. You're gonna be very fast. So if you found any issue or you want to change the logic of something, you go to one place and do that. And your change or your fix gonna affect all the reports. So it is easy to maintain. And not only that, this gonna automatically force standards and consistency. So you're gonna have less chance of having different different numbers in different reports. So that means your project can have better chance to survive and be solid for many other use cases. So this is, I'm gonna say, a bigger reason why we need data modeling in Power BI projects. And now we come to some reality check, or let's say some people gonna push back on this and gonna say, hey, this gonna looks really good on paper, but in real projects it will never work because different reports have different requirements, and if everything depends on one shared model, then changes one thing gonna become really scary. So you're gonna feel like I might break something if I change the calculation because all reports are using it at once. Well, I'm gonna be honest, this is totally fair. This is what's gonna happen if you build one giant shared data model for everything. We will not do that, of course. You will not build for one company one model. You will be creating shared model by subject area, by domain. One model for the sales reports, one model for the finance, another one for the HR report. So you're gonna get like a group of reports that are using one model. Things gonna look like this. For each domain, you're gonna have multiple reports and one model. And if your project is getting bigger and bigger, you're gonna have multiple models. So that means we will be in the middle. So we will not go and create like one table for each report. And at the same time, we will not try to force one model for the whole company. Now, let's have a recap. Why data modeling is important? Because bad models gonna create technical problems. Very big Power BI files, slow reports, hard to refresh, and complex docs. And as well, bad modeling gonna also create project problems. Repeated work, hard maintenance, different KPI numbers, and users losing trust. So I hope with this you have now enough arguments why you have to take time to do data modeling. Maybe you have to go and now convince one of your managers or your project. If you skip it, your report might work for now, but over the time you have high risks of failing. So now, what is data modeling in Power BI? Now, first of all, the data model, it is a structure that describes the business data and how the pieces are actually related to each other's. What this exactly means. Now, data modeling, it is a process that looks like this. You're gonna have a look to your data. It could be chaotic inside files, inside databases, or in one big file. And inside it, you're gonna have like a mix of business objects, sales, products, customers, dates. Now, you're gonna look at it and then decide what is the best structure for it. And here you decide for two reasons. First, for the business, so you're gonna go and start organizing the data into clear business objects. Like you're gonna say, okay, all the sales data gonna go in one place, then you split and take all the products in another table. Same things for customers and dates. So you start splitting your data and put it in places based on the business itself. Now, the second reason why you want to bring a structure for it, it is for the tool that you are using. Like for example, Power BI. We want to shape the data in a way that Power BI can work efficiently and correctly so that you get nice response and fast performance. That means our goal is to look to the original data and think about how to reshape it for those two goals. Split it into tables based on the business and split it in order to get good performance for the tool that you are using. We are not splitting things randomly. We have a plan.
My plan, a man, pan.
Now, the next step in data modeling is to decide how to connect those tables with relationships. Relationship, it is as well a description that can explain how those tables relate to each other's. And the final third component in data modeling, we define the calculation on top of the model, like the total sales, the average profit, the total number of orders, number of customers, all those calculations. And in Power BI, we do those calculations using docs. So that means the model is not just like one table or one object, it is three parts that work together. Tables to store the data, relationships in order to connect those tables, and calculations in order to answer business questions. Alright, so this is the data modeling, and now let's go and focus on tables, because in data modeling, tables can have different shapes, different roles, depend on the modeling technique. In techniques like, for example, the data vault, the table is gonna have the role of hubs, links, satellites, bridge, so different, like let's say styling. And in operational systems, the tables might take the shape of an object, or let's say play the role of relationships and link. But in Power BI, things a little bit easier because we are building for analytical reports. And the most important modeling style or technique, it is the dimensional modeling. So in this technique, the tables might take one of those two shapes, fact tables and the dimension tables. And now let's deep dive into those two and start with the first one, the fact table. So what is that? A fact table stores business events, transactions, or activity that we can use in order to calculate something. So now what this exactly means, let's have this example. So now here we have a sales table. Now what we do, we have a deep look to the data in order to understand the behavior or what this table is trying to tell us. Now first of all, we can see the table is recording something that happened to the business. And what happened here? A sale did happen. So there is like an event. The second thing that you're gonna see, it might include a lot of IDs. Those gonna be like a link to another thing, another table. Now another pattern, you're gonna find informations about the date and time, like an order date, an invoice date, transaction date. So you're gonna find information about when this event did happen. And the last pattern that you're gonna find here, we have numbers like quantity, sales, discount, cost or profits. All those numbers gonna help us to calculate something. So if you see all those together, so an event, IDs to something else, information about the date and time, and a lot of numbers, then my friend, you are looking at a fact table. This table is just recording the business activity. So this is the first type, the fact tables. Now let's talk about the second type. We have the dimensions. A dimension table stores descriptive informations that gives the context to the facts. Of course, we have to understand what this means. Look at this table. It is storing the product's informations. And you can see each one row is actually representing one product. So that means the row here is not like an event or like we are recording something happened. It is just describing a business object like the product. Now, the second thing that you're going to notice that we have a lot of attributes, informations that is describing this product, like the product name, the category, the brand, the color, the status. So they are just adding more context to the product. And now by looking to this, you can understand those columns are really important in reports. So we could use one of those columns in order to do data filtering, in order to focus only on small subset, or we could use one of those informations to make a group of numbers in our reports. Like for example, we can take the categories and we can build something like the sales by category. So that means this information, the category, gonna help us to group up the sales number. And this is of course the core thing in building visualizations and reports. So if you have a table like this where we are describing one business object like the products or maybe the customers, and we have a lot of columns that are adding more and more context, and they look amazing in order to build a filter or to use it in order to group the numbers, then my friends, you are looking at a dimension table. So this is exactly what we mean with the second type, the dimensions. Alright, so now let's compare those two quickly side by side. The fact tables record what happened. Dimension tables describe what happened. The core of the facts are usually dates and numbers in order to do calculations. The core of the dimensions, they are usually the labels that we use to analyze those numbers. Like for example, sales by category. The sales are numbers that comes from the fact, but the category, it is the label, the context, it comes from the dimension. So the fact answers what happened, it is like an event and transaction. A dimension answers who, what, where and when. So it is the description, it is the context. So actually that's it. Once you understand those two, then data modeling become much easier to understand and as well to build. Okay, so now by looking back to our data model, with that we have the two main tables, facts and dimensions. And now of course the question is how to connect them. This of course gonna lead us to a very famous shape called the star schema. A star schema means we have a fact table that sits in the middle and we have all those dimension tables that connect around it. So the fact sales is in the middle and around it we have products, customers, date, store. And look at this. It is forming the shape of the star, right? That's why we call it star schema. And this is our target in data modeling. We want to get this shape. And my friends, Power BI just love star schema. It works very well with this shape. And of course, you might ask why? Well, there are many reasons. Like for example, it gives Power BI a clean way to filter the data. So all those dimensions around the fact, they're gonna go and filter the central table, the fact that holds the numbers. And of course, all those relationships gonna help Power BI to understand how the filter should move. So for example, if you are filtering the products, this has an effect on the numbers, like for example the sales. Same thing, if you filter the customers, this is gonna automatically filter the sales and for all other dimensions. And now because of filter logic is so simple, DAX gonna become as well much easier to write. So all what you have to write now is just like for example, the total sales is equal to sum of sales. We don't have to write any complex DAX calculations because we have a clean data model that is supporting it. The model already know how products, customers and dates are connected to the sales, so you don't have to repeat it in the calculation. And not only that, as well, it's gonna make building the visuals much easier for you and as well for Power BI. So you can have this mental mode in your head to say, okay, if I'm building the visuals, I need numbers, and you go immediately to the middle, to the fact. And if you want to group it up by something, then you look at the dimensions to get a label. Same thing, if you want to build a slicer, you usually go and look to the dimensions. So that means star schema gonna gives you a clean starting point to build any visual. So actually that's it. This is the star schema.
So shoot for the stars, okay? All right.
Fact in the middle, dimensions around it, relationships from the dimensions to the facts. The facts gonna hold the activities, the numbers. The dimension gonna give the context and the filters. So this is exactly why star schema is amazing, not only for Power BI, but as well for other BI tools like, for example, Tableau. And now the thing is, we don't have only one method on how to model the data for Power BI, but as well we have another thing that you might hear, Snowflake schema and the Galaxy schema. So what are those stuff? In real projects, what might happen is that one of your dimensions in the star schema start getting bigger and bigger over the time. Not only you are getting more data and rows, but as well you are adding more columns over the time. So your dimension gets really big, and here you decide to go and split it into two dimensions. So now, for example, instead of having one dimension for the product, you're gonna go and split it into two dimensions. One for the product and one for the category. And now what you do after splitting, usually you go and connect them and build relationship between them. So that means the relationship is not only between the dimension and fact, but as well you can have it between one dimension and another dimension. And this might happen to another dimension and so on, and you start splitting. And over the time, this star schema gonna looks like a snowflake schema. So it looks like snowflake. Now if you work with those two and compare them side by side, you're gonna understand that the snowflake schema, it is more complex. You have more relationships to manage, you have to write a DAX that is suitable for the snowflake, and now Power BI might get a little bit slower because it's gonna go and connect a lot of tables until it reach the fact table. But of course, on the other hand, the snowflake gonna help you reducing the size of the model. So if your Power BI file is really big one, you can go and split it and use the snowflake in order to reduce the size of it. So I worked with those two, and I can tell you I try most of the time to avoid using the snowflake and try as a default to use the star schema because it is just simple. And only in extreme cases I go and split a dimension into two, and okay, we call it now snowflake. So snowflake is the second type of data modeling, but actually we have a third one that's called Galaxy. Sounds fancy, right?
I say chow because I'm fancy from Tallahassee.
So what this means? Now, this time the dimension is not a problem, but the fact. In many scenarios in real projects, you will not have like only one perfect fact that's gonna serve all the reports. You might end up having more than one fact. Like for example, you have one for the sales and another one for the budget. Now the thing is, you need both in order to build one big dashboard, and those two facts are sharing the same dimensions. Like for example, fact sales is using the dimension product, and same thing gonna happen, the fact budget gonna need as well the dimension products. So with this we have the product as a shared dimension between two facts. So actually that's it. If your model gonna look like this, then my friends, you have a galaxy. But here be very careful, this is very common mistake that done in data modeling. We never connect the fact tables together. They're gonna get connected through a shared dimension. Of course, this is very important topic and at the same time very advanced. We're gonna leave it later in the chapters, but now for you just have the sounding that we have a star schema. This is the most common and default data modeling that we do in BI and analytics. Then we have a snowflake. If you have an issue issue with big dimensions and you want to split and normalize. By the way, if I say normalize, that means we are just splitting big tables into smaller tables. And the third one, the galaxy, if you have multiple facts that are sharing the same dimensions. Now, just quick clarification about the terms that you might hear in Power BI projects at work. You're gonna hear people saying dataset, semantic model, data model. At the end, it is all the same. Dataset, it is just an old terminology used by Microsoft Power BI, and now they are calling it semantic model. The data model, it's like people like me, I use it as official term. It is the process not only in Power BI but as well in any platform that you are building that has to do with data. So if you hear all those terms, don't worry about it. Just keep this in your head. The report is the visual layer and the model is what sits behind the report, and they can call it whatever they want. Okay, so now let's do a quick recap for everything that we have learned today. A data model, it is the way that we structure our data for two reasons: in order to build business objects and as well to make a clear structure for the tool that we are using like Power BI. It is made of three components: tables, relationships, and calculations on top of those tables. And now, since Power BI is a BI tool, analytical tool, then the tables usually have two important roles. Either it's gonna be a fact table or a dimension. Fact table gonna record what happened, so they are events. Dimensions, they're gonna describe what happened, so it is the context, and it's gonna help us to filter and group the numbers. And when we connect the dimensions around the fact, then we're gonna get the shape of the star schema. This is the foundations of building Power BI models, so everything gonna be easy for Power BI in order to filter data and as well to write DAX calculations. And if one of your dimensions are getting bigger, we split it into two dimensions, then we connect them together, and with that you're gonna get the Snowflake schema. Or in other scenario, if you have more than one fact that are sharing the same dimension, then you have a galaxy. Alright my friends, so with this I'm really happy that now you have a solid foundations about data modeling in Power BI in order to start really practicing. And this is exactly what we're gonna do. In the next video, we're gonna take a row table, build full star schema end to end in order to practice all those concepts. Hey friends, so now we're gonna speak about the technical part of data modeling in Power BI. It will not be easy, so I need your full focus. Now the thing is, Power BI is very advanced in data modeling and as well very sensitive. That means not only making a bad decision in big topic like how to module the data in star schema, Snowflake and so on could lead to bad performance and bad results, as well a tiny small mistake that you decide in the data model, like for example the cardinality on a relationship between two tables, could lead to bad numbers and bad results. So that's why it is not an easy topic to learn and, to be honest, to teach. You have to do a lot of projects in order to understand the different scenarios and why we do those decisions. Now I'm gonna do my best to bring all the scenarios that I had in my projects as scenarios in this course. So now let's get started.
Ramming speed. Here we go. Okay.
Alright, so now let's start with the foundations. In Power BI we have all those different layers, and we're gonna focus now into two layers together, the module and the visual layer. So let's zoom in. The visual layer, it is the place where you're gonna go and build your report. So usually you have like maybe two tables, and then you pick one of them and start drag and drop to the visual to build maybe a table or a chart, a card, and Power BI gonna just show the visual. But now what's gonna happen if you go to another table and drag and drop inside the same visual? Now Power BI gonna say, okay, but wait, how I'm gonna go and combine those two different data from two different tables in one visual? So Power BI need from you more infos in order to combine the data, and we cannot define the logic in the visual layer. We have to do it in the engine, in the previous layer, the module layer. There we're gonna define everything, the shape of the tables, how the tables are related to each other using relationships, the cardinality, the filtering, the calculations, how the data gonna move from one table to another, define the security rules. So Power BI gonna find all the rules, all the description about how everything is related to each other's, and how Power BI gonna go and deal with those two informations in the visual. And based of all those informations in the module layer, Power BI gonna have all the knowledge in order to calculate the numbers and plot charts in the visual layer. And here is the most important thing to understand: if the numbers are wrong in the visual layer? It is highly likely because the rules, the shapes, the relationships on the module layers are wrong. So bad model gonna define bad rules that gonna lead to bad numbers. And of course, my friends, don't expect if you make mistakes on the module layer that you're gonna find big error message in the visual, in the reports. No, mostly the report gonna function. You're gonna see numbers, your visuals are working, everything is okay. Only if you or your users make zoom in and start really checking the numbers, they might start seeing those wrong numbers. So mostly the mistakes gonna lead to silent errors that it is really hard to find. But don't worry about it, we're gonna start with the foundations. Now it always starts like this. In my data I have two tables, left and right, and I'm gonna need both of them in my reports. And here, my friend, you have two options, not only one. Either you're gonna go and combine those two tables together into one single table, like we have done in Power Query by merging the tables into one. They are physically now one table. Or the other option that you say, you know what, let's just leave them as it is. So we will not go to Power Query and do anything. We will just like put a line, a relationship between those two. Physically, they're gonna start separated from each other's, but they have a relationship between them. So this is the first decision that you have to make. Either in Power Query you are merging or building relationships in the module layer. Now, of course, we are focusing on the relationships. So what are they? A relationship, it is like a contract between two tables in order for you to define the rules that gonna tell Power BI how to filter and how to combine the data from those two tables into one visual in the front end. And now you might say, wait, you said relationships, we don't combine data, only merging in Power Query we combine. So now we are combining actually in relationships. So what is going on?
What is going on?
Now let's zoom out again. The three layers: Power Query, module layer, and visual layer. Now, if you merge two tables, it's gonna happen at the beginning, in the start, in the Power Query. So everything gonna be merged together, the columns, the rows, into one single table. And of course, in the next layers, the module, the visual, you're gonna see only one single table. So that means combining the data happens in very early stage in the Power Query. But now in the other side, if you go to the module layer and build a relationship between those two tables, they will not get combined. They're gonna stay separated. So that means in module and as well in visual layer, you're gonna see the original two tables, but only if you go and build a chart, a visual in the visual layer, and you start picking data from left and right, only there the data gonna get combined. And of course, not all columns, not all rows. This depends on what you picked and what filters you are using. Now, of course, you're gonna say, okay, when we combine in Power Query and when we build relationships, the rule is very simple. If two tables are describing the same row, like for example, you have customer info and customer emails separated in two different tables, then no need to build relationships, just go and combine them at early stage in the Power Query. But if you have two different tables, like for example the sales and the customers, it would be a bad idea to go and combine them together. Instead, build a relationship between them. Those are the two options and the first decision that you have to make. But now we have more things. Now, in order to build a relationship between two tables, you have to define for Power BI three things. First, you have to define the keys. They are common columns between two tables, like IDs, keys, or whatever, so that Power BI know how to match the rows between those two tables. Without it, Power BI has no idea how to combine the rows. Another thing, you have to define the cardinality. Yes, a fancy name. So you have to describe the values inside those keys. And here we have two options that we have to define for each side. It is very simple. One means the values are unique, there is no repetitions, and other value, many, means the values are repeating, they are not unique, and one value can appear multiple times. So that means we have two options, two sides. That means we have four cardinality options. Yes, I can do math.
Hey, Michael, what's 394 times 5,912?
Let's see.
We have one-to-one, one-to-many, many-to-one, and the evil and the one, the only, many-to-many relationship. This is gonna be the real suffer. Okay, so let's have a very simple example. We start with the one-to-one relationship. So here we have two tables about the customers. One has the names, the other has the tiers, and they are connected using the customer ID. Now let's go and check the values inside the keys. We can see on the left side, the keys are unique. For each customer, we have exactly one row. That's why the relationship on the left side is one. Now let's go and check the right side. We have the exact same thing. Values of the customer ID is unique. There are no duplicates. duplicates, and as well on the right side it's gonna be 1. So that's it. This is the one-to-one relationship. Now let's have an example about the one-to-many relationship. So on the left side we have the customers again, and on the right sides we have the orders. Now same thing, we're gonna check the values inside the keys. On the customers we don't have duplicates, so they are all unique, but on the right side we have duplicates. So for the first customer, Maria did place 2 orders. So on the left side it is 1, on the right side it is many. It exists more than once. Let's try out John. Same thing. On the left side 1, on the right side many. But of course this is not must. Like for example Anna, she ordered only once. But since we have duplicates from other customers, this relationship gonna be one to many. Now the many to one, it's exactly the same, but we just like flip. So if the dimension now on the right side, we can say it is many to one relationship. So the same thing, we are just like flipping the sides, nothing new. Okay, now we come to the many to many relationship, and here we have 2 tables. On the left side we have the customer segments, and on the right side we have the orders, the sales. Same thing, they are connected using the customer ID. But now if you have a look to this, you can see the customer ID is not anymore unique on the left side. So a customer could belong to multiple segments. And on the right side, the fact it was normal because a customer could order multiple things. So that means if I click to one of those customers, same effect, they go and like order multiple things. But now here is the issue. One order belongs now to 2 rows on the left side because the customer belonged to 2 segments. So that means the left side is not anymore 1. It is many, and with that we have many to many relationship. So we have to define the rules of the cardinality. Another thing that you have to define is the filter direction. Now in reporting we filter data like crazy, and we have to define the direction of how the filter gonna move from one table to another and whether it is allowed. And in order to control the traffic of the filters, we have as well some options. So now again we have this simple example where we have 2 tables, the sales and the segments, and for each table we have like an aggregation. For the segments we have the total number of segments, and here we have the total number of sales. Now one option to define the direction of the filters to say it is single filter from the left to the right. So for example, if I go and filter the data for the customer ID, you can see the sales is already filtered with the total, but as well the right side is filtered. So we have here only 2 segments. Same thing, if I go and filter the data by another customer, you can see it always has an effect on the right side. So whatever I'm filtering on the left, the filter is going to the right side. But now if I go and start filtering from the right side, you can see, okay, the table is filtered, we have only 2 segments, but this filter has no effect on the sales. I'm still seeing the total number of sales. So the filter is not traveling from the right side to the left side. Same thing if I go and select the other customers. You can see the sales table is not affected. Now of course we can do the opposite, where we can say single filter from segment to the sales. So this time if I filter on the segments, it's gonna filter the sales. But now of course if I filter the sales, there is no effect on the right side. Now if you say, you know what, let's have it free for all, everything filter everything. For that we're gonna use the both. So that means if I'm filtering on the left side, the data gonna get filtered on the right side, and the same thing if I'm filtering on the right side, the data are getting filtered on the left side. So wherever I'm filtering, it's gonna go everywhere. So as you can see, my friends, with this we can control the behavior of the whole data model, how the data is filtered, and this has a great effect on the reports. So those are the 3 rules that we have to define on the relationships: the keys, cardinalities, and the filter direction. And guess what? We will not do this only between 2 tables. We have to do it for the whole data model. Each time you connect 2 tables, you have to define those, and if you do it wrong, you're gonna get wrong results. Alright my friends, so now enough with the sketches and the theory. Let's go back to Power BI and practice. Alright, new start, blank report, and we are on the model view. Of course, what do we need? We need data, so we're gonna go and connect CSV files. Here I have prepared some facts and dimensions. We're gonna start with the fact sales. So let's go and load it. As usual, we're gonna get a preview. Okay, load. Now you can see we have something new. We have a card inside the model. This is the fact sales, and inside it we have a lot of columns. You can go and expand it if you want, but if you want to hide all those details, you can go and minimize it. So this is our fact. Now if you click on it, you're gonna find here on the right side some options. Like for example, in the properties, you can go and rename your fact. You can go and add a description. We have some synonyms, so we can call it fact sales, sales facts, and so on. This is important for the Power BI Q&A. If the user like ask, okay, give me the sales, Power BI knows, okay, the sales means the fact table. table. Same thing for the row label as well for the Q&A. And the last one, you can go and define the key column, but for now we will not define anything. So as you can see, some few metadata about our new table. Now if you go to the advanced, this is all about the load modes. Since it is a file, it is an import. Now on the right side in the data pane, we have here two tabs, the tables. It is a nice way to see the tables and the columns inside it. And if you go to the model, this is another way on how to present the data model for us. Like for example, we can go to the tables over here and we're going to see like a list of all our tables. In our model, we have a lot of things. So we have tables, relationships, we have measures. So here Power BI tried to group the different things inside our model by topics. With that, you get a nice overview of the whole data model. So this is the interface about modeling in Power BI. It is really advanced compared to other tools. Now, we don't have yet a data model. We have only the fact sales. So that's why we're going to go and connect for it another table. Usually we go and connect a dimension. So let's go and do that. I'm going to go and pick the dimension customers. All right, let's go and load it. Okay, once it's done, we have a new card inside our data model for the dimension customer, and we can move it around, but we keep the fact table in the center. So we have a new dimension, and you can see we have already a relationship between those two tables. So this nice line means those two tables are connected, and Power BI, yes, do it automatically. Now, as a default, if you add a new table inside the model, Power BI gonna go and investigate all the data inside this new table. Everything, the values, the uniqueness, and as well the column names. And once it finds a possibility to connect this new table to the whole model, it's gonna go and do that. So it is a suggestion from Power BI that is based on the data. It's not like a random guess from Power BI. This is of course a nice thing if you have small data model, but once the model gets bigger and bigger, this might be annoying because Power BI always try to connect it to all other tables. And what's happened, you're gonna end up like cleaning up all those relationships and start over from the scratch. So if you have a small model, leave it as it is. But if you have a big data model, you can go to the options and deactivate it. So now in order to learn how to create a relationship, we're going to go and delete this one over here. So if you just select it and hit delete, you can go and remove it. Now in order to recreate it, you have like multiple options. Either you're going to go to the manage relationships over here in the ribbon. So if you click on it, you can go over here and start a relationship between two tables. Or what I find like cooler, if I go and let me close this. For example, here customer ID, drag and drop it on top of the other column, the customer ID on the fact, then release. With that, you're going to create a relationship. So now what do we have in this window? You're going to read it from top to bottom. It's very simple. It says, okay, from table dimension customer, and then you have a nice preview of the data to understand the values inside the columns to the table fact sales. Same thing, we have a preview. So now what we are doing over here is we are just connecting the tables using the keys. So you can see here it's highlighted customer ID and customer ID. This is of course correct because I dragged and dropped on the correct columns, but if it was wrong, you can go and select another column by just like clicking on the column name. So with this, I'm saying the key is the customer number from the dimension and the customer ID from the fact. But of course, this is not correct. So I'm going to go and switch it back. So this is the first thing that we define. Another thing, we define the cardinality, and here we have 4 options. Now Power BI gonna target one-to-many relationship, and this is because Power BI knows the data and it selects the correct one. So this selection is based on the data, but Power BI has no idea whether this is correct for the business or not. Only you and the business users know the relationship between business objects in the model. So this is not a suggestion about how to connect tables. This is something based on the data that we have inside Power BI, and Power BI here says, okay, based on all the values that we see inside the customers, this is unique. That's why it is 1. But the customer ID inside the fact, you can see here we have 1. It is not unique. That's why we have the many. Now, of course, you can go and force another cardinality if you want, but Power BI will not allow it. You can say, no, we have here many, so you cannot do that. So we're going to go to the one-to-many. Now, of course, if we start from the table fact and then dimension, it's going to be many to one. It's the same thing, of course. So this is about the cardinality. Now, the last one, the filter direction. We can see here we have 2 options. Both and single. So if you leave it as both, and then let's go and check. So let me save it. So now look at this. We have like an icon on the relationship. It says both direction, and here comes something really important to understand. The best practices in the star schema is like this. The filter should move from the dimension to the fact and not both directions, because this is going to create something called ambiguity in filtering. That means it's going to has like a different effect on another table. We're going to have an example. Don't worry about it. For now, keep it in mind. the filter direction is always from dimensions to the center, to the facts. So now in order to make this more healthy and to follow the best practices, we're going to go to the relationship over here. So either double click on it, or actually we can find it on the right side. In their properties, we see now information about their relationship. Same thing, but it is like more compacted. Now the cross filter going to be single, and then apply changes. Now this looks perfect. The filter direction is from the dimension to the facts. And I can tell you, if your model looks like this, then you are following the best practices. On the dimension side, we have the cardinality 1. On the fact side, we have the star. So it is 1 to many. And the direction is from dimension to facts. Once I see this, then I'm going to be happy in the model. So this is how you create a relationship between those two tables. And now, of course, you can see the relationship on the right side over here under the group relationships. We have the new one, or you go to manage relationships over here. And you're going to have like a nice overview of all relations in your data model. All right, now before we continue, another thing that I usually do, once I import a new data, I check whether the IDs has this icon. Like for example, here the order ID has like an aggregation sign. Same thing for the product ID, the store ID. Now this icons means Power BI can go and summarize, aggregate this column. And usually we aggregate numbers, right? But there is only one case where it doesn't make sense, and that is for the IDs. We don't go and find the average of IDs or go and summarize all the values or something like that. Let me just show you what I mean. If you go to the report view and let's go to the fact sales, then grab the order ID over here. So what this tells us, the sum of order ID 10k, but this is not useful information. The only thing that we want to do with the order ID is to count it. How many orders do we have? But we don't need the sum or the average. And this auto aggregation is really annoying thing, because sometimes I would like to see the raw data in the front end, and always Power BI go and aggregate it. That's why what I do, I go to those IDs on the facts or in the dimensions, I click on it and then go over here and say don't summarize. So don't do that, and with that Power BI will not do that anymore. So let's go and try. I'm gonna go and drag the order ID in the middle. Look at this, now I see the IDs and this is perfect. So usually I go and do this for all IDs in the facts so that I don't have this issue. It is again luxury thing that we do, but it is important because usually as we are building the data model, we have always to go to the report view and verify whether everything is correct. All right, so now what we're gonna do next is that as we do data modeling, we would like always to understand the behavior on the reports. So we test things in order to understand whether this is exactly what we expect. And I usually do it like this. After doing few things in the model, I go back to the report view and start testing. Like for example, I'm gonna go and add one visual only for the facts and another one only for the customers. So here for example, I go usually with the table and I'm gonna go and add an order ID, maybe a customer ID, line total, so only few columns, and then I add a card for the fact table, so the total sales. And after that, for each table I make like an aggregation in order to see how things change, like the total sales. So same thing, I'm gonna go and duplicate it, but this time it's gonna be only from the customer dimension, so the customer ID, first name, last name. So that's it. And as well a card, this time it's gonna be the total number of customers. As you can see, it's like I'm building the model again but on the front end. Now let's go and test the filtering, right? So now if you just click one of those values, you're gonna see the table customer is filtering actually the fact table. Now it's all about the customer ID 1. Same thing, if I click on Anna, I'm filtering the whole fact table. So that means anything that I'm filtering on the right side, it has a direct effect on the facts. Now let's deselect and do the opposite. We start selecting things from the facts and see whether it has an effect on the customers. Like for example, the first order, if I click on it, look at this, nothing happened to the right side. I still have 5 customers. So it doesn't matter what I'm like filtering from the fact, it has no effect on the right side. That's because it is in one direction. Now let's go and test the both. If I go over here and select the relationship, say both, apply. Now let's test the reports. It is already filtering the customers. So now since I'm filtering on the order ID 8, it has the customer 3. This has an effect on the total number of customers and the visual. And same thing, if I go and start like clicking around, it has a full, the filter is moving from the fact back to the dimension. And of course, this is not a good thing. Now, of course, you might say why it's not good. It is correct. Like here we are just selecting or filtering one order. It is good information that we have only one customer for this one order? Well, this is okay if you have one fact, one dimension, but once you start getting a lot of dimensions, they're gonna start filtering each other's and it's gonna be full chaos. Of course, to understand this effect, we have to go and add another dimension, and this is exactly what we're gonna do now. We're gonna go and extend the data model with a new dimension. So let's go and get, my friends, the dimension products. So let's go and load it. Then say load. Now we got a new dimension. It is here, the dimension products. So I will just make the fact in the middle, surrounded with the dimensions. But now, why Power BI didn't create a relationship between those two tables? Now let's go and create the relationship by drag and drop the product ID on the product ID. And now we can see here we have an issue. This relationship has cardinality many to many. So here Power BI is saying there is something issue with the product ID. Now by looking to the examples, you can see 1, 2, 3, like we cannot see any issue here. At the end, it is just a preview, like only few rows. But our goal is of course to connect it with the product ID. Now let's go and try to force it to be one to many, like we have done for the customer. So one from the product and many to the facts. It says no. It even doesn't allow us to save it. It says the product ID in the dimension product contain duplicates, the value 6. So this is not really unique, my friends. So what we're gonna do, we're gonna switch it back to many in order for Power BI to allow us to save it. And then we have to dig into this issue. Now let's go and save this. Look at this. Between the products and the facts, we have many to many. And again, this is not healthy. We would like it to be like the customers, one to many. So now let's go and check the issue with the products. And we can do that by going to the table view. So here we have the customers. Let's go to the products. It says the product ID 6. And yes, we have duplicates. The same row exists twice. And this makes, of course, no sense. And that's why Power BI was not happy about this, because it breaks the rule. So my friends, Power BI was good enough to detect the issues, and it doesn't go and connect things randomly. If it sees something wrong, it will not go and create a relationship. Now, how are we gonna fix this? It is very simple. We're gonna go to the Power Query and clean the data before modeling it. So we're gonna go to transform data, then go inside and make sure to check the dimension product. And what we have to do is to just remove duplicates. Over here on the ribbon, remove duplicates. And now look at this. The product ID 6 is only once inside our data, and all the values are now unique. Actually, that's it. It should fix the issue. So let's go and save it. Now let's go and try to change the cardinality again. So let's try the one to many. And yes, we are not getting now any more issues. Power BI is happy. The product ID is clean, unique, pointing, of course, to many in the fact. Let's go and save it. So now things looks way better. The dimension has one, the fact has many. Same things for the customers. Now, of course, the filter direction, both of them are not that good. Just gonna go and switch it to single. Same thing for the customer. Now look at this. This is a perfect data model. It's very satisfying. All the filters are pointing from the dimensions to the middle, and we start seeing the stars around the facts and everything else with a one cardinality. So we have to keep pushing to get exactly this picture. And of course, the next step is just the luxury things. You might go and add some maybe metadata by defining the key. So here it is the product ID in order to have this small icon. And now, since we have multiple dimensions, I can show you exactly why it is bad to have both directions as a filter between the dimensions and facts. So again, I'm gonna go and switch them quickly. So here both as well. And as usual, in order to understand it, we're gonna go to the report level. And now since we have a third table, I'm gonna go and just add it quickly. So let me just make those things small in order to test and fit the products. So this is our fact, this is the customer, and we can go and add now the products over here. So I'm gonna go and get rid of those columns and only pick things from the products. So the product ID, name, and I'm gonna say that's it. And the last thing, I'm gonna go and add card for it. So this time we're gonna go and count the total number of products. So now those are the totals. 6 products, 5 customers, and around 6K of sales. All right, so now let's start filtering, and we're gonna do that by filtering the products. Like for example, I would like to see the total sales for the product number 1. So I can see here we have 2K, but look at this. the customers get filtered as well. Now I can see only 2 customers. And here of course comes the big question, should we as well filter the customers based on the products? Well, I can tell you, most of the cases we don't need this effect. It is too extreme to filter as well another dimension like the customers, because usually this is how the users works on dashboard. They have the dimensions in order to filter the major event, the major measure that we have in the report, which is the total sales. And now if the filter is filtering another filter, they're gonna lose immediately the big picture. They're gonna lose immediately the other possibilities that we have in the dashboards. So they're gonna look to the right side and say, oh, we have only 2 customers, but they will not think about, yeah, I'm seeing 2 customers because I'm filtering using the products. This is too deep and too much. Same thing if they go to another product, they're gonna see, oh, we have only 1 customer in our business. So they will not as well think inside your data model and they know, everything is connected and so on. They usually use the dimensions to filter one thing. And imagine you have a lot of dimensions, this is gonna be catastrophic. Filtering only one small thing gonna filter deeply the whole dashboard. And of course, you're gonna get the same effect if you go to the customers over here. We go and use, for example, Anna. They're gonna say, okay, this is the total sales of Anna, but it is filtering as well the products. Now, what is way better than this? What we're gonna do, we're gonna go back to the model and yeah, we're gonna go and change things back to single. Same thing over here. Now, let's go back to our reports. So now, let's try again. We're gonna go and select the product 1. And now, yes, I see the total sales for this product. But look at this, the customer is gonna stay as it is. So the effect, it is not that overwhelming for the users. Now, if they go to the customers and they say, okay, let's go and filter Anna, only the fact table gonna change. We still see the 6 products on the left side. So the effect is not that big. So my friends, as a default, if you are using star schema, don't go and use the both directions for everything. This is gonna be very overwhelming and very deep for users. Usually all what they do, they want to do analysis on one main measure, like for example, the total sales, and they need your dimensions for filtering. But if the dimension starts filtering each other's, they're gonna lose quickly the big picture of the dashboard, and it's gonna make filtering one thing like an overreaction in the report by wiping out all other data. That's why as a default, use one single direction, but in extreme cases, or if the users really want to see this effect in some reports, then go and use both directions, but limit it between maybe 2 tables only. So this is the best practices for filter directions in Power BI, and now you know why.
Thank you. I got it. Now I know.
Okay, so now let's go and add another dimension to our data model. This time we're gonna go and pick the store. So dimension store. All right, it is very cute, very small data model. Let's go and load it. All right, so we got it over here. Let's go and grab it near to the fact and bring the customers above. Something like this. First of all, we have something good. So the relationship between the store and the fact is 1 to many, and the filter is pointing to the right direction. So if I go over here, I'm gonna say, okay, it is using the store ID as well in the dimension, so everything looks nice. But now we have this weird thing. We have like a relationship between the dimension store and the dimension customer, and it is using this dotted relationship. It's not the straight line that we used to see between the fact and the dimension. So what is going on here? Let's go and open it. Aha, Power BI is able to build a relationship between the store and the customers using the city. Well, this is a very usual thing that you have the same information in multiple dimensions, and Power BI thought, yeah, why not to go and connect them using the city? This looks nice, but it is not a normal relationship, right? It was dotted, and you can see over here it says make this relationship active, and it is deactivated. That means we have in Power BI 2 types of relationships: active relationship and inactive relationship. So here it is inactive. Let's go and activate it and see what can happen. Say no. There are ambiguous paths between fact sales, dimension store, fact sales, dimension customers, dimension store, and fact sales dimension store. I know a lot of things here, but simply Power BI is just whining about saying we have a loop relationship. So the path is like cycling between the tables, and I cannot go and activate it, otherwise it's gonna be for me unclear how I'm gonna answer your questions. And you can see it over here, the loop, the cycle. So customers and fact, then we have fact and dimension store, and then pack. So we have a relationship between the customers and the fact, another one between the store and the fact, and a third one which is closing the cycle between the store and the customer. And this is exactly the cycle. Now, of course, the big question is why Power BI doesn't allow that? So what is the big issue? All right, let's have this very simple example. We have exactly the same setup here. We have the customers, the stores, and they are both connected to the sales, but at the same time, they are connected to each other's using the city. Now, let's say that I would like to see the total sales for one of our customers. So if I go and filter, for example, Maria, I expect that the filter gonna go to the fact sales like this, and the total of sales gonna be 1500. So this is our expectations. But the thing is, Power BI has another path to the sales. So it can go to the store, and then from the store, it can go to the sales. Now, because of this path, Power BI gonna filter the sales differently and get 2K for this customer. Now, of course, this is gonna be a big issue for Power BI because it has two different results for the same action. And Power BI cannot decide for us which one is the correct one. And this is exactly what we mean with ambiguous. Power BI don't know the correct path between two tables. That's why it prevents us from having this scenario, and Power BI force us to decide only on one direction, one path between two tables. Now, of course, we have the same scenario if you look to the stores. If you say, you know what, let's go and filter by the downtown, it's gonna go to the sales over here and get 2K, but as well, it has another path through the customers. So it can go to the customers and from customers go to the sales. Same scenario, same issue. So this is ambiguous and Power BI will not allow that. Instead, Power BI says, okay, I'm gonna leave for you the relationship between those two tables, but it is inactive. I will not go and use it. I'm gonna go and use only the active relationships. So if you go, for example, and filter Maria, Power BI has one clear active path between those two tables, and it's gonna get only one result. Same thing if I go to the downtown over here, it has as well one clear path. This is the loop and why Power BI was not allowing us to have ambiguous path, different options for the same action. Okay, so with this, now we have understand why Power BI did make this inactive between the customers and store. And now let's say that, okay, you decided that this is the correct path between those two tables and you want to activate it. Now what you can do, you can go, for example, yeah, it's wrong, but you can go between the customers and sales, open the relationship and make it inactive. So now it is dotted, and then go back to the link between customers and stores and make it active, which is, of course, again, not correct. But this is the way on how to switch between active and inactive relationships. Now, of course, I'm gonna get it back because this is not correct. So now what we're gonna do with this inactive relationship, you have here, my friend, two options. Either you're gonna say, you know what, I would never use this relationship between those two tables. It is totally wrong. So that means you go and just delete this relationship. But the other option is that we still actually, my friends, could use this relationship inside our reports. Now, the big question is how you're gonna use the inactive and at the same time active relationship in your project. Now, the thing is, the active relationship gonna be always used automatically from Power BI. So if you are using any calculations and filtering in the charts, Power BI always gonna use the active relationship. But if you have special cases where you say, you know what, I need this inactive relationship, you can go and use DAX. There is a DAX function called use relationship. It's gonna turn on an inactive relationship specifically for one calculation, so that the measure the calculation gonna go through an inactive relationship instead of the active one. So that means in one report you can let Power BI use all time the active relationship, but for specific cases you're gonna create an extra calculation, an extra measure that use the inactive relationship. So that's why, my friend, if you have an inactive relationship between two tables, either drop it or you're gonna use DAX in order to use this path for specific calculations. So those are our two options, but now I'm gonna say for this scenario I don't need it, so I'm gonna go and delete it. So yes, now again everything looks nice. All the dimensions are pointing toward the facts. The cardinalities around the fact are the many, the star, and the cardinality on the dimensions are 1. So far everything is healthy like planned. Alright, let's keep going and connect more things to our data model. Now, this time we're gonna go and connect another customer dimension, the loyalty. So let's go and do that. Again, a very simple dimension. Alright, now you can see that Power BI did connect our new dimension to another dimension to the customers using a one-to-one relationship. So let's go and open it. It says, okay, we are connecting using the customer ID, which is correct. And it says as well, the customer ID in the new dimension is unique. So we don't have here duplicates. Of course, same thing in our original customer dimension. Everything is unique here. And that's why Power BI did decide to go with the one-to-one relationship. So now the question is, should we panic? Should we leave it like this? These one-to-one relationships are actually a harmless relationship, and you will not do a lot of mistakes if you leave it as it is. It will not go and lead to wrong numbers or any issues in the front end. The only side effect that you have to think of is that Power BI has to go and join those two tables in order to present the results. So it is an extra effort for Power BI to travel from one table to another, but it has no effect on the correctness on the report. And here you have actually two options on how to do it. Either you're gonna leave it as it is, and here you could say, you know what, it makes no sense to have them like splitted. I can go and join those two tables together and merge them into one dimension. So with that, I reduce the number of travels for Power BI and maybe speed up things a little bit. So very famous solution is to just go and merge them. Don't leave them separated. So for example, here the names and the tier are gonna go together inside the dimension customers. So I'm gonna say this is the default solution that I usually do in my projects. But now in projects, sometimes we decide to split things using the one-to-one relationships for some reasons. Like for example, your dimension customer over the time gets bigger and bigger. You have a lot of columns about the customers. And in order for you to manage things easily, you say, you know what, I'm gonna put all the descriptions about the customers in one table and then group another set of columns in another table. Maybe some date informations about the last login, the first sign up. So they are like group of columns about the same topic, and then connect those two tables using one-to-one relationship. Or it could be for security reasons where you split some sensitive data into another table. So with that, you could hide this type of informations and you show only the informations that are allowed. So with that, we have like split between insensitive and sensitive informations, and we connect them using the one-to-one relationships. But again, those are special edge cases where we have to go and split things. But as a default, if you see one-to-one relationship, you can go and merge them into one dimension. And this is exactly what we're gonna do now. We're gonna go and merge those two tables together. And how we're gonna do it? We're gonna use the Power Query. So we're gonna go to transform data, and I'm gonna go and make this bigger. So let's go to the dimension customer, and then we're gonna go and say merge queries. This is the first table. We need the second table, the loyalty. Now we have both of them. Of course, we have to connect them using the customer ID. And here, be careful, you have to decide about the join. I usually always use left join. Inner join is dangerous because it's gonna go and filter the data. And by looking to this, I can say the customer has more weight than the customer loyalty because it has the main informations about the customers, and I would not like to lose anything. So you start with the main table and then the secondary table, and make sure to use the left join. So actually that's it. Let's go and hit OK. Now we have it here as a table. The next step, we're going to go and expand it. So we have to select the columns that we need. Well, we need the tiers, we need the points, but we don't need the customer ID because we have it already as a primary key. So actually that's it. Let's hit OK. Now look at this. We have the tiers and as well the points. The next step, I'm going to go and just rename them to be more friendly. So we're going to go over here and say rename. This is going to be tier, and the other one going to be points. So this looks really nice. Now in our model, we don't need anymore this dimension because it is already merged into the customers. So what we can do, we can right click on it and deactivate enable load. Yes, continue. So with that, we deactivate this table to be loaded inside our model. And with that, we have everything inside the dimension customers. So this is how we merge. It is like preparation step before the data modeling. So I'm going to go and close it. Make sure to save it as well. Now look at this. The dimension did disappear, but we have its informations inside the customers. Again, it is not that dramatic if you just leave it, but it is more clean to bring everything into one dimension, to have the shape of the star schema, and you don't have to deal with a lot of tables as you are building your reports. So with that, the dimension customer did absorb another dimension that has the relationship one-to-one. Now, my friends, dimensions don't always live in dimension tables. Sometimes they sneak into fact tables as descriptive informations. Our job is to spot those sneaky dimensions inside the facts and pull them out into real dimensions. So let's go and find them.
Well, let's see.
So now what we're going to do, we're going to go and inspect our fact sales to see whether we have dimensions inside this table. Let's go to the table view in order to inspect. Now, as we learned at the start, fact table is going to contain a lot of IDs, dates, and numbers. So let's see whether this is the case. Yes, we have a lot of IDs at the start. We have the dates, we have the numbers, but as well, we have a lot of text over here. This is a big alarm. Now, usually text and string columns, they're used in order to describe something. And this is exactly the job of the dimensions, not the facts. So that means, my friend, all those columns are actually good candidates for dimensions, and it makes no sense to leave them inside our facts. And this happens a lot in real projects where you think, okay, this table has an event, it is transactions, we have dates and stuff, but still it has as well, same time, a lot of description. So that's why it's time to extract all those dimensions from the facts and make our fact clean, and as well, we gotta get some useful dimensions. So now, of course, the question is, what we're gonna do with all those informations? Do we have here one dimension, 2, 3? Well, this depends on the relationship between those columns. So now let's see what do we have over here. We have promotion code. So it is a code that is used maybe for some sales. We have the order channel, in store, online, phone, the order status. We have information about the payment methods, credit card, PayPal, and so on, the card network, and the card type. Now, your main job is to spot the columns that relate to each other's. And from looking at this, I can say the payment methods, the card network, and the card type, all those 3 columns are actually related to each other's, and they are perfect in order to make a dimension. And this dimension, of course, gonna be the payment dimension. The order status and the order channel promotion code, they are not related to the payment methods. So that's why I would not go and connect those stuff to our new dimension. Now, of course, the big question is, how are we gonna split? Well, again, that means we need to transform the data, and for that we have the Power Query. So let's go there. We don't use Power Query only to merge things, as well to split things. So now there are like multiple ways on how to do it. I usually do it like this. Now the thing is, we don't have the dimension yet inside our data model. So either you're gonna go and get it from the CSV file, or you can go and duplicate the fact sales, which I think it is way easier than just like loading the data again. So I'm gonna go and duplicate the fact sales, and then I'm gonna give it the name, dimension, it's gonna be the payments. So this is duplicate from our fact sales, and of course I don't need all those columns, right, for the payments. I just need the last 3. So what we do, we're gonna go and select everything and say, go and remove the columns. With that, I got only the 3 columns that I need for the payments. Now comes something really important to do. Those informations usually gonna have a lot of duplicates. So look at the first 2 rows, they are just the same. So what we're gonna do, we're gonna go over here and say, remove the duplicates. So with that, each row is unique. And this is very important for the dimensions in order to get one-to-many relationship with the facts. Now look at this, what we are missing. We need the ID for the dimension in order to connect it with the facts. We don't connect things using text. And in order to generate an ID, it's going to be very simple. We're going to go and add a column, and then we add an index column. It's going to be a sequence of number for each row. So we're going to go over here and say, okay, start from 1. And with that, we have a nice ID. I'm just going to go and bring it to the start, and then what we're gonna do, we're gonna go and rename it like all others. So we're gonna say payments ID. Now look at this. If you go and compare it to any other dimensions that we have, this is exactly a nice dimension that we could use in our model to do filtering and all other stuff. Again, very important that we have an ID and the data is unique. We don't need many-to-many relationships. So this is how you build a dimension out of facts, but we are not done yet. We have to connect now the dimension to our facts. So if you go to the fact sales, and you can see that in the fact we are always connecting the dimensions using IDs, and we need the same thing actually for the payments. So actually we don't need all those informations in the fact, we just need the payment ID. Now how are we gonna do it? This is gonna sound a little bit weird, but we have to merge now the fact sales with the dimension payments just in order to get the payment ID. I know this sounds strange that we are splitting and then combining, but only with this you're gonna get a clean model later in the next layers. columns so that it is easy to connect and as well easy to use later in the reports. So now what we're going to do, we have to go and merge things. So the first is going to be the fact sales. The second is going to be the new dimension, the payments. Of course, the question is how you're going to go and connect those two tables. We're going to use the three columns. So we need the payment methods, the card network and the card type. Same thing from the first table, from the fact, we're going to use those three columns. So we have to connect all those columns in order to get the payment ID. And of course, it's going to work because they are actually the same columns. Again, we're going to use only the left outer join. This looks good. Let's go and hit OK. Now we got the whole dimension in the facts. We don't need that. We just need only one thing, the payment ID. So let's go and select it and say OK. Look at this. We have it already here. Let's go and rename it. So this is going to be payment ID. And what we're going to do, we're going to go and put it side by side by all other columns, right? It deserves now its place. So I'm just going to go and put it at the end. Now look at this. It looks clean. We have customer ID, product ID, store ID, and the payment ID. The last step that we have to do is to clean up. So we don't need any more those three columns. I'm going to go and delete them. So right click and remove. So it's going to be over here. Now look at this. Our fact is clean. And with that, I'm going to say we successfully extracted a dimension out of facts. We have, of course, other informations, but we have now less descriptions in the facts. Now the last step, we have, of course, still some text, but we're going to do that as a second step. Now let's go and save and close, then apply all the changes. All right. So with this, we got a new dimension, our dem payments, and as well, Power BI did connect it correctly. So things looks really nice. We have one-to-many relationship and as well the direction is correct. You can see we are getting the shape of the star, right? If I just move things like this, fact in the middle and surrounded by dimensions, and everything is pointing to our facts. So now, of course, we are not done yet. We still have some descriptive informations inside our facts. So the promotion code, the order channel, and the order status. Now, the big question is, how are we going to extract those informations? Do they relate to each other's? Now, if you look closely, you would not have the feeling those informations actually relate to each other. So the promotion code has nothing to do with the order channel. Same thing for the order status. So they are actually three different pieces of information in the facts, and all three together will not form a dimension, and they are not related enough to go and bring them together into one dimension. So now how are we going to solve this? You're going to find in some projects that people say, you know what, for each column we're going to go and create a dimension. So they start splitting each of those columns inside the fact and build a dimension and create for it an ID. And over the time you're going to find in their star schema a lot of mini dimensions around the facts, one dimension, one column, and so on. And I think this is really overreacting. So this is going to be a lot of work if you have a lot of columns inside the facts, and this is usually the thing in projects. Fact tables are usually big tables and they have a lot of status columns. So how are we going to solve this? We don't want it inside the fact, right? Well, the solution for this is something called a junk dimension. A junk dimension, it is a small dimension that bundles several unrelated low-level flags. So all those junk or garbage, let's say, columns that are actually not related to each other's and take space inside the facts, we're going to go and bundle them into a junk table, a junk dimension. And each time you find a new flag that is unrelated for anything, you're going to go and put it in this junk dimension. So this is the best practices in dimensional modeling or building a star schema to put all unrelated informations into one dimension. So now let's go and see how we're going to do it. So that means, my friends, all those three columns are going to go into a new dimension. So how we're going to do it? So same thing as we done with the payments. We're going to go to the Power Query. We're going to repeat the same steps. So we're going to go and duplicate the fact table and we're going to give it a name. So here, the official name, people are going to go and call it like dimension junk, or I usually go and use a friendly name. So dimension flags. Well, it doesn't matter which one you're going to use. It is just the idea. So what we're going to do, same thing. We don't need all those informations. We just need the unrelated columns. So remove the columns. And now comes something really important to do with that. So we have here a lot of nulls inside the junk dimension and we have to handle it. Otherwise, the join or the merge with the fact sales will not work. So this is very critical. What we're going to do, we're going to go and right click on it and say replace values. So instead of nulls, we're going to say unknown, or you can say, okay, So any string value that you want, like unknown or not available, let's go and hit OK. So this looks way better. Now only then we're gonna go and remove the duplicates. So make sure to select everything and then go over here, remove duplicates. Nice. Now things are unique. The last step, we're gonna go and add a column. So we're gonna add an index that starts from 1 and then move it to the start. We're gonna call you the flag ID. So this is our junk dimension. Everything is ready. We have a lot of unnecessary informations together, but it is not that big. Now what we're gonna do, we're gonna go to the fact sales and connect the junk to the facts. But we have to be very careful since we're gonna use all those 3 columns in the joins. They must match. And now the promotion code will not work, right? Because here we have nulls and in the junk we have the unknown. That's why we have to handle this as well. So we're gonna go and say, okay, replace values. If you are null, then you are unknown. Let's hit okay. Nice. Now we're gonna go and connect things using the merge. So we're gonna go to the right side and select those 3 columns and connect it to our junk dimension. Same thing. We just need the flag ID in the dimension, right? So left join and let's hit okay. So with this, we got the dimension as a table, but all what we need is the flag ID. So I'm going to go and deselect everything and say flag ID. And look at this, it is working. So before I move it, I'm going to go and call it flag ID. And this junk as well deserves its place near the other dimensions. So I'm going to go and move it to the left side, but I'm going to go and put it at the end. So look at this, we have the flag ID, the junk, and on the right side, now we're going to go and remove all those stuff. So right click on it, remove the columns. Now look to our facts. We have over here a lot of IDs, then we have the dates, and we have numbers, and all the junk now inside a junk dimension. So this looks really clean. Now let's go and close and save. Everything is loaded correctly. Let's go to the model. Now we have our junk dimension. I'm gonna put it here on top, and you go down, and we have to make sure this is one-to-many relationship and the correct direction. So my friends, I'm really happy with the results so far. With this, we have extracted a new 2 dimensions out of the facts. So we have a really solid dimension called the payment. All the columns relate to each other's, but as well, we have a lot of junk dimensions, a lot of unrelated flags. We bundled everything together into one dimension and connected back to the fact sales. So this is really amazing. I always keep my eyes on the directions of the filters, the cardinalities, just to make sure that we have a clean star schema in order to do analytics. Alright friends, so now we're gonna speak about dimensions so that they are kinda special, so they play different roles in different scenarios. That's why we call them the role-playing dimensions.
What do you think of role play?
So now let's understand what this means. Okay, so now in order to understand it, we're gonna have this very simple scenario where we have 2 dimensions, the salespersons and as well the managers. Both of them are connected to the fact sales. And now with this setup, I can go and find out the total sales, for example, per person. If I go to the Anna here, I can see that she made 2 orders and the total sales is around 1500. Same thing if I go to other salesperson like Carlos, Diana. With that, I'm able to find out the total sales and the total number of orders. But now if I go to the other dimension, to the managers, and I go and select the team of Pop, I'm gonna see the total number of orders and as well the total number of sales for the whole team. And his team has only 2 persons, so the 1 and the 2, so Anna and Carlos. And same thing if I go and check the other manager, I'm gonna see as well the total sales for that team. So far nothing is crazy, right? It is working. But now what could happen in real business is that one of the managers, like for example Pop, he can go and sometime close some sales. So that means if I look to Pop as a salesperson, I can go over here and see, okay, he closed 2 sales and I can see the total amount of sales. And if I look at Pop as a manager, I'm gonna see now the total number of sales and orders for the whole team. So that means I can look at Pop in 2 directions, one as a salesperson and another as a manager. So far there is no big problem, but the issue is that the design of the data model, we have the same person in 2 dimensions. So that means we have double informations, and this is not really good. Because for example, now if maybe Pop now change his name or address or whatever, we have information inside the dimension, I have to go now and update both of the dimensions. Of course here it's a very simple example, but over the time this is going to be really hard to maintain and to manage. And as well, this is a bad design if I make like a dimension for each role. Maybe next day I'm gonna get like a new role, like an account owner. Then we're gonna have like a 3rd dimension about the persons, and then we're gonna have maybe Pop in all 3 dimensions. So that means you're gonna lose get control quickly if you start splitting the dimensions by the role, especially if they are identical. You can see here we have the same columns. You have ID, name, team, ID, name, team. So they have the same schema. The only difference is the role. So now, of course, what is the solution? It is very obvious. We're going to go and bring all those dimensions that are identical, and we're going to bring them into one dimension that's going to play different roles. Okay, so now how it going to looks like in the modeling, we're going to go and combine those two dimensions into one generic dimension called employee. So before it was splitted by the role, but now we have it generic. And of course, in the future, if we had like an HR dimension, we can go and always fit it inside the employee so that we have like single point of truth for people inside the company. Now, of course, each person gonna be one row inside the dimension. And now if we do this, of course, we have to be careful not to lose information from the model. Like for example, before we had a manager, we had a salespersons. Those informations were the table name, and they are of course important in the model. But now instead of having them in the names, we're gonna go and put them as values inside a new column called a role, so that we have one complete dimension that is ready to be reused multiple times inside the facts. Now by looking to this, you can see that our dimension gonna play two roles, right? Salesperson and a manager. And for that, we have to go and create two relationships, one for the salesperson and one for the manager. And of course, in Power BI, we cannot have both of them active. One of them gonna be active and the rest gonna be inactive. So for now, for example, the salesperson gonna be the active relationship and the manager gonna be the inactive. So now let's have an example like before. Let's see the total sales for Anna. We can see we're still gonna get the total sales, the two orders. Same thing if I go to Carlos, to Diana, and as well to our manager Bob. So by looking to this, our dimension now is playing the role of the salesperson. But now let's say that I would like now to switch the roles, and I would like to see the total sales for the whole team, for the managers. So that means we have to switch roles for this dimension, and we can do that by using the other relationship, the manager one. Of course, we can do that using DAX. And now the dimension employee is playing this role. So if I go to Bob, I will not see the sales of Bob. I'm gonna see the sales of the whole team. Same thing if I go to the other manager, I'm gonna see as well the sales of the whole team. Now if I go to Anna, Carlos, Diana, I will not see anything because they are not managers. They don't have teams. So as you can see, I'm using the same table but from two different perspectives. One as a salesperson and another one as a manager. Now imagine you have a third role. All what you have to do is to go and create a new relationship between those two tables, and you use that relationship in order to play another role for this dimension. So that's why, my friends, we call the dimension employee is a role-playing dimension. It is just a dimension that is playing different roles for the same fact table by using multiple relationships to it and only using one active relationship at a time. And of course, we switch roles by using DAX function called the use relationship. So this is what we mean with the role-playing dimension. Now let's go to Power BI and see how we're gonna do that. Okay, so as usual, we're gonna go and connect our dimensions. This time we're gonna go and get to the managers and as well the salespersons. So this one over here. Load. Now at the start, if you are not investigating about those new dimensions, you're gonna see, okay, we have here a manager ID, so I'm gonna go and connect it with the fact. Looks good, one to many, so I'm not hurting the star schema. Same thing for the salespersons. I have an ID for it in the fact, so I'm gonna go and connect it as well, one to many. So at the start, things looks healthy, right? But now if you go and investigate the data itself, you're gonna see that the dimension manager has like an ID, name, email, team, and it's gonna look identical to the salesperson. We have as well ID, name, email, team, and so on. So this is gonna be like an indicator for you to say, you know what, let's go and make from this role-playing dimension. So of course now the question is, how are we gonna merge those two into one dimension? As usual, we have to do transformations using Power Query. So let's go to transform data. Okay, so now we are inside and we see here the manager and the person. Of course, in order to make a union between those two tables, we have to stack them. And for that, we have the append queries. We are not merging, so we are just like stacking the tables on top of each other's. But now if we do this immediately, we're gonna lose a very important information to understand where the data come from. So for example, here is Anna is a sales salesperson or a manager. That's why before we append, we have to go and add a column. That's gonna help us to understand the source of each row. So in order to add a new column, we're gonna go over here and say add column. We're gonna go and say custom column. So we're gonna give it a name. It's gonna be the role. And now we have to define what is the value for each row. This is gonna be a static value. So we will not go and select any other available columns. It's gonna be always the same static value, the salesperson. So actually that's it. This is the column name and this is the static value. Let's go and say okay. And now with this, we can see for each row, we have the same value, salesperson. Now we have to go and do the same thing for the managers so that we don't lose this important information. Again, a custom column, it's gonna be the role and a static value. So you're gonna be the manager. That's it. Let's go and hit okay. Look at this. We have for each person now the role of manager. Okay, so with this, we prepare the 2 dimensions now to get appended. I'm gonna go to the salesperson, then home, and we're gonna go and say append. So we are appending 2 tables. Append to the table manager. All right, now look at this. Each person has the role of manager. So with this, we have now the role for the 2 tables. The last thing that we're gonna do is that before we append, we have to make sure that all column names are the same. So here we have name, email, team, and so on. The only difference is actually the ID. So what we're gonna do is that we're gonna go and rename it. So instead of salesperson ID, it's gonna be an ID. And same thing for the managers. We're gonna go and rename it to ID. So as you can see, I'm trying to bring those 2 tables to become really identical. Only after preparation, we go and merge the 2 dimensions into one. And now we are ready. So I'm going to go to the salesperson. And from here, I'm going to go and append the second table, the manager. All right, we are appending 2 tables. The second table is going to be the dimension manager. Let's go and hit OK. Look at this. The main thing that we are not getting any nulls, which is perfect. So we have here now 10 persons, the names, the email, the team, and very important, of course, the role. Now, the last step that we're going to do is that we're going to go and rename this because this is not anymore the salesperson. This is a generic one, the role playing dimension. So I'm going to go and call it dem employee. And of course, we don't need the manager, so I'm going to go and disable it. Don't enable load, so that we don't see it in our model. Okay, so this is our role-playing dimension. Let's go and save and close everything. Now look at this. We got only 1 dimension for the employee and not 2. And of course, now comes the very important question, how to connect the role-playing dimension to our facts. So again, we have 2 roles, that means 2 relationships. The first one, I think it is working. So we have between the salesperson from the fact and the ID, and this is an active one, but we need the second one. So what we're gonna do, we're gonna grab the ID and now put it on the manager ID. So yes, this is 1-to-many relationship, but of course we cannot activate it because we have already 1 active relationship to our facts. So look at this. This is exactly the role-playing dimension. You have 2 relationships. One of them is active and the other is inactive. All right, so with this, we are done with the data modeling. Now, of course, comes the big question, how are we going to go and use those 2 relationships at the same time? So let's go to the report view in order to make an example. At the start, let's go and see the total sales for each employee. So we're going to go grab the name, the role, and of course, we need the total sales, and that means we're going to go to the fact table and grab the line total and drop it over here. Now, of course, the question is, which relationship did Power BI uses in order to connect the employee and the sales? This is, my friends, the active one. So that means it is connecting the ID with the salesperson and not the manager ID. Manager ID is inactive. And with this, we got a really nice total sales for each person. So far, nothing crazy, right? This is like the default setup in Power BI, but now of course comes the question, how are we gonna show side by side as well the total sales for each team, not for each individual person? So that means I would like to see the line total, but using the relationship manager ID to the dimension employee. Now, of course, in order to do that, we have to go and create an extra calculation in the fact in order to use this relationship. So we're gonna go and write a DAX. So how to do it? Right click on the fact and say new measure. And then we get here a new window in order to write the calculation. I'm going to go and expand it. So now we can do it step by step. It is not that hard. So first of all, I'm going to call it sales by team. So this is the name of the new field. So now, of course, the question is what we are calculating. We are aggregating the line of total. So very simple. We're going to say sum, and then we're going to go and find the table, so it's going to be the fact sales, and we are searching for line total. So with this, you're going to get the total sales, but of course, if you leave it like this, then you're going to get the same effect like before. Power BI going to go and use the active relationship between the fact and the dimension, but no, we don't want that. We want Power BI to use the inactive relationship, and for that, we have the nice function, use relationship, so that I force Power BI to use it the way that I want. So here we just have to define the keys between the two tables. So it is between the fact sales, and this time we need the manager ID, and the manager ID goes to the dimension employee, and here we have only the ID. So it is very simple. We are just saying, okay, go and calculate the total sales, but use the relationship. Then we define the keys, so the manager ID to the employee ID. Now let's go and get out. Now look at this. We have new extra column inside our fact called sales by team. It has as well this calculation icon because we just calculated. It has as well this calculation item, means we are calculating this column. And now by looking to this, you have now the two options. Either you want the total sales using the active relationship by just dragging the line total like we have done at the start, or if you want the same measure but using another inactive relationship, we're gonna go and grab our calculation and put it in the visual. Look at this. I'm able now to see everything side by side. I can see over here, for example, Bob. You can see in one go his total sales as a salesperson and the total sales as a manager for his whole team. Now for Anna, of course, she has no team, so that's why we don't see any number. For the other managers, they are not making any sales, that's why you're gonna see here nulls, but you're gonna see their total sales for their teams. As you can see, my friends, in one go, in one visual, we are able to use multiple relationships between the two tables, the fact and the dimension. And this is exactly the power of the role-playing dimension. I don't have here like 2, 3, 4 tables. I have everything in one table, in one go. And in the future, if I got like an access to another role, I'm gonna go and integrate it inside the employee table so that I reduce the number of dimensions around the fact. And I'm gonna be very flexible using the relationship in order to do the aggregations. Okay, so now let's do a quick recap. Role-playing dimension, it is one dimension that plays multiple roles in the same fact. You're gonna use it when you see you have multiple entities that have the same structure, the same schema, and you're gonna have the fact that is pointing using multiple IDs to the same entity. Alright friends, so now finally we're gonna start talking about a concept that is not that easy, the fact tables. This one confuses a lot of people and I think it gets people lost in data modeling once they start working with facts. But the good news is that there is like one trick, one very simple concept. If you understand it, then suddenly working with fact tables gonna feel easy. And here I'm talking about understanding the grain in the facts. So now of course the big question is, what is a grain? The grain is the level of details that one row in your fact table represents. So now, of course, in order to understand what this exactly means, we can have a very simple example. Alright, so in this example, we have 3 fact tables. And at the start, if you look at this inside your data model, you're gonna get the feeling they are all like the same. The total number of sales is like identical, and we are speaking about the same business. So they are very similar fact tables. But now, my friends, if you zoom in and start looking to the details, you're gonna understand those 3 fact tables are completely different from each other's. And that's because of one thing, the grain is different. Each table has different level of details. Okay, let me show you what I mean. Let's start with the first table. So here we have the fact sales. Now you have to ask this question, what does one row in this table represent? So we have to try to explain it in one sentence. So now you can see that this one row is actually part of like one order. So here we can see that we ordered 3 products in the same order number, right? That means each row is representing one line of one order. And this is, my friend, the grain of this fact table. Each row represents a line. Same thing here, for example, in this order, the one row representing one line of order. So this is the grain for the first table. Let's go to the second one. Again, we have to ask the same question. What does one row represent? Now, if you go and pick one row and say it loud, each row here is representing the whole order. It doesn't matter how many products did we order. It could be 1 product, 10 products, facts, it's still gonna be only one row. So my friends, the grain in this fact table gonna be the whole order. It is not anymore like detailed like the fact sales, right? So it has like less details than the first facts. Same thing if I go to another row, like for example over here, this one is representing the order. But if I go to the other fact, you can see it contains two products. This is the grain of this table. Now let's go to the last one. Same thing, ask the same question. What does one row represent in this fact? Now if you go and check each row, you can see we don't have anymore the orders. Like each row is representing 1 month. We have January, February and March. So that means each row here is representing a month of sales, right? So the grain for this fact table gonna be the month. Of course here it is highly aggregated compared to the other facts. Other facts contains more details. So that means, my friends, although 3 facts have different grains and different level of details. The first one, fact sales, is the most detailed one. One row represents 1 line of order. And in the second fact, we are losing those details. So the fact order, the grain here is the whole order. And the third fact, sales monthly, the level of detail here is really low. So we have here high aggregation. And the grain here is month of sales. We don't see any details about the orders or the line of orders. So this is what we mean with the grain. It is not that hard, right?
That's what she said.
And from now on, each time you see a fact table in your model, you can ask this one simple question and you're gonna say it loud. What does each row represent in my facts? And once you answer this question, then everything gonna be simple for you. You're gonna understand your fact. You're gonna understand how to connect it inside your data model. But what is way more important, you're gonna write correct DAX calculations on top of your fact. So my friends, understanding the grain is the first thing that you're gonna do once you start data modeling, and as well once you understand it, then you have really solid foundations. Otherwise, things might go wrong. So now let me show you an example why exactly it is critical for calculations. Okay, again, here we have one fact table, the sales, and it looks simple, right? And now if I go and start asking you business questions for this fact, and you jump immediately to the calculations without understanding the grain of this fact, you might start doing wrong calculations. Like for example, if I tell you, go and find the total number of orders. Now you might say, okay, this is really simple. I'm gonna go and count the order IDs inside the fact. And you tell me, okay, we have 6 orders in the table. My friend, that was really quick. Look again, do we have really 6 orders? Well, no, right? We have here only 3 orders. So my friends, without like taking step back and understanding the grain of your fact table, even if it's like simple like this, you're gonna do wrong calculations. So what one row represent in this fact, it is a line of order. So that means if I want to find the total number of orders in this very detailed fact table, I have to go and count the order ID, but using distinct counts. So I'm counting one ID only once. And with that, you're going to get 3 orders. Now, of course, in some calculations, you're going to be lucky. Like for example, if you go over here and I tell you, find the total sales inside our business, you're going to go and make the sum of this column and you're going to get it correct. All right, so now let's move to the third one. This is going to be a tricky one. If I ask you to find the total costs of shipping, if you don't understand the grains, you're going to go immediately to the shipping and say, okay, the sum of all those values, and this is wrong, my friends, because look at this, the same cost is like repeating for each line, right? And this of course makes sense because the cost of shipping gonna be for the whole order, right? For all products. So that means if you go blindly and start like aggregating all those values and you tell me, okay, the total cost of shipping is 450, this is wrong. You still have to be careful with the grain, and it is way more correct if you say, okay, I'm gonna go and find the highest shipping cost in the whole order. In case we got like wrong numbers or different pricing, you're gonna go with the highest one, and with that the total cost of shipping is 200. And here comes really something important to understand, that in one table we have different columns with different grains, and the grain of the line of sales is actually the line of order and not the whole order. And if you go and compare it to the shipping, here we have different grain in this column. It is again the order itself and not the line of order. So that means not only you have to understand what each one row is representing, but as well you have to understand your numbers at which level they are. It could be at the same level as the table itself, like the line of sales, or it could be a different aggregated grain like we had in the shipping and the order ID. So my friends, as you can see, even with a very simple fact table, you might do wrong calculations if you don't understand the grain of your table and as well the grain of each column. Otherwise, you're gonna be delivering wrong numbers to the business and they might do wrong decisions. Alright friends, so now we come to the most confusing topic in data modeling, how to work with multiple facts. Here I can tell you from my projects, I saw a lot of weird things, a lot of mistakes that happens in data modeling once you start working with facts. So what happened is that people see like two facts and they might notice, okay, they are sharing a common column, and usually comes the idea, why not to go and build a relationship between them? I would like to combine those two. Maybe others gonna say, you know what, so let's go and merge those two facts together, or maybe go and append those two facts. So you have different opinions and different designs, and at the end all what you want to do is, I would like to do some analysis like colorations in order to compare the numbers between those two facts. So at the start this sounds smart, but once you start like combining, building relationships, you're gonna understand this is gonna be the main mistake that you do in data modeling that gonna generate a lot of issues and wrong numbers in the reports. And this is exactly what we're gonna do now. I'm gonna show you multiple scenarios, multiple fact tables, show you the bad data modeling design, and of course I'm gonna show you the solutions, the best practices. So now let's get started. Alright, so now let's start with this very simple scenario. We have two fact tables, fact sales US and fact sales EU. Now before we do anything we have to understand those two facts, and we start with the very important question, what is the grain? What each row is representing? On the left side, each row is actually representing one order. So we have 1, 2, 3, 4. If you go to the right side, it is the same thing. Each row is representing actually an order as well. So this is the first thing that we understood from those two facts. They have the same grain. It is the order. So this is the first thing that we have understood. Now the second thing is to check what we are talking about inside each table. What is the event? On the left side you can see the event is actually sales is happening. So we have an order ID, customer, a product, and the total amount of sales. So it is an event about the sales. Now let's go and check the right side. Well, it is the same event as well. Sales are happening here. Order ID, customer, product, and total amount of sales. So that means those two fact tables are actually not only having the same grain, but as well they are identical. They are talking about the same event. They have as well the same structure, the same shape. They are just splitted into two tables. And this happens a lot in real world because source systems usually tend to split things into multiple tables. So here they split by the region, by countries, maybe by dates as well. Very classical one, they split tables by years. But at the end, it is the same table, but it's split into multiple tables in order to make things more manageable, or maybe for security reasons. So now this is the setup, and now of course the big question is, if I want to go and build a report where I need data from the left and from the right. So what we're going to do in the data modeling in order to build this visual, either you're going to go and build a relationship, or you're going to go and combine those two tables into one by using merge or append. So you have to decide on what to do with those two facts inside the data model. Now let's start with the first one about the relationships. It makes no sense to build a relationship between those two because they are identical tables, and usually we build a relationship between two different things like sales and customers, orders and products. So that means it makes no sense to build a relationship between those two facts. What is left is to go and combine them into one, and here we have the two options, merge or append. Now if you go and merge those two, it will not work because yes, you have a key like the order ID, but actually there is no match between them. Here they start with the 1001 and here they start with the 2000s. So if you merge those two, you will not get any result. What is way better is to go and append those two together. So you go and stack them on top of each other's, and with this you're gonna get all the orders inside your business. So with this you got all the 8 orders and things looks healthy, right? But there is like small mistake that we have in the module or in this one table. We don't know anymore which order comes from where. So we lost this small information in the table name. From here we can see the orders come from the US, and on the right side we can see they come from the EU. That's why in best practices, if you go and append two tables, go and create a new column, like for example here the source, in order to know where those sales come from. So with this, after combining the two facts into one, we will not lose any information. And now of course the last question is, can we use now this fact table in order to do aggregations? Well, yes. If you go and find the total amount of sales, you're gonna get a correct number. You will not get anything corrupted. So this, my friends, the best way to react on this scenario. If you have two tables having the same grain, having the same event, the same shape, so they are completely identical, go and append them together into one single fact. But of course, don't forget to add this new column in order to understand the source of each row. Okay, so that was an easy scenario. Now let's go to another one where we have as well two fact tables. This time we have the fact sales, and on the right side we have the fact revenue. Same thing, before we do anything we have to understand the content of those two facts. So what is the grain? On the left side, each row is representing one order. On the right side, same thing. Each row is representing as well one order. So again, we have two fact tables with the same grain. Now the second question, are they dealing with the same events? Well, on the left side, like the previous scenario, we are dealing with the sales. So we have an order ID, customer, and the total sales. But now on the right side, this time we have different events. Yes, we have the order ID, but we are talking about the source of the revenue and as well the total number of the revenue. So this is the setup. We have the same grain, we have different events, but we are talking about the same thing, about the orders. Now, of course, same question, what we're gonna do if we need to build a report and we need informations from those two fact sales? Are we gonna go connect them using a relationship or go and combine them into one fact using merge or append? So now let's start with the relationship. If you go and connect them, you're gonna get the cardinality 1-to-1. Well, usually if we have 1-to-1 relationship, it makes no sense to keep them splitted. It's way better if you just combine them into one table. But of course, always under one condition, if they have the same grain. So what are the other options? We're gonna go and combine those two fact tables into one single fact. Here we have two options, either append or merge. Now, I found a lot of projects where they go and actually append those two facts together. So they look like almost similar, those two fact tables. You have an ID, you have maybe something that is describing the ID, and then the measure, the total sales. So they are not identical, but they have the same pattern. That's why they go and like append them together. So if you look at this, you're gonna say, wow, this looks nice, right? I have all the orders here, I have the measures, and I can see the grain, so the measure type that I have in the amount. So things looks clean, and with this, I can go and do multiple like analysis, and I have some dynamic. Well, you can go and do that, of course, but you have to be very careful each time you use this fact table. Like for example, if you don't explain this for the others and someone goes and start like doing a sum of the amount, they're gonna go and get like 3,500, and this makes no sense because here those numbers, they have different meanings for each row. In one row this number is sales, but in another row this number is revenue. So if you go blindly and do a total sales on this fact or maybe an average for the sales, you're gonna get of course wrong numbers in the reports, and you have always to be careful that you do the aggregations based on the grain, and this of course makes everything complicated and open the door for many mistakes. That's why I never recommend to append it like this. Instead, we go and merge them. So you're gonna say, you know what, they are sharing one-to-one relationship. I'm gonna go and just put everything side by side. So I have the order ID, I have the customer, the source, the sales, and the revenue. And with that, my measures are actually not mixing together, and it's still very easy to analyze. Like for example, if I need to find the total sales, I'm just gonna go to this column over here and find the total sales. Same thing for the revenue. So yes, I have wider table and I have more columns inside my data model, but doing aggregations and stuff on the fact, it is way easier and safe compared to the append. So my friends, in this scenario, if you have two fact tables that have the same grain like this, they have one-to-one relationships, they are not identical, so they have like different events or different columns, then just go and combine them, merge them together into one single fact table, and don't use append if they are not exactly identical. Okay, so let's keep moving now to the third scenario. Things gonna get a little bit more advanced. So again, we have two fact tables, the fact sales and the fact budget. We have to start with the first question. What is the grain? So what each row is representing in each fact? You can see that in the fact sales is actually each row is one order. So it is very simple. But now if you go to the fact budget, you can see that each row is actually a month. It is the planned budget for specific product in a month. So for example, for the product laptop, we can see that in January we have so much budget, and for February we have another planned budget for it. So that means, my friend, the grain is different between those two tables. They have completely different level of details. And now the next question, are we talking about the same events, the same structure? Well, they are totally different from each other's. The fact sales, here the event is sales is happening, but on the right side planning is happening. So for each month, for each product, we have a planned budget. As well, the structure, it is totally different. Here we don't have any IDs. On the left side we have an order ID. So those two fact tables, they are completely different. They don't have the same events, They are not sharing the grain, they are not sharing the event or the structure. And now, of course, the question is, if a business user asks you to go and compare the sales versus the budget by the product, so you need data from those two facts into one visual, what you have to do. So again, we have the same options. Either we're going to build a relationship between them or merge those two facts together into one single fact. So now let's start with combining everything together. Here you have the two options, either append or merge. Well, it makes no sense to append. Please don't do that unless they are totally identical and they have the same grain. But now a mistake that might happen is that you can see, you know what, we have a product on the left side and a product on the right side. Actually, we can go and merge them together using this key. So if you go and do that, you're going to get something like this. So you have the order ID, you have the month, you have all the products, and then you have the two measures, the sales and the budget. So with this, you have everything like side by side and you can go and compare them, right? But my friends, those numbers gonna make no sense at all once you start aggregating. So if you go and give this to your business users, they're gonna say, well, actually, we didn't plan so much budget. We don't have like 9,000. We have planned only 6K. So actually, your numbers are wrong and Power BI has maybe an issue. You're gonna go to your data model and check, well, actually, we have correct numbers. We don't have like wrong data inside Power BI. It's only the decision that you have made to merge those two together into one table. Because my friend, the relationship between those two fact tables are actually many to many. Like for example, on the left side, the laptop, if you combine it with the budget, you're gonna get actually two planned budget for this product. So you get the January and February, and you're gonna have them as two rows inside the new table. And same thing, for example, for the order number 3 as well, it's gonna connect to two planned budget, the January and February. So with this, you're gonna get the same budget inside the combined table twice, one for the first order and another one for the second order. And of course, this is really bad. If you combine two tables that has many to many relationship, it will just cause duplicates in the new combined table. So no, you cannot go and combine those two tables together. They don't have a key between them and they have different grains. So what are the other options? Well, actually, we can go and build a relationship between them, right? So you're gonna start something like this. You're gonna leave them separated so we don't merge. And you're gonna start picking maybe the product ID from the fact sales in order to build the visual. And then put the sales for each product. So everything so far is clean, right? Now, what is missing is, of course, the budget. So what you're gonna do, you're gonna go and relate those two tables together using the product. Again, you see here the many to many relationship between those two. And then you're gonna go and grab the budget and you put it on the visual. So now, if you go and give this as well to the users, they can as well see bad numbers in the visual. They're gonna say, okay, from one side you are getting the total sales correct, not like the previous one as you merged the two tables. But my friend, that total budget makes no sense. We didn't plan so much. So again, your report is wrong, your data is wrong, and they will not trust it. So again, you're gonna go back to the data model and you start adding those numbers. Well, it makes no sense. The data is correct. It's all because you are connecting directly two fact tables together, and this can only cause issues. From one hand, you are totally depending on the products from the fact sales. And this is a big issue because in the fact sales, you're going to see only the products where sales happens. But maybe on the budget, you are planning for the future. So you have a new product and you have a budget for it, but no orders yet happen to this new product. So for example, here, the monitor, we have a budget for it, but still we don't have any sales for it. Now, of course, this product now is missing from the report because you are building the access for the visual based on the products from the fact sales. So that means you cannot count on the products from the fact sales. Same thing if you say, you know what, let's go and use the product on the right side as well. You will not get the full big picture. Like for example, here the mouse, we have an order for it, but we don't have a planned budget for it. So it doesn't matter where you start building the visual, it will not work if you are connecting two facts together. And as well, same thing, since we have many to many relationship, we're gonna get this effect where the budget gonna fan out and you're gonna get here duplicates inside your visual. And this is of course what is causing the big number on the budget. So actually, my friends, we cannot append, we cannot combine, we cannot build a relationship between those two facts. We have only one solution to make this clean, and that's by introducing something else. So what we're gonna do, we're gonna get rid of this bad relationship between those two facts, and we're gonna introduce a new dimension in the middle. So now you're gonna hear a lot of different names about this dimension here in the middle. Some people call it a shared dimension, others call it confirmed dimension, or you might hear about the bridge table between two fact tables. You can call it whatever you want. At the end, it is the same concept. We're gonna build one dimension where it has the single point of truth. So it is complete and it has all the products in the business. So here should be nothing missing. We have the laptop, we have the phone, we have the monitor, and as well we have the mouse. So all the products in the business. And after that, we connect our facts to this single dimension. And if you do it like this, on one side, you're going to get many-to-one relationship between the sales and the dimension. And same thing on the other side, between the budget and the dimension, you're going to get one-to-many. And now once you start building the visual, things going to be way easy. For the axis, you start always from the dimension in order to make sure that all the products are inside my visual. So I have all my 4 products and the measure is going to come from each fact. So the total sales going to come from the fact sales and the budget going to come from the budget. So with this, first of all, you make sure that nothing is missing, right? So we have here the monitor. We don't have sales for it, but we have a budget for it. And we have as well the mouse where we have a total sales for it, but no budget. So with this, I'm getting completeness in my visual. Nothing is missing. And as well, the number is going to be correct. There is no more fan out effect like for the laptop. Things are connecting to my dimension using the many-to-one relationship, and this will not cause any duplicate effect in the visual. So this solution is a clear win for me. I have the complete picture, nothing is missing, and as well, my numbers are correct. My friends, if you see 2 fact tables, 2 tables that they have different grains, then you have to be very careful. You might see things that could be related to each other's or could be combined. Otherwise, you're going to deliver only wrong numbers. Leave them separated and connect things only using a shared dimension. Okay, so now to the last scenario. This one going to be a little bit tricky, so I need your full focus. This is advanced. Again, we have 2 fact tables. So we have the sales, we have the budget. We will not go through everything. They have different grains, they have different events. But the thing is, they don't connect using the products. They connect only using a higher level. So we have the category. So this is a setup, and now the business user has the same question. I would like you to go and compare sales versus budget, but by the product. So again, if you go and build a direct relationship between those two, you're gonna get, of course, a wrong budget. We said you don't do that. So instead, what we're gonna do, we're gonna go and introduce the shared dimension in between. And the shared dimension this time gonna be the category, because they are not sharing products, right? They are sharing category. And after that, you go and connect your facts to the new dimension category. Now, the thing is, we're gonna still have an issue in the visual, even if we introduce the shared dimension in between, because the user is asking us to compare those 2 measures by the products. And the products, my friends, it's not an information that exists in the budget, right? The budget knows only about the categories, and the categories, as I said, it is a higher aggregated level than the products. So that means with the products and the fact sales, we have more details than the budget. And here we have very important rule to understand. We can show a measure only at the grain that it was recorded at, or a higher level, so more summarized. So that means we can never show the measure at a lower level than the grain that is recorded at. Like for example, the budget was only recorded at the category level, so we can show only the numbers at this level, or we can roll up if we remove the categories in order to have the total budget, but we never can go down that. We cannot go to the budget by the products because it is not recorded at this level. And if you use any tool, it's gonna go only and fake the numbers. It will not work. So the rule is very simple. If you have 2 fact tables, you can compare them only at the highest level they share. So that means if you want to do really this comparison, we have to do it at the category level. So yes, we compare the sales versus budget, but by the category. And don't misunderstand me, if you want to build a visual only for the fact sales, of course you can go and use the products. But we are talking only about connecting 2 facts into one visual. Here you have to be careful which one is the highest, and only that you can use. I know this one was an advanced one, but once you know those rules, then everything gonna be simple. Back to Power BI to practice. Again, we are at our data model. So far, we have only dimensions around one fact, the fact sales. Now, what we're gonna do, we're gonna go and grab another fact to the data model, and we're gonna go and connect it. So get a new data, CSV, and this time we're gonna go and connect the fact budget. So let's go and do this. Okay, so go and load it. Alright, so with this we got our new fact inside our model, and the thing is, I'm gonna go and remove the relationship that Power BI automatically created between this fact and other things. So let's go and remove it, because now we are dealing with the facts and we have to be careful. So first we have to understand our facts, not only the budget, but as well the fact sales. Now, in order in Power BI to understand the grains and all those stuff, we're gonna go to other tab. So we're gonna go to the table view, and let's go to the fact sales. And now, of course, we're going to ask the classical question, what each row here is representing. So we can see that the order ID 1001, we can see it twice. So we have two rows for the same ID. So a row is not representing the whole order. A row is a line of order. This is a really detailed one. Now let's go and check the budget. So now look at this. This is highly aggregated. So each row is representing actually a month, the planned budget and the planned quantity for each product for 1 month. The fact sales has a lot of details and the fact budget is highly aggregated. That means those two facts have different grains, and of course we cannot go and combine them. And of course we will not relate them directly to each other's just because we have here a product ID, and as well in the budget we have a product ID. So we will not do this where we're gonna grab the product ID from the fact budget to the fact sales. Look at this. Power BI says many-to-many relationship, and as well we are getting here like a warning from Power BI says this is many-to-many. Both of the product IDs are not containing unique values, and it's like be careful of this behavior. So if I go and save it, we are doing now bad practices by connecting the fact tables together. So my friends, we will not do that. So we're gonna remove it. Instead, we need a dimension in between, a bridge, a conform dimension, and this is gonna be our friend, the dimension product. So let's go and grab it over here and just put it nicely between those two facts. So you can see it is already connected to the fact sales, so we don't have to deal with this side, but we have to go and connect it to the fact budget. So grab the product ID and put it on the dimension product. Look at this, looks nice. We have many-to-one relationship. That's because the product ID in the dimension product is unique. So looks good. Let's go and save it. And actually that's it. Look at this. We have a nice shared dimension between two facts. So one-to-many relationship and many-to-one. And this dimension is just like shared between those two facts. So this is how we connect two facts together. And now we can go and use the values of those two facts inside our visuals and reports. Let's go and try this out. Now, as we learned, in order to build a visual, we always start from the shared dimension, which is the dimension products. So it is over here. I'm going to go and pick the product name, and only then you start picking the measures from the facts. So now let's go and grab, let's say, the total sales from the fact sales. So I'm going to go and drop it here. So this is the first fact. Now let's go and compare it by another measure from another fact, the budget. So we're going to go and grab the budget sales and drop it on the view. Look at this. Everything is working, and now I'm able to do sales versus budget analysis. Now, of course, in order to test whether you are missing any numbers, what we can do is that you can just go and duplicate this view like twice, one left, one right. And now we can make one view dedicated only for one fact. So that means I'm going to go over here and remove the budget. This is going to be only for the sales. And if the numbers are exactly the same as the combined one over here, then everything is healthy. Same thing on the right side. This time, this is going to be dedicated only for one fact, the budget. So that means I'm going to go and remove any value from the other facts. Now, look at this. The total budget is exactly like the combined one. And this means everything is working perfectly. So this is how I test if I'm combining two facts tables together. You make one dedicated view for each and see whether the numbers are matching. And now, of course, you can go and check other stuff like by grabbing other measures to our view and see whether everything working fine. And now, one more thing that we could practice is that we could actually connect multiple dimensions as a shared dimension. So it must not be always like only one. We can go and add more. So that means if we go and check the facts and see something in common. So here we have the month of the budget. So this is a date. And now if we go to the fact sales, we can see as well, let's say the order date. This is not a month, but as well, it is a date, and we could like use a shared dimension called a dimension date in between. Let me show you how to do it. So let's go back to the model view. Now, of course, we need a dimension date. We don't have it yet inside our model. We're going to go and connect something new. So over here, you can see we have a dimension date. Let's go and load it, and let's go and hit load. All right. So with this, we got a new dimension, and I'm going to put it just in between those two facts. Now, of course, in order to make a shared dimension, we have to go and connect both facts to this new dimension. So for example, let's go and grab the order date and connect it to the date inside the dimension. So as you can see, they are using the same informations and we have many-to-one relationship. So perfect. Let's save it. So this is one side. Now let's go and connect the other side. So budget month, it goes as well to the same key to the date. Same story. We have here many-to-one relationship, which is active. And this is nice. So now with this, we have two shared dimensions between our two facts. And this, of course, opened the door door for more analytics between the two measures inside the different facts. Now we can compare things by the date. Let's go and try this out to the report view. As usual, we start with the dimension. So the new one is the dimension date. Let's go and drop it in the visual. Now here, very important to understand the level of details, the grains. You can see the dimension is based on the days. So for each day, we have one row. So we have to keep this in our mind. Now let's go and grab the measures. It's going to be again, the total sales. Now look at this and understand. We have for few days a total sales. So in January, we have 2 sales. And in February, we have 2 days of sales. With this, we can understand that the level of details of the dates inside the fact sales is as well the day. And you can check as well that in the table view. You can see the order date always include like a day. So far, everything is matching. Now let's go to the budget. We need as well the planned budget for the sales and drop it on the same view. Now, the first thing that we have to check is, of course, the total. So the total budget is matching over here, and as well for the sales. We don't have to worry about now wrong numbers. But now if you look to the table over here, you can see there is something weird, right? You can see that the numbers are not really side by side. There is like some shifting. Now, if you look closer to the budget, you can see it's always at the first day of the month. So the 1st of January, the 1st of February, and so on. So we see a budget only on the first day. And for the total sales, we see it in different days. Sometimes the 5th, sometimes 12th, 3rd, and so on. So we are not really able to compare the two measures side by side. And this is, my friends, because we have different level of details and grain for the budget. So we can go and check this over here. Let's switch to the fact budget. We see it like the 1st of January. This is only the format, but the level here is a month and not a day. And what we have learned before, if you have different level of details, if you have different grains, you have always to work on the highest level. Otherwise, your chart kind of looks exactly weird like this. So in order to compare now the budget and the total sales, we have to bring them together at the same level where both of them can understand the level. And this is, my friend, not the day, this is the month. That's why I'm gonna go to the date over here and just get rid of the day. And with this, we have like a roll up to the month. And look at this, now we see things side by side. So the budget is near the total sales. And that's because both of the fact tables can work at the same level at the month. And now things are more healthy and we can go and compare the two measures side by side. As you can see, my friends, not only you have to build a healthy data model, you have as well to understand the grain of everything, the grain of the dimensions, the grain of the facts. Without that, you're gonna build weird reports, and in the worst case, you will be reporting wrong numbers. So now let's recap. So if two fact tables have the same grain, the same fact, the same structure, the same event, then go and just append those two facts together. But if you have a scenario where the two facts, yes, have the same grain, but they have different shapes, and you can build a one-to-one relationship between those two facts, then just go and combine them into one fact by merging them together. But now in the other scenario, if they have different grains, different shapes, different events, never combine those two facts, and as well never relate them directly to each other's. Always build in between a shared or bridge a dimension and connect your facts to it. And at the visual level, if you are comparing two facts, only work at the level that both facts understand. So always pick the highest level that both facts can understand. So my friends, once you understand those rules, then it's going to be really easy to work with facts in data modeling. Alright friends, now we're going to talk about something really important for data modeling and as well for real projects, the security. The thing is, in real projects, it is not enough to have a model that gives correct numbers, but also you have to control who is allowed to see which data. So that means we have to make it secure, and this is deeply connected into data modeling. If you have clean data model, then it's going to be really easy to implement the security requirement and it's going to be safe. But if you have a data model that is messy, chaotic, the security is going to be really hard to implement and your data gonna leak to the wrong users. And this is exactly what we're gonna do now, and we start as usual with the foundations. So what is security in data modeling? Let's go. Okay, so we have a table, and by default this table has no security. So that means if we are building a report on top of it, everyone, all the users, gonna be able to see all the data of this table. But now let's say that we are a real project and we have to go and apply security on top of this table. Here we're gonna have like 3 options. The first scenario, if the whole table is actually contains a lot lot of sensitive informations like the salaries, the contacts, the finance data, and some users are actually not allowed to access this table at all. So that means what we have to do in this scenario, we have to go and hide the whole table, everything, all the rows and all the columns. And for them, this table is basically doesn't exist. This is what we call the table level security. Now, the second scenario may be not that extreme, where you say, you know what, we have a table like employees, and it contains a lot of data that are actually not sensitive. But we have like 1-2 columns that are really sensitive, like for example, the salary. So we will not go and hide the whole table for the users. What we can do, we can go and protect and hide only one specific column. So that means the user is going to be able to see all the data, but only this column going to be hidden for them. This is what we call the column level security. Now to the third scenario, which is the most common one in many projects, where we can say actually the table is totally okay, all the columns are not sensitive, but now it is not allowed to show all the rows for all the users. Like for example, a salesperson can only see the region, or maybe the managers are allowed only to see their own departments. So that means the whole table can be visible, all the columns are allowed, but the users will not see all the rows. They are allowed to see only specific rows. And this is what we call the very famous row level security, and you're gonna hear a lot of people are saying RLS. So those are the 3 levels of security or hiding things in data modeling. The table level security, you want to hide the whole table. The column level security, you want to hide only specific sensitive columns. And the third one is the row level security, if you want to go and hide specific rows. Now, of course, the most common technique that is used almost in every project is the row level security. And this is exactly what we're gonna deep dive now. So we have to understand why and what. Let's go. Okay, so now we have this following setup where we have a table about the sales and a report in top of it. Now, this sales table gonna contain all the sales, so for all departments or regions. Now, the thing is, in companies, we have different people with different roles. Like, for example, we might have like a director that is actually allowed to see all the data. And we might have another person, like, for example, a manager that is allowed only to see the sales for specific departments. So that means not all the rows, only specific one. And we might have a third one. So we have a salesperson that is allowed only to see the data based on the region that is assigned to it, like maybe only Europe. So that means we have 3 different users with 3 different security requirements. Now, of course, because of this, you cannot go and just share the report with everyone. You have to be careful with the security requirements. Now, one of the ideas is to go and do this, where you're going to say, okay, I'm going to go and duplicate my report into 3 files. I'm going to build a filter specifically tailored for each role, and then start sharing those reports based on the role. So we are making like role-based reports. But of course, I think it's obvious this is a really bad solution, because you have the same report, the same work over and over, and all those duplicates is just because of one simple filter. And of course, if you want to change one thing, it's going to be a really nightmare. You have to go through all the files and start implementing the same change again and again. So this is going to be a really nightmare to maintain, and it will not work. Now we have a smarter and better solution at that. Instead of having all those duplicates, we're going to go back to one model and one report. But now what we're going to do, we're going to go and add a row level security component on top of the data model. And it is smart enough to let Power BI understand who is looking at the reports. And based on the information, based on the role, Power BI is going to go and filter the data model, especially for that person. And this is exactly the best solution, is to implement the row level security so that you stick with the one project without having you to duplicate things. Now, of course, the question is, how are we going to go and build this smart component in the data model, how this works and how to build it. Now, of course, implementing row level security depends on the tech stack that you are using. One solution that you might find rarely in projects, where they build a live connection between Power BI and the underneath like database or maybe like Databricks, and they decide to build the whole row level security in the backend. So they build the whole filtering logic in the database, and Power BI has only to go and pass the user information to the backend. And of course, the backend system gonna return only the rows the user is allowed to see. So that means the whole logic gonna be built outside of Power BI. And to be honest, this is something really complicated to do, because now you have 2 systems. The testing gonna be really hard, and we rarely use the live connection between Power BI and the backend system. Most of the times we import the data to Power BI. So that's why the second option is to go and build the row level security inside Power BI. And this is the most common option that we actually build and implement in real projects, and this is exactly what we're gonna learn. So now, how we're gonna build this RLS inside Power BI and how it works. So now we have again this setup where we have a table in the model, and this table has a column called region where you have the values US and EU. After that, we have a report, and then 3 users are using this report and accessing it. Now, if you leave it like this, then we don't have security. That means everyone is seeing everything. But now, if we cannot leave it like this and we have to go and implement the role level security, then of course we cannot go and build some random filters inside Power BI. We need more tools. So the first component or tool that we're going to use for role level security is the role, and it is a tool that we're going to use in order to filter the model. So it's very simple. It has a name and a value. Now the value could be either static or a DAX calculation if you have expression. Now if you decide for the static values, then you're going to have like 2 roles based on the regions, one for EU and another one for US. So this is the rule, and with this Power BI knows how to filter the data model based on the role. But that's not enough, of course, because Power BI is missing another important information, the mapping between the users and the role. Power BI doesn't know whether Maria has the role like US or EU, so we don't have yet this mapping. And for this you have 2 options. Either you're gonna leave it like this static, where you go and publish the report to Power BI service, and from there you start manually mapping which user belong to which role. And now with this, Power BI has everything, the 2 informations, the mapping between the user and the role, and the mapping between the role and the data model. So everything is linked. Now if a user like Maria go and access the reports, what's gonna happen? Power BI first has to go and check the role and say, she belongs to the role EU, and then go to the other mapping. Okay, the role EU has the static value EU, and after that it's gonna go to the data model and filter the data based on this static value. So with this, Maria gonna see only EU data. And this is, my friends, what we call the static role level security in Power BI. Now by looking into this, the role level security has actually 2 problems. The first issue, we are creating like a role for each value inside our data. So here we have like 2 values in the region, we have create 2 roles. But if the security concept is based like on another column and other values where you have 10 and 30, you have to go and create like 30 rules. And if you keep like getting new values, you have to go and keep expanding, and maybe you're gonna go and miss something. And the second issue, each time we get a new user, we have always to go to the Power BI service. We have to assign those new users to the different roles. To be honest, I have never done this in projects because I had like 3,000 users and I don't have the time to go and assign manually each user to each role. That's why we have another option where things are more dynamic, and we call it dynamic role level security, where we're gonna say we will not do those manual things, but instead we're gonna add a new table to the data model. This is a special table only for security, where it has 2 informations. Which user is allowed to see which region. So we're gonna see like information for each user, like Maria gonna see EU and so on. Now of course the big question is where this data come from. Now if you are unlucky, you have to go and create it manually. So you're gonna have your own Excel where you are mapping the users to the regions. Again, it is kind of manual work. Or if you are lucky enough, and this is something that really happens a lot in projects, where you're gonna find this kind of information stored somewhere in your source systems. And this is actually what I usually do. I go and load the security informations like any other tables inside my model. So with that, I don't have to map anything manually, and everything gonna be automatic. Now, so far we have just like table and data, and Power BI has no idea how to do the role level security yet. So now what do we want? We want just to connect the users to this security table, and we can do that by doing 2 steps. First, Power BI has to know who are the users that are looking at the reports, and for that we have a nice function called user principal name. It's gonna return the current user that is opening the reports, so usually gonna get the email address. So with this, Power BI knows, okay, who is looking at the reports. Now in order to map this value that is returned from this function to the security table, we have to go and create a role. But now of course we will not go and create a role for each value inside the table. We're gonna make things more dynamic by creating only 1 role, and we're gonna use some DAX calculation in order to just map the value from this function to the security table. So those are the components, and now let's understand what's gonna happen if Maria go and open the reports. Power BI gonna go and execute the function and understand, okay, who is that? It's gonna get the value, okay, Maria. Then Power BI gonna go to the role in order to understand how to filter and where to go with this information. Then it's gonna say, okay, we have to go and filter the security table. And this is very important to understand. It is filtering the security table and not going directly to the whole data model and filtering the tables. So that means only the security table gonna get filtered to Maria. And now what's gonna happen? This filter gonna travel to our data model. So it is very important to have a correct relationship between the security table and your data model. So this is how it works. This is the dynamic row level security. And now let's go and compare the static with the dynamic side by side. In the static RLS, we have to go and create multiple roles based on the values inside our tables. But for the dynamic RLS, we have usually to go and create only one role with a DAX calculation. Now for the static, the users are assigned to the roles inside the Power BI service. But for the dynamic, the users are mapped inside a security table inside the model in Power BI desktop. Now for the static, if the access change, we have to go and change the assignment in the Power BI service. But with the dynamic, if access change, we just change the data inside the security table. And here the recommendation is if you have like small projects, small data, and only few users, and then go and use the static because it is more straightforward and it is easier to implement. But if you have like more data, you have a lot of users, you have bigger projects, then the best practices says go and use the dynamic row level security. It is, yeah, at the start not that easy to build, but you are investing for the future, so things gonna be way faster and dynamic once you get a lot of users using your reports. And now based on this, we will be focusing on the dynamic row level security because it is the method that we usually implement in real projects at companies. So now, since this is a confusing topic and you have to pay attention to the filters and directions, we can have this very simple example where we have a fact table, fact sales, and 2 dimensions. And now we have to pay attention to the numbers. So here we have the total sales of 10K. We have 5 customers and 5 products. So a very classical star schema. Now, of course, anyone that is using this data model gonna see exactly those numbers. Nothing is filtered unless they go and make a filter slicer or something in order to interact with the report. But if they don't filter anything, they're gonna see the whole thing. Now, of course, we want to make this secure by implementing the dynamic RLS. And we start with the first step where we're gonna go and add a security table. Now, this table is just mapping between the email address of the users and their region. And we have a relationship between this security table to the fact sales since we have as well here the region. But now look at this, even if we have the security table, everyone is able to see the 10K. So adding a security table and build the relationship doesn't mean the data gonna get filtered automatically. For that, we have to go and add more steps, like for example, a rule where it's gonna check the user principal name. Now let's say that after adding the rule, we have a user called Alice, and she's gonna go and now open the report and start looking at the data. Now suddenly, she will not see the whole 10K as a default, she's gonna see only 4K, even without filtering any data in the report. And that's all because of the security role and as well the security table that is connected to our fact. But now you have to pay attention to this. You can see that she is able to see the 5 customers and the 5 products, and that's all because of the filter direction. We are not filtering from the fact to the dimension. It is the opposite, from dimension to fact. So that means it's gonna stop over here and will not carry out to the other dimensions. But now if you say, you know what, I would like as well to filter the dimension customers based on the security, then what you have to do is to just go and change the filter direction to both. Now look at this, the security table is filtering the fact and the fact is actually carrying the filter to the dimension customer. But with that, Alice is gonna see 4K and as well only 2 customers, not anymore the 5. But the dimension product is not affected because here we have one direction. But if you say, let's go and filter the whole data model, then as well you have to go and add like both. And with this, actually you are filtering the whole data model. So that means, my friend, you have to pay attention to the filter direction in the relationships because it's going to define the behavior of the security of the whole data model. If you do it wrong, then the whole security will not work, even if you have the best setup, like you have the roles, you have the table, but the relationship is wrong. Like for example, if you just switch it like this, where you say the filter direction is from the fact to the security, now what's going to happen? The user going to see the 10K because the data is not traveling from the security table to the fact. So whoever like go and look to the table, all of them gonna see the 10K. So that means the filter is not traveling. The whole setup gonna be wrong and you're gonna have like security leak. That's why the definition of the direction gonna be very critical topic. And now, for example, if you go and switch to Bob has different scenario where he is mapped to South America. And for that, we have like 2 orders. That means Bob can see only 3K, 2 customers and 2 products. Now, if you go to Carla, she has the region East, she can see only 3 orders, and she can see 3 customers, 3 products. Now, of course, something that might happen a lot where you have a user that is not actually inside your security table. What's gonna happen? This user will not see anything. They will see total sales of 0, no customers, no products. Since Dan has no record inside our security table, he will be completely blind and will not see anything. So this is exactly how the dynamic row level security works. And as you can see, it is something that is completely depending on the data model and how things are connected. That's why building the row level security, it is part of data modeling. If you do it wrong, then you will not be able to connect things nicely like now we are doing. So now back to our data model. Of course, here we have only star schema. So we have dimensions, facts connected to each other, but we don't have security. That means everyone gonna see everything. Now, how are we gonna do it? Of course, we have to do it step by step and we don't have to rush it. Now, I'm gonna show you how to do the static. It's very simple. So now the first step, we have to understand the security requirement in our project. So we cannot go and apply like some random filters on top of our data based on our like gut feeling. If you don't know about that, you have to ask your team, your departments, and usually there is like a security officer that understands those topics. Now, let's say after some discussions, I understood we have always to secure our data based on the regions. So this is a very important step because now I know my goal. I want to secure this data model based on the region and not based on the city or the country or some specific departments and so on. Now, the next step is that we have to understand where are the regions inside our data model. So that means I start going to the table view and start investigating all my dimensions and facts to understand where I can find the region informations. Now, for example, here we can see it in the dimension store. This is very good. And in other tables like the facts, the fact sales, we don't see this information. So that's I located the dimension store. This is going to be a very good starting point. So now that means based on the stores, I will be able to use it in order to secure the fact table in the middle. So with this, I know exactly my target tables, and this is very important in order to build the row level security. Now, the third step before I start doing anything, I'm going to go to the report view and then make like a special view only for testing. You have always to understand the big numbers of your data model and understand the behavior of the row level security on top of it. Otherwise, you don't know whether you have done things correctly or not, and you might have some security leaks, or maybe you are filtering unnecessary things. So I have to memorize it in my head. The total sales in the whole data set is 5,500, 5 customers, 6 products. So that means I know the numbers, I know which table is going to be affected and filtered, and I know how to build the roles. Now, since we are building the static one, you have always to understand the values. So as you can see here, the regions, we have 2. That means we need 2 roles. And those are the values that we're going to use in order to filter the data model. So Europe and USA, you have exactly to use those values as it is. So now how are we going to build it? We're going to go back to the model view. Now, in order to create the roles, we're going to go to the response over here and we have manage roles. It is very simple. We're going to go from left to right. So we're going to start by creating the roles. Now, the first one, we're going to go and create the role for EU, and another one, we're going to go and create the role of US. So now the next step, we have to tell Power BI which table must be filtered. And as we checked, the dimension store should be filtered because only here we have the region informations. Of course, if you have multiple tables, then go and select multiple tables. But now we have only one. And now the next step, we have to go and create the filter condition. And here we have 2 options. Either we're going to go and click around if we are creating the static one, or we're going to switch to DAX in order to create the dynamic RLS. But now we are creating only the static. So I'm going to go and say new rule. It's just a very simple filter condition. So we're going to go and select the column. It's going to be the region. And now the value, we're going to write it exactly like the value inside our data set. So since this is Europe, we're going to write it like this, and it is case sensitive. Now, if you just go and read it from left to right, we are creating a new role in order to filter the dimension store. And this is the filter condition. Region must be equal to Europe. So that's it. We have to go and do it again for the US. Yes, we are filtering the dimension store. And then we can go and create the condition. Same thing to the region. And now the value is going to be USA. So actually it is very easy. That's it. With that, we have created the 2 roles. And now we can go and save it. So that's it. And then go and close it. Now, of course, you might ask, okay, what happened now? Go to the report view and check. You can see nothing changed. So yes, we have created the roles, but Power BI is not filtering anything yet, because in order to do that, we have to go and publish the report to the Power BI service and then start assigning the different people to the different roles, and then it's gonna work. But now, of course, the question is, how are we gonna test it? Are we gonna go and create like a dummy user or go and ask someone to test for us? Well, of course, no, we have something smarter in Power BI. All what you have to do to test is just to go back to the model view, and then we have in the report as well something side side by side called view as. So it is very cool. We can go and view the report as a specific role. Like for example, I would like to view the report as the role EU. And this is of course very cool because now I can test the report as a person that has this specific role. So now let's go and do that and say okay. Now you're gonna see this nice warning. It says now viewing as the role EU. So very cool, but now of course in order to know whether this works, we have always to test by going back to the report view and look at this. So you can see in the fact we are seeing only the orders with the region Europe, not from USA. You can see as well the total sale did change. So that means, my friend, this role is working. Now let's go and test the opposite. So I'm going to say again, okay, view as, and then we're going to go and switch to US and then hit okay. Now it says viewing as role US. Let's go and test. Look at this. Now we are seeing the orders only from the region USA. So as you can see, it is working. And now as you might notice, the total products and the total customers, they are not changing. And that's all because of the star schema relationships that we have created. You can see the filter directions are always from the dimensions to the facts. So that means the filters will not reach the dimensions. Now, of course, if you want to test, we can go and try this out by going, for example, to the relationship between the fact sales and the dimension. Now, of course, we're going to go to the direction. Instead of single, we're going to go and switch it to both. Now here we have another option. It says apply security filter in both directions. Well, yes, this is exactly what we want. So that's it. Let's go and save. Now we can see the filter is in both directions. So the filtering should reach now the products. Let's go and test. Look at this. We moved from 6 products to 5 products. So that means not only the fact table is getting filtered by the role level security, but as well our dimension. So as you can see, my friends, this is the power of the relationships and the filter directions. We can control which tables must be secured based on the security requirements. So actually you have it. This is how we create a static role level security. Now, of course, let's move to that dynamic one. So now how are we going to do it? First of all, I'm going to go and remove all those stuff. So we don't need you. Same thing for you, and then reset everything back. Now, before I start creating any rules, we actually need a security table. So I need a mapping between a user and their regions. Now there is like 2 options for that. Again, either you load it from outside, or if it's like only few users, you can go and enter data for that. But for this, I have prepared something for you. So if you go and connect a new CSV, there is here a table called security. Let's go and connect it. So now look at this. We have user emails and their regions. Now you can see that the first row is actually not the header. So that's why I'm going to go and transform the data quickly. And all what you have to do is to just use first row as the headers. All right, this looks way nicer. Now let's go and close and apply. All right, so with this, we got our new security table. Of course, the next step, we have to go and connect it to our data model. So we're going to go through the dimensions. We're going to connect the regions by region. Okay, so now here we have like many-to-many relationship, which is totally fine. What is very important is the filter direction. So we have to pick this. The security filters the dimension store. This is very critical to do it correctly. Otherwise, it will not reach our data model. So actually that's it. Let's go and save it. Again, look at this. The arrow is moving from the security to the dimension, and the dimension is moving to the facts. This is a very important one. All right, so now if you go, of course, to the report view, you're going to see all the data. Power BI don't know yet how to use this security table. So nothing actually going to happen. That's why we're going to go back to the model view. And now, of course, comes to the magic. We're going to go and create a new role. So again, manage roles. This is not static. We are working on the dynamic. We will not go and create like a role for each region. It is enough to have only one. So let's go and create one. And let's go and call it regional access. Now, of course, the question is, which table should be filtered based on this role? It's again the same thing, the dimension store. And now since the dynamic, it is a little bit more advanced, we will not go and create here a new rule. It is not a simple filter. We're going to go and switch to DAX in order to write the filter expression for Power BI to understand how to filter the dimension. Okay, so now let's do it step by step. We just want to create the filter condition. And the first question is what we are actually filtering. We are filtering the regions inside the dimension store. So that means I'm going to go and write it like this. The region inside the dimension store should be equal to the following value. Now, if you are just creating like a static RLS, it's going to be like this. So equal to Europe or USA, but actually we will not do that. We want to make things dynamic. Now, the first thing that we have to decide is actually, we will not go and use the equal operator. We're going to go with the in. And that's because one user might have multiple regions. So that means we might have a list. And in order to filter using a list, we have to use an in operator, not an equal. Equal is only for one value. Now, the regions should be filtered based on the other table, the security. So that means we have to get the values of the security in the filter. and we can do that using the function calculate table. So we're going to tell here Power BI, go and grab the values from another table based on a filter. So that means we're going to go and use the values, and actually we need the security region. Perfect. With that, we are getting the regions from the security, but of course I don't need all the regions. I need only the regions of a specific user that is actually opening the reports. That's why we have to go and build a filter. And of course comes now the magic, the most important thing. We're going to say filter the emails inside the security, but based on the email of the person that is actually looking at the reports. And for that we have the very nice function user principal name. This function will just return the email address of the current user. So with that we will not get all the regions from the security, only for the one that is looking at the reports. And actually that's it. So now let's read it again. Filter the regions inside the dimension store based on the values of the security regions, but of course not all the regions, only for the regions that are equal to the email address of the current user. So this is exactly how we build a dynamic row level security. Now we can go and verify the docs. Looks good. We're gonna go and save it. And actually that's it. We have only one role, we are filtering one dimension, and we have a dynamic flexible expression. So let's go and close it. Now, of course we have to test. If you go to the report view, you can see nothing is changed. We still have all the orders. Of course the effect can happen once you publish to Power BI service. Again, we will not go and ask a user to test for us. We can test it directly in the desktop. So we just need like an email address to test. I'm going to go to the security and go and pick Maria. So I'm just go and copy the value. Now, in order to test, we're going to go to the model view and then view as. Now, again, we're going to go and activate the regional access and then say, okay. Now, as usual, we're going to see this warning. Now we are viewing as the regional access. Of course, we have to test. If you go to the report view, we will not see anything. Well, what is going on? Now, the thing is, Power BI is trying to get my email address that is currently looking to the report and try to filter the data based on that. And since I don't have my email address inside my data, this is just like fake one. I will not find any match over here, and it's gonna say, okay, you are not allowed to see anything. That's why I cannot see anything in the fact table, which is a good thing, of course. But in order to really test, this is not a bad effect. We're gonna go to the view as, and this time we're gonna say other user, not my user. So I would like to see the report as Maria is looking to the report. So we're going to go over here and put her email so that I'm going to see exactly how she can see the report and say, okay, now you can see now viewing as a regional access and the email address. So Maria, now let's go and test to the report view. Look at this. Now we can see only Europe data, and that's because Maria has access only to the region Europe. So this is perfect. Now let's go and test another user. So we're gonna say, okay, not Maria, this is gonna be John. And then, okay, you can see now we are viewing as John. Let's see what he can see. Well, John has access only to region USA. That's why the report is now showing only USA region. So this is exactly the dynamic. The report, the data model can be filtered exactly for specific user. And if the user doesn't exist, like the one that I had at the start, then the user will not see anything. Now let's go and test the fake one that we had. So I had another one called Baraa, which has, of course, all the access of all regions. Now we can see, okay, we are viewing the data as Baraa Gmail. Now let's go and test. You can see now I'm able to see multiple regions, which is totally okay. So even if a user like me with multiple access to multiple regions, the row level security is working because we are using the in operator. And actually, my friends, that's it. This is how we create a dynamic row level security in Power BI by using a very simple expression in docs. Alright friends, so now let's do a quick recap. Security is a very important part in data modeling. Do the data modeling correctly, then it's going to be really easy to build a security on top of it. Security have three types: table level, column level, and row level security. Of course, the most common one that is used in project is the row level security RLS. It's all about how to filter the rows of your tables to show only the allowed rows, and there are actually two ways on how to build the row level security. We have the static RLS to filter only the rows based on a static value. It works great if you have a small project with few users, but if your project is growing over the time, then you have to switch to more flexible way by building a dynamic RLS where you're gonna filter the data based on users, not static values. And in order to do that, we need some extra stuff, like for example, a security table, where it's gonna map the users to specific values of your data model. Then you have to be very careful how to connect this security table to your data model by using the right direction of the filters. Otherwise, nothing gonna happen. And the last step, you're gonna go and write a very simple DAX expression in order to let Power BI know how to filter your data model based on the security values. Of course, in real projects, we don't rush and build the role-level securities. We have always to do it step by step and slowly. So first, we have to understand the security requirement in our domain. Usually, we go and ask a security officer or someone that knows about those topics. We don't go and randomly apply security stuff inside our data model that is totally maybe unnecessary. So don't follow your guts about this. Always ask and make sure that you are implementing what is needed. Once you understand the requirements, then understand where you can apply it inside your data model. Don't try to force it in all tables unless it's needed. And of course, not only that, as well, your filter should be able to reach those tables and dimensions. But again, we secure only the things that is required. We don't have to go and like secure every single table inside the data model. So don't make your life hard if it's not required. And what is very important, we always have to test. That means you have to know the big numbers of your data model by heart, and you have always to test the effect of the RLS. So actually that's it. This is the role-level security in Power BI. I know that was not an easy one. This is an advanced topic, but once you understand it, you can go and apply it to any project. Hey friends, so now we're gonna do something amazing. We're gonna go and build a data model project in Power BI, exactly like I do in my real projects. The thing is, I have been involved in many Power BI projects at my work that had bad struggle with the performance and as well delivering wrong numbers. But after investigating, it was not the dashboard was bad or DAX. Almost each time it was the bad model underneath the report. So that's why I have prepared for you for this project a nightmare dataset that looks exactly like the one that I have seen in companies. Full chaos, bad shapes, bad data models, and as well bad relationships. So now what I'm gonna do, I'm gonna walk you through this data model step by step, exactly like I do in my real project, so that at the end, we're gonna get a healthy data model that is ready for reporting. And yes, this is the best way to learn data modeling, by doing projects, not just like watching disconnected videos, so that at the end you develop like a feeling for the whole process end to end. And very important, you don't just watch me doing the things, you always work with me. So for each step, you pause the video, you do it at your end, and then you continue. Alright my friends, so this is gonna be a fun project to do, and now let's get started.
Battle stations, everybody. Let's go, 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 go.
Okay, so now before we jump in, I'm gonna show you the project phases for the data modeling. So first, we have to prepare. We're gonna open the mess, we're gonna set up the workspaces in Power Query, and then we're gonna start investigating. So we're gonna start exploring and have basic understanding of the tables. What is the business? What are the entities? Which one are good candidates for dimensions? Which are for facts? So we're gonna develop like a big picture in our head. The second phase, we start building. So we start building the dimensions. We're gonna find like a group of tables that relate to each others and turn them into clean dimension. So we keep iterating until we build all the dimensions for the data model. Then the third step, we're gonna start building the facts and connect the dimensions to them. So we take all those event tables and start building the fact, and after that we connect all the dimensions to our new facts and start testing, of course, so that the numbers never break silently in our data model. And then the last phase is gonna be the polishing phase. We're gonna go and add security to our data model, and then we do like final test to validate the whole data model. So this is the whole project. So those are the phases that we're gonna go through. And as well, before we start like building anything, we have to keep in our mind those rules. We're gonna follow them from the start to the end, no matter which step we are in. So the first rule or goal is to build star schema. Fact table in the middle, surrounded by dimensions, and we never connect facts table together. The second rule, we have always to understand before do any changes. Especially, we have to understand always first the grain of each table. We have always to say it loud in order to understand the grain, otherwise we're gonna build wrong dimensions and facts. Now the third rule, every info, every column inside our data model must earn its place. So that means if we find any column that is not really needed for analytics and reporting, we have to go and drop it, and that's because of two reasons. First of all, they are wasting space inside our Power BI file. If you have a lot of unnecessary columns, your Power BI file gonna be really heavy and hard to refresh and hard to move. So that's why we remove them, to have some space. And the second and more important, they're gonna confuse you during building the visuals and reports. So if we find anything unnecessary, we just go and drop it. We can always go and bring it back if we need it. Rule number 4, we always have to protect the numbers. We must know by heart the totals of our data model, so that each time we do like a change or we connect something new, we go and check those numbers to make sure that they don't break. And now we come to the final rule, or let's say big step. We have to make sure that we are following standards that we have to define before starting the projects. And of course, those standards, we can define them from one project to another, depends on the requirements. But for this project, the standard is going to be like this. First of all, we have to define the language. Yes, this sounds like simple, but I saw a lot of projects where they are mixing languages in the data model. So yes, the language is going to be here English. Then we have to follow the same naming convention for the table and the columns. And of course, there are a lot of naming conventions, but for this project, we're going to follow the snake case. All letters, all characters are lowered and they are separated with underscore. Now, as well, you have to define the prefixes and the suffixes. Like for example, in the table names, if we have a fact table, we can have the prefix fact score, like for example, fact underscore sales. And if it is dimension, it's going to be dim, shortcut for dimension, like only 3 letters, underscore, then the dimension name, like for example, dim underscore customer. This is really important because I saw a lot of confusion if a lot of people are working on the same Power BI project. One gonna call it the underscore customer and another developer gonna call it dimension underscore customer. So we have to set up the standard for our projects before we start building. Now about the columns, we as well could bring some standards, like for example, the surrogate keys. Anything that we create inside the data model gonna end with the suffix underscore key, like for example, customer key, product key. So once you see in the data model, okay, it ends with the underscore key, that means we created that. It is not a natural key that came from the source. Like for example, the customer underscore ID, this is something comes from the source file, and the customer underscore key, it is a surrogate key that we just created in the model. So that you have understand the different types of your keys in the model. Now, the last rule, we have to make everything friendly. So that means we have to give for everything, the table name, the column name, even some values inside our tables, friendly, meaningful name, so that once you start building the reports, the value is going to be friendly and everyone can follow the reports. We don't bring any cryptical shortcut technical names that we inherited from the source systems. So this is the setup. Those are the phases, the rules, the mindsets that we're going to follow through the whole project. Now let's get started with our Power BI project. All right, friends. So now I'm really glad to present you the nightmare dataset that we're going to use for this project. Have a look to this beautiful chaos because, my friends, there is high chance if you join a company, join Power BI projects, that their data model looks exactly like this. I have seen this in many projects where the data model makes no sense. You cannot see like a star schema here, many-to-many relationships between tables, the filtered direction is like everywhere, and that's all because people skip the data modeling step. They just connect the source systems to Power BI and jump immediately to the visuals, to the report dashboards. They just want to build fancy reports for the end users. But of course, after a while, once they start sharing the dashboards, the users can understand all the numbers makes no sense. They usually come back to this model and start fixing the data model in order to bring better numbers. So my friends, what I have done for the preparations, I brought all the scenarios from my project and built this nightmare dataset in order to cover all the scenarios that you might face in the projects. So our goal is to turn this into a healthy star schema, bring correct numbers, and as well as good performance. Okay, so now we're gonna start with the phase number 1, the preparation. That means first we have to have good understanding about the content of those tables. So what is the business? What are the entities? Which tables are good candidates for dimensions? Which are for facts? So basic understanding about what we have, and we don't have like to deep dive into each small detail, just to develop a feeling about the business, about the data. And after that, we're gonna do like few setups in the Power Query as a preparation for the project. So now let's start. Let's understand what you have here, and I will not go through all the relationships because we're gonna break the data model, and anyway we have like to build the relationships again. So just basic understanding of the tables, and we're gonna do that by going to the table view. So we're gonna start from the top to the addresses. So what do you have here? We have an address ID, street, city name. So it's all about the geographic, the addresses, and maybe for the customers or something. So this is for the first table. Let's go to the second one, the campaign log. Okay, this one is a little bit bigger. So here we have the campaign name, the channel, start date, end date, a budget, impressions, click and spend. So it's all all about our marketing campaign day by day. So this looks like an event, and this is really good candidate for a fact. So we have numbers, we have dates. Now let's go to the third one. We have the campaign SKUs. This one looks compacted. So we have the campaign name again, and for each campaign we have like a list. And I think those are the products that we have in the business. So that means this table shows us what are the products that were involved in the campaign. And of course, this is not easy one to consume because the list is usually bad for reporting. And we can see as well the column names are not correct, and we can find them in the first row inside our table. Of course, we have to clean those up. Now let's go to another table, the cities. So what do you have here? We have again the cities and as well the regions. So this is again a part of the informations about the geography, the locations, the addresses. This is of course a descriptive informations, and we're gonna need those stuff as a dimensions. Now let's go to the next one. We have the cost master. So it looks like this is our customer table. So we have customer ID, customer name, segments, the address ID. So this is the first connection to our addresses. Then we have like people, the account manager, payment terms, some hash keys and source IDs. Those stuff comes from the sources. But now look at this. The customer name is not actually like a person. They are companies. Like here, for example, we have the Atlas Industries. So that means this is a very important table for the customers, and our business is B2B. So that's all for this one. Let's go to the next one. We have the customer contacts. So what do we have here? We have again the customer ID, the contact name, the emails is primary. Now you can see for each customer, like for each company, we have multiple contacts, which makes sense, of course, because our customers are companies, and usually we have to deal with multiple people in the same company. So this is all about who we talk inside each company. Let's go to the next one. We have a dimension underscore order. So this one looks really garbage. We have only one column and no context to it. So we have some kind of IDs that actually we cannot relate to anything so far. So I think this is junk. This is something that we could drop. So we just faced our first garbage inside the data model. Let's go to the next one. We have the exchange rate. So what do we have here? We have the currency, the rate, and as well the date. So this is as well information about our business. Let's keep going to the inventory. So now what do we see here? We see the product names, and for each month we have like numbers. So this is all about the inventory. So that means how much stock we are holding month by month. And here we have like a whole year. So for each month we have one column. All right, let's move to the next one. We have the invoice lines. So here we have like an invoice line, an invoice ID, product, and amount. So that means we have invoices in our system, and those are the details about each invoice. And that brings us to the next table, the invoices. And here we see like the master table for the invoices. So we have the invoice ID, the order ID, the customer name, the invoice date, and the amount as well. So this looks an event, a good candidate for a fact table. So it is connecting to other things like the invoice ID, the order ID, the customer name to the customer table. We have a date and numbers. And if we need more details about the invoices, we have the other table that we just checked, the invoice lines. So we just spotted another fact. Now let's move to the next one. We have the order line items. So again, sounds similar to the invoices. We have the details about each order. So for each order, we have like lines, an order ID, and this time we are connecting to the product names. So finally, we see here the products, and then we have here some numbers like the quantity, the price, the costs, discount, and total sales. So those are the details for each line. Now we're gonna go to the orders. So we have here 2 orders where the orders are splitted by the years. So for 2025, we have here a lot of things. So here we have an order ID, a legacy reference, customer name, customer city, region. So again, we have like some repetitions inside our dataset. To which city we're gonna ship, to which city we're gonna bill. So we have here different cities. Then we have the date, the order channel, and a lot of columns in this table. So again, this looks like a big table for a fact, because here we have an event. Each line is about an order, but as well at the same time, we have a lot of context inside this fact. So this is a gigantic one for the 2025, and I think that 2026 looks exactly the same. So they are just getting splitted. All right, so this is our third fact, I believe, but inside it we have a lot of dimensions that we could extract. Now let's go to the next one. We have the payments. So this one is a small one. We have the payment ID, the invoice ID, customer name, date, and amount. Again, looks like transactions, events. So this sounds like a fact table as well. And now to the next one, which is really important, the products. Finally, we have a dimension. So what do you have over here? We have the product code, the name, the brand, the subcategory, the price, and many other descriptions for the products. So this table holds the context for the business products. which is a classical one for a dimension. Let's go to the next one. We have the regions. Well, again, we have informations about the region, and as you can see, we are operating globally, North America, Europe, Asia. So our business is everywhere. Now let's go to the next one. We have the sales targets. So we have a row for each month and as well the target revenue. So it looks like someone planned the budget, the revenue for each month. And this is a classical use case where we're going to compare the target to the actual sales that we have in the transactions. So for sure, we're going to need this. Now let's go to the next one. We have the security. This is a really important one. So here we can see the user email and the region. So we can see each employee, which region they are responsible to. And of course, this is a perfect table that we're going to use in order to build the row level security. So we have to keep our eyes on it. Now let's go to the next one. We have the sheet 1. Weird name, right? I think this is like something wrong here. So we have the shipment ID, order ID, mode, ship date, delivery date. So all informations about the delivery. So we can see for each step how and when orders get out. Okay, interesting one, but we have to rename the table. Now let's go to the next one. We have the shipments. Well, those two tables are identical, and yes, I think the sheet 1 is an import problem, and this is a classical thing that happens inside the data model, that you have like two tables that are identical and you have to get rid one of them. So this is not really good. Now let's go to the subcategories. So very simple one. We have here like mapping between the category and the subcategory. Of course, this is going to help us in order to organize our products later. Now let's go to the last table, the user details. So we can see here for each user, we have like credit limits and a phone number. Well, of course, this is confusing. Which user we are talking about? I think this is going to be for the customers. If you go and check the customer master, well, yes, we have like the same patterns in the ID. So those are more details for the customers. So that means in the datasets, we are using like two names, sometimes users, sometimes like customers. Of course, we have to deal with that. All right, my friends. So that's it. We just visited all the tables. We developed like a feeling about the business. What are the entities? What are good candidates for dimensions? Of course, here the big dimension is going to be the customers and the products. And as well, we have a lot of events happening in the business. So we have a lot of facts. We have invoices, we have orders, we have payments, and as well, we have shipments, so a campaign. So a lot of events are happening in the business, and this is going to be really interesting on how to make a data model out of this and how to connect things together. So as you can see, my friends, this is a really important step. We have to get a feeling about the data before we change anything. The more you explore, the more you analyze, you build this understanding about the data, about the domain, and it's going to be easier for you later to understand the grain and how to build the dimensions and facts. The more you invest in this phase, the less errors and mistakes you're going to do in the data modeling. Now, of course, I have done this quickly because I have built these datasets, but I really recommend you to pause the video and go through them one by one, understand its contents. If you have done this already, now we're going to go and do a last step in this phase where we're going to prepare the Power Query, because we're going to work a lot with the Power Query in order to shape the data model. Not everything going to be like connected. We have sometimes to merge, append, and as well clear some quality issues. So now let's go to Power Query. As usual, we go to transform data. Now, of course, in this phase, we will not go now and transform or change any table. All what we want is to just organize it, because the thing is, as you start like building the data model, you will be creating new tables, references, and quickly the queries over here gonna go in chaos. So you will not remember which tables are the source table, which tables are the new one that you just created. So this is gonna get out of hand quickly, especially if you have like big model like this. Now, of course, there is like no best practices how to organize your projects, but I'm gonna show you how I usually do it. So everyone does it in their own way, on their own style, but this is how I like to do it. So I start by creating a new group. So new one, and we're gonna give it a name. So I like numbering the folders just to sort it on the left side. So the first one gonna be the stage. So the stage gonna be the folder that's gonna contain all the raw queries as it is from the source systems. So that means, my friends, all those queries that we see now on the left side gonna be inside this folder. So with that, I know, okay, all the raw stuff are living inside this folder. With that, we don't mix it with the new tables that we generate. So let's go and create it. Now you can see Power BI put everything under other queries, which is a good thing. Now I'm gonna go and select everything and drag and drop them on the new folder. So with this, my new folder, the stage, contains all the raw sources. So this is the first folder. We're gonna go and create another one, and we're gonna call it to dimensions. Now this is going to be an empty folder for now, because we're going to put inside it the new dimensions that we create from the stage, like the customers, the products, and so on. So that means if I want to go and do something for the dimensions, I go immediately inside this folder and I'm going to see it. Now usually after I build the dimensions, I'm going to go and build the facts. That's why The third one gonna be the fact folder. So same thing, any fact that I build from the stage, it's gonna land inside the folder facts. Of course, you can go and put them together, like maybe call it the data model, where the prefix is gonna decide for you whether it's fact or dimension. But I like to split it like this in order to have like a quick access. Now we're gonna go and create a last one. So a new group, we're gonna call this for support. Now in our data model, we're gonna have some tables that don't belong to dimensions and facts. Like for example, the security stuff, or maybe some like data that we insert. So anything that don't belong to dimensions and facts, gonna go to this folder, the support. Now you might ask, okay, why do we have the support if we have like another folder called others, right? We could use it as well, but the other queries has different job. So in case we connected any new tables, any new sources to our data model, it's gonna land inside the other queries. They are like tables that are in my to-do list that I have to work on. So my friends, this is how I usually organize my Power Query in order to build the data model out of the raw tables. Now look at this, we have 23 tables inside the stage and nothing inside the other tables. Of course, as we progress in the project, we're going to take all those tables and put them inside the different folders. We have to grab all those stuff and start building the data model. Alright friends, so that's what for the phase 1. We have now basic understanding about the content, the tables, and we have prepared our projects to start building. Finally, we're going to kick off the phase 2 where we start building the dimensions. This is how we're gonna do it. So we're gonna have like a loop. We're gonna go through each dimension where we're gonna grab a group of tables that describes the same thing. So the same entity. So all tables that have the same context for something like a customer. So what we're gonna do, we're gonna go and pull them together, reshape them into one clean dimension if it's possible. And we're gonna do whatever it takes. So we're gonna split, merge, append, fix, drop until we get the shape of a dimension. And of course, before we move on to the next one, we have to polish the dimension to make sure that we are following the standards that we agreed on the start. So the snake case names, the table names, the prefixes, the suffixes, everything. Once it is polished, then we go to the next dimension. So my friends, this is the whole loop. We pick tables, build, clean it to the standards, and then we move to the next one. But I'm gonna warn you from now, you might find yourself that you are repeating the same steps over and over for each dimension. And guess what? This is the part of the job. This is the nature of things, how we build data modules. And with each iterations, of course, you're gonna be faster. So now let's start building our dimensions.
Let's go build an airport.
Okay, so now let's start with the first dimension, and here we have to go and pick like one topic or entity. And I'm gonna start with the big elephant in the data model. We have the dimension customer. So we're gonna go and build it now. How we're gonna do it? We go and pick all the tables that are related to the customers and turn it into one dimension. So now based on what we have learned, we have a lot of tables, but obviously the biggest table that's gonna gives us context about the customers is the customer master. So now what I usually do is that in this scenario, since we have like a lot of chaos over here, it's like a puzzle game. I'm gonna go and grab all those tables that are related to the same topic and move them to one section in the model. So for example, here the table customer master, I'm gonna go and grab it over here just in order to get like feeling of progress over the time. Now what is the other table that actually gives us more context about the customers? We had the contacts. So it is over here, the customer contacts. And at the end we found like a table, the user details, where we get like phones and emails as well. This one gives us some context about the customers. Now there is a topic that actually could be relevant in that, the addresses. Each customer has an address. Of course, here the question is whether we make like an extra dimension for the addresses or we merge everything inside the customer. So I'm gonna say let's go and group them as well together with the customers. So this is the addresses over here. And for the addresses, we saw as well some other related tables for the locations. So we had like the cities, it is over here. And as well, we had the regions. So this could be as well interesting. So now by looking to this, we have like 3 tables about the customers and 3 tables about the addresses. So now I know, okay, on the top right, I have the dimension customers, and my goal is to go and turn all those tables into one single dimension. So as you can see, our data model is getting like maybe slowly less chaotic, but we are not there yet. We didn't start. So now in order to change the shape of the tables, of course, we have to go to the Power Query. Now in this scenario where we have a lot of tables, I usually start with the foundations, with the biggest table that's gonna gives us a lot of context context about the customer, and the one table that, let's say, has a completeness, like has all the customer. And I'm gonna say this is very obvious. It's gonna be our customer master. Here we have a lot of columns about the customers, and this is very good starting point. So now, before we do anything, we will not go and change now directly the shape of this table. We have to go and make a reference out of it, so that I can work on a copy, let's say, and leave the raw data as it is. Maybe later we're gonna need as well this table for something else. That's why I usually go and say, okay, let's go and build a reference out of this. So we have it over here, and then drag and drop it to the dimensions. All right, so now let's minimize this. The next step, we have to go and rename it. And here we have to be really careful with our rules. So we said we have a prefix for each dimension called dim, and we are using the snake case. So everything should be lowered. Actually, that's it. This is our first dimension. Now let's have a look. What do we have here? We have a lot of context about the customers. And how many customers do we have? We have 61 customers, and this is really interesting. The last row is 999, and it sounds like a test customer. So this is like a dummy information that came from the source system, and I'm gonna say we have to get rid of it. So I'm gonna go and filter this data out, and we can do that very simply by going to the filter over here and search for the ID, and then all what you have to do is to just unmark it. That's it. So now by looking to this, we have 60 customers inside this table. This is the foundations. We have to keep this in our mind, because as we start adding more and more things to this table, we have to make sure that everything stay unique and we stay with the 60 customers. So now we have the foundations. Now let's go and look to the other tables. So we have the customer contacts over here. We have the ID, the name, the email, and is primary. So we have here more context about the customers. And of course, it makes sense to go and put those informations side by side with the other context. So with the dimension customer. And how we do that, we go and merge the two tables. So it is very simple. We're gonna go to the dimension customers and say, okay, let's merge the queries together. So dimension customer, and the next one, it's gonna be the customer contacts. The ID gonna be the customer ID, and the left join, make sure it is always left. If you use inner, you might lose data from the main dimension. We don't want that. So, okay, now we get it like a new column over here. We have to expand and select exactly what do we need. So we need the name, the email, and is primary. So with this, we got our 3 columns side by side with the other context. Now, it is very important. Once you merge new data inside your table, you have to make sure that everything stay correct. That means the data is not fanning out, or let's say getting duplicated. Now, if you go and check here, we had 60 customers, but now as I scroll down, we have way more than 60 customers, and that's because the same ID is keep repeating over and over. And of course, that's all because the new merge table that we have attached to this table. So that was a really bad merge between those two tables, and this is exactly what you have to be careful, that merging is not destroying your dimension or maybe your facts. Now, of course, the question is, why did this happen? Because, my friends, we are merging two tables with different grains. So again, the customer contacts, each row doesn't represent one customer. Each row is representing one contact for the customer. So here, for example, for the second customer, we have 4 contacts. So the grain is different from the customer master. Here, each row is really representing only one customer. And once you merge different grains, you get this bad effect. So now, of course, the question is, how we gonna solve this? Well, there is like different ways on how to do it. You can say, you know what, we can go and convert this table into the grain of customer. So that means each row represents one customer. And what do we do with the contacts? We make like a list of contacts. It's like we are grouping up, or let's say aggregating this table to the level of the customer. And of course, we can do that if you go to the transform and then group by the columns by the customer ID. Another solution that you might say, you know what, this is the contact of the customers, and we can make another dimension out of it, and then make a relationship between this new dimension and the customer. Or a third solution that you might say, you know what, let's not go and add all the contacts inside the customer dimension. Let's just add the primary contacts. So for example, for the second customer, we have here like 4 people. Only one of them, Sarah, is actually the primary contact for this customer. And if that is okay for the analysis and the reports, then we can go and merge actually this table to the customers again. But of course, we have to make sure that we really have like one primary contact for each customer. We can do that by filtering the data, for example, over here, and say, show me only the primary contact. So of course, this dimension is very small. You can go and check like by eyes and see. With this, I have exactly 60 customers and I don't have like any duplicates in the primary key. So now again, my grain over here is one row is one customer, and the relationship between the customer contacts and the dimension customer is again one-to-one, and this is very safe in order to do a merge. So now, since we filter the data like this, let's go and check our dimension customer. Now let's see, again we have here a clean dimension where we have only 60 customers, and on the right side of course we have our primary contact for each customer. So with this, finally it is safe to merge those two tables into one. Now of course we are just checking by looking, right, whether there is duplicates or not. There is like smarter way on how to do it. That's you go to the primary key, the customer ID, and you group up the data by the rows. So you say here group by, and you just say okay count, and here the operation gonna be count rows. So if you go and say okay, of course the data gonna get grouped up by the rows. And if you see it like this, where the count is everywhere is 1, then my friend, you don't have any duplicates and you are okay. Of course you can go and check for here and you can see okay, we have only one value, the 1. So this is something that I do each time I merge two tables together to check quickly whether we have duplicates or not. But of course this is only for checking, so I'm gonna go and remove it. Alright, so that was the first lesson. Be careful for the grains if you are merging things together. Now let's go and check the third table. We had the user details, right? Now again we have more context to the dimension customer. We have the limits and the phone. That means we have to go and merge those informations to our new dimension. But this time we have to be careful. Do we have here the same grain? Well, by looking to this, I'm gonna say we don't have here any duplicates, each row representing one customer. So this one gonna be really easy. I'm gonna go to the table customers, same thing. We're gonna go home and then merge, find our table. It was at the end, so user details. Now things here getting interesting about the entity. We have here the user ID, but in other table they call it user ID. We have of course to talk about this because we have now like two different names for the same entity, right? But first let's go and merge things together, and of course we have to expand, so we just need the new informations, credit limit and the phone. And again, before we celebrate having more data inside our dimension, we have to go and check whether everything is unique and we don't have duplicates, so looks really good. Now before we continue with the other tables and building the dimension, I still don't like it that we found out inside our data we have like two names for the same entity. We had the customer and as well the user. So of course, what is the true? How are we gonna call this? Dimension customer or dimension user? This happens a lot, of course, by the way, in the companies where you have different departments calling the same entity different names. In one department, they call all the customers as users, and another is customer. So of course, this is always a dilemma as you are building a data model, especially if you are connecting like multiple sources inside one model inside your project. Now, of course, one idea could be, let's go and ask the business users who are using the reports which name they want to use. Now, the thing is, if you are asking a business user from specific department, they might say, you know what, we use customers, then I want to see it in the report as well as customers. But if you go and ask another department, another business, they might say use the user. So still it is dilemma and they will not really help you in order to decide for your data model. You cannot go and use both of them. That's why you have to have like feeling about the data model. If you have a lot of tables are using the customer as an info, then go with the customer. Like here in our example, most of our tables are using this term customer and only like one table is using the user. That's why I'm gonna decide for our data model to go with the customer as an entity name and let's say ignore the user as a term. So now let's go back. So that means we're gonna stick with the name dimension customer. We will not rename anything. Now let's go back to the other three tables. Now the next batch of tables, they are all to do with the addresses. Look at this. We have here the address ID. And now here, my friend, you have two options. Either you're gonna go and build a new dimension called addresses and then connect it to the dimension customer. And with that, you are actually building, remember, the Snowflake schema, one dimension connect and branch to another dimension, or we're gonna stick with our goal where we are building the star schema. So we always try to fit everything together into one dimension, and only in extreme cases, we might go and branch. So of course, I'm gonna stick with the goal. We are building star schema. That means all the address information is gonna go inside the dimension customer. And don't worry, we can always go and split if things goes wrong. So that means we have now to go and merge more and more things to the dimension customer. And now would like to show you one trick that I usually use in order to feel safe before merging things together. Yes, you can go and count things after merging, but usually I go to the module layer. So first save, yeah, okay, close and apply before going to the model view. Now look at this. This is our new dimension that we are actually building all the time. And you can see that Power BI is always trying to connect a new table to the whole data model. Of course, we have to remove all those stuff and start from scratch, but don't worry about it now. Now the thing is, if I have like a new table that I would like to merge it to the table customers, I go and check the cardinality. Like for example, we want to merge the addresses with the dimension customer, right? Now you can see we have already like a relationship between those two. Now if I see the cardinality is 1-to-1 relationship between those two tables, then this is really safe to merge those two tables together, because Power BI automatically check the values inside those two tables and detect the cardinality. And of course, this is a great indicator for me to say nothing gonna go wrong if I go and like merge those two tables together. So this is a good thing. And by the way, about the cardinality, if the relationship is one to many, so from the addresses is one and in the dimension customer is many, it is still safe. So there's another way to check before, let's say, merging two tables together. Let's go back to Power Query. So now same thing, let's go to the dimension customer. We're gonna go and merge. And here we're gonna search for the addresses. This time the ID gonna be the address ID. As well here, address ID, always left join, never inner join. If you have one missing address, then you are removing a whole customer. So this is not safe, we always use left join. And same things, we're gonna go and expand. We just need the street and the city name. So look at this, looks nice. Now, of course, we have to go and test. So do we have 60 customers? Well, yes. So merging the addresses didn't cause any harm, any issues. Now, what else do we have? We have the cities, right? So let's go over here. Now, what do we have here? We have the city name and the region name, but here we have a quality issue. You can see that the first row is actually the column names and not the column 1 and column 2. Now, in order to fix this, this is very simple. We have here in the ribbon, use first row as headers. So Power BI are gonna go and promote the first header as the column name for the table. So this is very simple. Look at this. We have now the city name and the region name. Now again, what we're gonna do, we're gonna go and merge this inside our dimension customer. Again, as I told you, you can go and check whether we have a one relationship at this table. So we have it over here, the cities. Let's go and grab it. I'm gonna go and remove this relationship and then try to connect it to the dimension customer. This is of course only for test. So I'm gonna take the city name to the city name. All right, look at this one-to-many relationship. So at the side of the cities, we have one. So I'm gonna get good feeling about it in order to merge those two tables together. We don't have many. This will not duplicate my customers. So that means we're gonna go back to transform data. So again, we merge, and as you can see, I'm merging all the time and I will keep doing that. So let's go and connect our cities. So city name, and the city name is somewhere over here. So let's go and connect, left join. Now what do we need from this table is actually only the region name. We have already the city name, so we actually don't need it twice inside our dimension. And we're gonna go and check, we have 60 customers. All right, now to the last table, we have the regions. Well, here we have only one column. We don't have like a lot of context that's gonna help us for the dimension customer, and the region information, we have it already, so it makes no sense to merge this table to the dimension customers. This information is already in our dimension. So as you can see, we have here the regions. So actually, this makes no sense to merge inside our dimension customer. It will not add any value or add any context. And this is of course one of the things that happens all the time inside the data models. You're gonna find the same piece of information multiple times in multiple tables. So the region exists here and as well in the cities and maybe in another table that we didn't discover yet. So here we have to be very careful. We are not like repeating the same data over and over. Otherwise, we are confusing the data model. So my friends, we went through the 6 tables and we have now one gigantic table that holds all the context about the customers. So that was a big step. We have combined now 6 tables into one dimension customers, but we are not done yet. We will not go to the second dimension until we do my favorite step. We have to do the housekeeping. So we have to clean up, organize, and make sure that we are following the standards. So we polish everything in order to make the dimension is ready to get used in the data model. So let's do that. All right, so now the first step that we have to do is that we have to get rid of unnecessary informations, unnecessary columns inside the dimension. Remember the rule, each data should earn its place. So that means if there is something unnecessary, we have to remove it. Otherwise, it's gonna take space. It's gonna lead to bad performance, and as well, it's gonna lead to confusion as you start building the reports. So that means, my friends, now we're gonna go through all the columns inside our new dimension and think about it. Should we leave it or should we drop it? So the customer ID, for sure, it's gonna stay. The customer name, the segments, all those informations are important for filtering and slicing and building visuals. Now, to the address ID, well, my friends, I believe we don't need it. I can't imagine that this is going to be necessary for reporting, only for connecting things, and we have decided to put everything together into one dimension. We are not making Snowflake, that's why I'm going to go and drop it. So remove the account manager, okay, the payment terms gonna stay. Now the hash keys. Well, my friends, those stuff comes from the source system, and I will never imagine that we're going to need this for reporting. That's why we're going to go and remove. By the way, this takes a lot of space inside the data model. I remember in one project we had like for each table one hash key, where the refresh time for the data model was really horrible. It took a lot of time, and all because those hash keys, they are string values and they are really big, and if you have millions of rows, imagine how much space this takes. So the fix was very simple, to just go and drop all those hash keys, and suddenly we saved around, I think, 20% of the data set. So now let's go and remove the hash key. Then we have source ID. This is as well some garbage from the source system. We will never use this. Now here we have the primary contacts, okay, we have their email. Now, whether it is primary, well, this is gonna be always true, right? We use this as a filter, so that means actually this is like totally useless information, and we would never use this. So let's go and remove it. Credit limits gonna stay, the phone, the street, the city name, and the region. So not that bad, right? We just dropped like around 4 columns. All right, so this is the first step that we're gonna do in order to clean up our dimension. Now comes the naming convention. As you can see, we are not following the standards. Only the table name is actually using the camel case, but all the columns are actually following another case. This we call it the Pascal case, where we don't have any separations and the first letter is capitalized. Now, of course, since we have committed to the snake case, we have to go and rename all the columns. Or you can say, you know what, since everything is like Pascal case, I'm gonna go and change the rules, but of course you have to stick to it, and we're gonna follow the Pascal case. Well, this is something that you decide, but I have decided for the snake case, and I'm gonna go and now rename everything to the standards. But of course, I'm gonna speed up, so I'll just do it for the first column for you. So this is gonna be the customer underscore ID, and this is gonna be customer name, right? Like this. So now, see you soon. All right, so now to the last column. As you can see here, we have the cities dot region name. We don't need the cities dot because this is just comes from the original table, the cities. We're just gonna go and call it region. That's it. So I'm gonna say everything is clean inside our dimensions. The names are friendly, so the table name, the column names, and as well the values inside the table. This is really important. If you see something cryptical, technical, we have to do something about it. Now I'm gonna say our dimension customer is ready to use. But now, of course, before we close and go to the second dimension, we have the last step where we're gonna go and hide all the original tables so that we don't see them anymore inside the model. So we're gonna go through them one by one. The addresses, we don't need it anymore, so we'll deactivate the enable load. So yes, same thing for the customer master. So we have to do the whole thing for all 6 tables. The cities, so deactivated. The contract as well here. The regions, well, actually we didn't merge it, but we don't need it. We have this information already in the dimension customer. And the last one, the user details. So right click and disable. Okay, so with this we have consolidated a lot of things into one dimension. Let's go and close and apply. Well, look at this, everything gone, and I have only the dimension customer. Now I'm gonna go and clean up those relationships. I don't need them. So remove, and last remove. So now comes the most satisfying thing that I'm gonna do. We're gonna zoom out and look at this. Our data model gets reduced a little bit, and now we have here one good solid dimension. So my friends, this is the first dimension, and I'm gonna say this is the biggest dimension that we have inside this raw data model. We have, of course, to keep iterating on this, and the next big dimension, of course, in our business, the products. And now again, the same iteration. We start by collecting all the tables that has to do with the products. We had very big table called products where we have a lot of context about it. So I'm going to drag it over here. And the second table that actually has to do with the products, that was the subcategories. I don't find it. Well, yeah, it's over here. So this one going to organize the products. And I think by looking to this, actually that's it. So we have only 2 tables to do with the products. We're going to go and try to merge everything into a new dimension called them product. So let's go and do that. So we're going to go again to the Power Query. All right, so now our 2 tables are again the products and the subcategories. Now, of course, we have to start one of them as the foundations. It's going to be the products, of course, because here we have a lot of context. This is the master table for our dimension. So as usual, so what we're gonna do, same thing, we're gonna go and create a reference out of it, drag and drop it to the dimensions. Let me just make this smaller, and we're gonna go and rename it. Same thing, the prefix is dimension and the name is products. Okay, so now let's have a quick look to our dimension products. As you can see, we have a lot of columns describing, and as well we have a lot of things that we're gonna clean up at the end. But of course we have to understand how many products do we have. Well, same thing, we have 60 products, and the last one we have as well a dummy data. So it says don't use, test, blah blah blah. So that means this is something from the source. We're gonna go and remove it quickly, so uncheck it. And the other thing, that's let's make sure that we don't have duplicate inside the products. So we can do a quick group by, so count rows. Okay, now we check this, do we have any twos? Well, only one, so this is clean. We don't have any duplicates inside our products. But now you might notice that we don't have actually a product ID, we have a product code. So that means the source table is not providing like a unique identifier in order to connect it to the data model. It is using the code as like a business key. This is of course a tricky thing. So now we will not clean anything yet. Let's go and check the subcategories. So the subcategories is over here. Now the first issue is that we don't have the column name. So what we're gonna do, we're gonna use the first row as headers. And the second issue, actually here we are merging two informations in one column. We have the category and the subcategory side by side, and they are separated with a pipe. Now of course we have the subcategories already in the dimension products, so we have it over here. But what is missing, which is very important, is the category. So that means we need the category in order to add more context to this dimension, and we have somehow to grab it from this column. Now of course we cannot go and merge this directly to the products because we don't have keys. The keys are actually like piece of information inside each value. That's why we have to go and split this into two columns, one category and another one subcategory. So let's go and do that. So here we have a nice function called split columns by delimiter. So here probably I get it correctly. We are splitting by custom, and the separator is the pipe. So actually everything is ready. Let's go and hit OK. Look at this. Now we have the categories and the subcategories. I'm gonna go and rename things because here it says 1 and 2. Power BI has no idea about the content. So this is gonna be the category and the other one gonna be the subcategory. Now we are not there yet because if you look at this, you see that all the subcategories, all the values are lowercase. But if you check our dimension over here, you see the key is not ready yet. We have it capitalized. So the first letter is actually an uppercase, and this will not work. So if I go and merge now things together, Power BI will not find any match. So as you can see, we have always like to prepare the data before merging. The keys must work. Otherwise, you're going to get only nulls after merging. So now either we're going to make this lowercase or we go over there and we make the key as a capitalized. I'm going to change it over here. In the reports, it looks way nicer if you have things capitalized. So how are we going to do it? We're going to go to transform, and here we have a nice function called capitalize each word. So let's do it. Now our key is ready for the merge. So everything now is simple. We're going to go to the dimension products. As usual, we merge, we go and pick our table. So it is the subcategories over here. And now all what we have to do is to just select things. So subcategory with the subcategory and left join. So let's go and set OK. All right, we have it here as a table. We have to expand. Well, we don't need the subcategory. We have it already. We just need the category. So okay, now it is working. As you can see, we have now the categories inside our table. All right, so now with this, I'm going to say that our dimension now hold all the context about the products in one table. We don't have anything else from the other tables. Now we're going to come back to this topic where I said we don't have like an ID from the source system. We just have like a code and a name. So it's not like the dimension customer. We had here like an ID. Now here we have like two options. Either we're going to leave it as it is, or we're going to go and create a surrogate key, something that we create inside the model, not from the business. And we're going to use this ID in order to connect it to the facts in the future. So I'm going to say for now, I'm going to go and add it. So we're going to go and add column, and we just go and add an index column, and we start from 1. So we have it over here. I'm going to go and rename it. So this is going to be not the product ID. This is going to be the product underscore key. We agreed in the rules, if we are creating any keys from us, we always have the suffix underscore key for it, so that I know which IDs come from the source and which one that I created. So it looks like this, and we have like 60 products. Now I'm gonna say we are done with merging and creating things. Let's go to the last step where we start like cleaning up and bringing standards to this dimension. So that means again, we're gonna go through all the columns one by one and say whether they're gonna stay or leave. So the code, of course, gonna stay, the name, the brand, the subcategory, the prices, the supplier, we could use it for slicer. Now comes something that I saw a lot in data models where people just leave such information here. So those are the big text, the descriptions. Now this is of course a huge text. It is describing each product, and of course we have to ask ourselves, do we really gonna go and use such a description inside our reports? In most cases, no. We are not building like an operative system. We are not building an interface in order to show the descriptions of the products. We are building analytics and reports, and in most cases we don't go and use product descriptions and long text in the visuals. But of course, on the other hand, I saw a lot of people that are using Power BI in order to build some kind of application, let's say, to see all the data. Well, there is like some projects that are misusing Power BI in order to build interfaces, but not BI, right? So in most cases, I refuse to have such informations inside the data model. That means we go and drop it. So remove. Now same thing, we have here hash key, the source ID. All those informations came as garbage, let's say, from the source system, and we don't need it here. Of course, they are maybe very important informations in the source systems, but here we don't need it. So let's go and remove it. Now here we have our category and the product ID. Now before we start like renaming everything, I would like to go and sort the columns. So I would like to see the product key at the start as like primary key. And the category, I would like to have it side by side with the subcategory. Well, I'm gonna say subcategory and then category. So with that, like we have a hierarchy, right? The product, then subcategory, and then category. I like to have things ordered so it makes sense as you are building visuals and reports. And now I'm gonna say we have all useful informations and we can go now and start renaming things. Again, I'm gonna do it now offline in order not to waste time. So see you soon. Alright, so this is the last column, and with that we are following now the same naming convention. Sometimes I remove few things, like for example the subcategory name. I call it now subcategory, so there is no need for the name inside the column name. Now there is one more thing. By looking to the values, you can see that the subcategory is actually capitalized. Same thing for the product name, only the category is everything here lowercase. And this of course because it comes from another table where everything is lowercase. So now in order to bring standards to the values, I'm gonna go and apply the same function. So transform and capitalize each word. So now things looks like more harmonized, everything capitalized, and maybe we can add it as a rule inside our project where we say all the text values inside our data model is capitalized, so that people, once they start building reports, they don't have to go back to the data model and start like adding more functions and transformations. All right, so now we have really nice dimension as well. The last step that we're gonna do, we'll just go and deactivate the row tables. So the products, we will go and deactivate it. Yes, same thing for the subcategory as well, it is deactivated. All right, so we are done. Let's go and make sure that we save and apply. All right, now this is our new dimension over here. Let me just zoom in. We're gonna go and remove the relationships, we don't need them. And for this as well. So now look at this. Now we have clean two dimensions are waiting here on the side, and our original data model is getting cleaned up step by step. Okay, so now what is next? What we're gonna do? Do we have like a third dimension that we're gonna go and build? Of course, there will be a lot of dimensions, but here we have like something that we have to decide on. Now, the product and the customers, they were like standalone and very obvious dimensions where we had like a master table for them. So we have like table product and another table called the customer master. So that's why it was really easy to make those dimensions out of those row tables. But now the thing is, in all other tables that are remaining in the data model, most of them are events. So we don't have like a master table for the third dimension actually. Most of the dimensions gonna get like extracted out of the event. As we said before, in many facts, there are always like hidden sneaky dimensions that we extract out of it. This is exactly now the scenario. Because of this, now we have like two ways on how to continue. Either you're gonna go through all the events one by one and start like extracting all the dimensions. And once you are done, once you have all the dimensions, then you start building the facts. Or the other way that I prefer, that at the same time we take like one event table and we split it into fact and dimensions. So at the same time we are building the fact and the dimensions out of the row tables, and we don't have like to rediscuss it and brainstorm it again. So either you go all the way by extracting all the dimensions and only after that you build the facts, or at the same time you are building the dimensions and facts. Well, I tend to the second option. So now let's go and do that. All right, so now by looking back to our data model, we have actually a lot of events. So we have the orders and sales, we have the invoices, the payments, the campaigns, and of course it's gonna be really hard to think of everything at the same time. That's why we have to go and pick one event, go deep inside it, and start splitting it into facts and dimensions. So that means we have to go and pick an event. I'm gonna say we're gonna start with the orders and sales. This is the most important one, and I think this is a little bit complicated. So now let's go and collect all the related tables like we have done in the dimensions together in one place. So we have the orders 2026, and as well we have the same table for the 2025. What else do we have? We have as well the lines for the orders. So this one over here. The sales target is gonna be the budget. So I'm gonna say it's not really same event. It is like the planned budget for each month. We're gonna think about it. Maybe we're gonna consider it. So I'm gonna say this is more than enough. We have a lot of things. We have the orders and the lines. And here we have to have full focus because we start talking about facts. Facts are very sensitive topic. So again, we're gonna go to the Power Query. Let's go inside. Now the first thing before we start touching anything, let's have some understanding more about our tables. So let's start with those two orders. So 2025 and 2026. Now again, I'm gonna ask the question of the grain. What each row is representing? Well, you can see over here, each row is actually one complete order. So we have all the informations about the orders. We have the customer name, city, region. Looks like dimension, right? But of course we have here the events, the order date, the channel of the order, the status, priority, total sales for the order, and some big notes. Now let's go to the other table, the orders 2025. This is very identical table. So actually here we have a split from the source system. Here as well we have the same grain. Each row is actually one order, but again the source system is splitting the data maybe for some reasons like archive and so on. And of course we have to do something about it. We cannot leave it splitted like this. It just confused the data model. Now let's go to the third one, the order line items. So now again the same question, what each row here is representing? Well, I'm gonna say each row is actually a line of order. So one line is not the whole order like we had it in the other tables. It is one position about the order. And of course we can go and check that by aggregating the order ID. So let's just group by and say, okay, this is the count of rows. Well, by looking to this, you can see here we have a lot of duplicates. That means for each order, we might have like multiple lines. Like here for the first order, we have 3 lines. All right, so I will just go and remove it. We are just testing here. So that means this has like more details, another grain than the orders. Now, my friends, here we have like a very classical scenario with the order lines and the orders. This is something that we call from the transactional systems, from the sources, the headers and the details. All right, friends, now I can say we come to the most complicated and confusing part in the whole data modeling project. That's why if you don't have coffee yet, go and grab one. Okay, so now we're gonna talk about the header and the details. This is very tricky and confusing part where a lot of people make mistakes in the data modeling for reporting and analytics, but yet one of the best practices and the common way on how to store transactions in OLTP sources. So it is a very common way on how to module the sources, and you're gonna find it a lot in many companies. So my friends, if you understand this concept and you know how to deal with it in the data modeling for business intelligence and analytics, then my friends, your life gonna be really easy working at companies because you're gonna face this data model over and over. So now, in order to understand this, let's start with a very simple example. I don't know, look around you, maybe you find an order or an invoice.
I found it!
If not, go and check online your stuff. So now here I have an order, and if I look at this, this is one business event. I have done an order, and this business event actually has like 2 sections, a header and details. The header, it is like the top level informations in the order. Like for example, I have the address, the customer, the company, the order number, the order state, the order date. So all those informations, we have it like only once for each order, right? And those are, my friends, the header. Now, if you look below it, depends if you ordered multiple things, you're gonna find like a table with more details. Like for example, you're gonna find the list of all products that you have ordered in this one order, and other things like the quantity, the price, and as well the final costs. And my friends, this setup, the header and the details, you're gonna find it in many events in many companies. So you're gonna find it in orders, in invoices, in shipment, in delivery, even in manufacturing. You're gonna have the bill of materials, the production order, or if you have like ticketing system, you're gonna find it as well in tickets. All those transactions and many systems system is gonna store those informations into header and details. Now, of course, the big question is, how are we gonna deal with those stuff inside our data model for business intelligence? Now, one of the biggest mistakes that people do is that they look at the header and details as two different things. So they say, okay, the header looks like a fact, so they go and make, like, for example, fact orders, and they see, okay, the details as well looks as fact, but this is like different grains. That's why they're gonna go and make another fact for that, the fact order line. So they make out of this like two facts. And now, of course, in reporting, you're gonna need those two tables in one visual, in one report. So that means they need two data from the facts. And here people come in this trap where they're gonna say, okay, well, actually we have the order key in the header and the details. This is actually what happens in transactional systems. They link the order with the header using the key, and they're gonna say, okay, this is a perfect match. This is the common column. I'm gonna go and connect those two facts together. Well, yes, this might work, but this can introduce only issues in the reporting. This has, first of all, bad performance, can lead to bad numbers, and as well, this is very confusing once you are building the reports. So this is one of the biggest mistakes that people do in data modeling. And now, of course, the question is, how are we gonna do it? How are we gonna model this? Well, the rule is always the same. The fact table gonna sit always at the level of things that you are measuring. So ask yourself where the numbers come from. So if you look to the header and the details, you're gonna see that actually all the numbers are stored in the details. The header is just like giving us some context and maybe like maximum 1 or 2 numbers, but the core numbers, the core measures are in the details. So that means it is always better to build a fact table that comes from the finest details, from the lowest level, because my friend, we can always roll up and aggregate the data back to the header. So that means in most cases, we're gonna go and create the core fact table from the details, and we're gonna the header in order to get more context for our new facts. So either we're gonna use it in order to generate new dimensions from the header, or we're gonna use it as well to connect the data model to our new fact from the details. So this is the very common pattern. We make fact from the details, and we use the help of the headers in order to generate dimensions and to connect it to our fact. And I can say this can work like 90% of the time. Sometimes you have some edge cases where people are storing a lot of numbers in the headers, but in most cases, this is gonna work if you follow this pattern. Okay, so now with this, I have prepared you with the foundations. Now let's go to Power BI and try this out. Alright, so now what we're gonna do with those 3 tables, I'm gonna say let's start with the easy and obvious thing. We have to go and combine those 2 orders into one single table. So again, if you have 2 tables have the same grain, and as well they are identical, they have the same shape, we go and append them. So how we're gonna do it, it's gonna be very simple. We're gonna go over here and say append queries, and I'm gonna go and create a new one so that we don't lose, let's say, the row tables. So now here it says 2 tables, and the first table I'm gonna start with the oldest, so first 2025 and then 2026. Alright, let's hit OK. So now we have a new table over here. Let's go and rename it. So this is going to be the orders. Now, of course, this is going to be like an intermediate table. We don't have like fact and dimension. We are just like merging things. Of course, if you want, you can go and make another order for all the temporary things, but I'm going to leave it now in the stage. Now, of course, we are not done. Let's have a look to the append, whether we have any strange things. Here we have some nulls. And if I go over here, the source file has as well some nulls. So actually there is like something wrong. And as well, the legacy reference. So that means that they are not completely identical. Let's have a look again. We have here the legacy reference, and in 2026, we don't have it. So actually with the new orders, we don't have this legacy column. So let's go and remove it. It says as well legacy. So I think we don't need it for reporting. And let's go and check the resource file. So over here, we have it in 2025, but we don't have it, I think, for 2026. So again, it is a legacy thing. We go and remove it from our new table. So you go out, remove. Now here we have a lot of nulls. The gift message, if I go over here, you can see actually we don't have any value. This is garbage column. So it is just taking space. Let's go and remove it as well. So as you can see, we are cleaning up. And since we are talking about cleaning, we have here the order notes as well. Those big text, come on, we don't need those stuff in analytics and reporting. So I'm going to go and remove it as well. So I think now we have like complete match between those 2 tables. We don't have any more nulls. So they are completely identical. Now, of course, you might say, but we lost an information which which record come from which table. So the 2025 and 2026. Well, actually, we don't need this information. We have it already in the order dates. So it will be just like an extra information that we have already. But if it was like another information like the country or something, I would go and add the source. All right, so now again, our orders is the header information. As you can see, we have here a lot of context for each order. So very good candidates for dimensions. And the order line items, here we have all the numbers. So this is the detailed table for the orders. And this means, my friends, this is gonna be our core fact table for the topic sales and orders. So now where we're gonna start, either we create the fact table now or we start extracting the dimensions from the orders. I'm gonna say, let's go to the orders and start like creating new dimensions. So what do you have here? We have the customer name, the customer city. Well, we don't create now another dimension called customers, so we're gonna leave it like here. Same thing for the region. Those cities gonna stay over here, the date as well. Now here we have something interesting. We have the order channel where we have like some numbers. Those are technical IDs. They are not something that we're gonna use in order to aggregate. We have as well status and priority. Those three informations are actually good candidates for dimensions because we can use them in order like to filter and slice. Now, of course, the question is, what is the topic? Are they like related to each other? Could we make like one dimensions out of this? Well, they are actually not related to each other. As you can see here, the order channel, the status, the priority, they are just like informations for the order, but they are not like connected together in order to make like good dimension. And of course, we will not go and make like one dimensions for each column. This is not good. In this scenario, what we're gonna do, my friends, we're gonna build the junk dimension. We're gonna put them all together in one and then reference it back in the fact table later. So how are we gonna build a junk dimension? We're gonna go and make another reference out of this. So we're gonna say reference, and this is gonna be a dimension. So I'm gonna drag and drop it to the dimensions. Let me just minimize this. All right, so right click on it, rename. Well, I'm not gonna call it again junk. So this is going to be the order flags. Maybe you're going to have another junk from another event. That's why we will not make it like super generic. Now, how we build this, it's very simple. We're going to go and remove all the unnecessary stuff and say, okay, remove. We don't need the order total. This is a number. We don't need it for dimension. Now, the last step, what we're going to do, we're going to go and remove all the duplicates from all three. So select all and say, remove duplicates. Very nice. We have only 14 rows. Now, of course, what is missing? We need like a key for this dimension. So we're going to go and add a column, an index column that starts from 1, then we're gonna call it, so rename the flag key, because this is a surrogate key. We just created this in our model and go to the top. Okay, so this looks already good. Now we are not done yet. There is something that I really don't like, those order channels. So as you can see, those numbers. Now this is gonna confuse a lot if you just bring it to the reporting. People might go and aggregate or find an average of this. Those are ID for something that we don't know. And we cannot leave it like this. We have to make something meaningful of this. So now at work, in order to understand what those numbers are, we actually go and read documentations or ask the people responsible for the source system, maybe ask an expert from the business or from the processes. So at the end, you have to find the mapping between those numbers and the real values so that we can show it in the reports. Now, let's say that I got it from somewhere, those informations. Now the question is, how are we going to add it to this data model? Because those informations are not coming from the source. From the source, we are getting only those IDs. So that means this is new information that I'm adding to this data model and it doesn't exist from the sources. And how we can do that? My friends, we go and add a data inside our data model by going to the home repo and say enter data. So this is going to be very simple. We are just creating a table from scratch like an Excel. So the first column is going to be the channel code, and we need another one where we have the full name. So the channel name. Okay. So it is just like mapping between code and the name. So we make sure that we cover everything from our data. We have the 10, and this stands for online store. Then we have 20. This is the retail partner. Then the 30. This is the channel of wholesale, and 40 is a filled sale. So we make sure that we have covered everything. So we have here actually only 4. Okay, so this is the translation, the mapping between the cryptical code and the friendly name. All right, so now let's go and hit OK. Well, now I have it here as a table, so I'm going to go and rename it channels, and then maybe bring it back to the stage because this is something like intermediate, right? So now what we're gonna do, we're gonna go back to our order flags and we have to replace those numbers with the new values, and we can do that by merging queries. So let's go and find our new table, channels. All right, so this is the key and left join. So let's hit OK. All right, okay, so let's go and expand, remove the code. We just need the name, and I'm gonna move it over here. Of course, you can now decide whether you're gonna leave the code together with the name, but I'm gonna say, actually, the codes are just like confusing, so I'm gonna go and remove it. So now, my friends, this is what we call data enhancement, data enrichment, and this is very typical things that we do in data modeling, because in source systems, we're gonna get a lot of critical things that we cannot just go and present it in the reports. So we have to add from our side something new to the data model, and with this comes a really great responsibility, because this is very typical. What could happen is that initially you're gonna go and start mapping everything manually, so everything looks perfect, but now suddenly the source systems are generating, let's say, new IDs, new values that we didn't map yet. So a typical problem happens that initially we do things correct, but afterward we forget about it, or maybe we just go and switch to another project, and your report's gonna show only nulls over the time because we don't have values for that. So adding data manually from us, the humans, to the data model, it is something critical and we have to be careful for it. So if you go to another project and you hand this data model to someone else, make sure to inform them that they have to check from the source systems. If there is something new, they have to go and extend this manual data that we added to the data model. Or what is way better and perfect, if you say, you know what, this mapping should happen in the source system and you are responsible for it, and provide it with all other files. This is of course the best option, because then we don't have any more the responsibility to touch the data inside the data model. Everything gonna be like fully automated. Okay, so now back to our junk dimension. The last step is just to polish. So that means we will just rename things, the channel, and here we have status, so only the S, and the priority. Okay, so our junk dimension is ready to go. Now let's go back to our orders. Let's see. Okay, again, we say those information is gonna stay, and that means we just extracted one dimension out of the order, which is totally okay. Now let's start with our fact. This is gonna be really interesting. Let's go to the order line. This has the lowest details. It makes sense. So let's go first and make a reference out of it. This is gonna be our first fact inside the data model. Let me just minimize all those stuff, and then let's go and give it a name. I'm gonna call it the fact sales. Alright, so this is the foundations for our fact. We have enough numbers inside it, but now the thing is we need the dimensions. So we have already here the product name, but we need the customers, we need the junk dimension, we need the order date, so we need all those stuff from the header to be included as well in our new facts. So that means now we're gonna start like combining things to our new fact, and here you have to be very, very careful. If you do one wrong merge, you're gonna destroy the whole facts. So now we come to the rule that we have to protect our numbers. So that means any changes that we do to the fact table, we still have to see the same numbers. And if we see something else, we have of course to fix before merging it to our facts. So now let's try this out, and I'm going to show you how I usually do it. Now, of course, I will not go and start like scrolling down, because usually the event tables are really big. So instead, I'm going to go and close and apply. So just save it. All right. So I think somewhere is our new fact, but we don't deal now with the data model. Let's go to the report view. And now we're going to go and pick like one important measure from our fact in order to keep tracking it for each change. So if I go to the fact sales over here, we have here some options like, for example, the line total, the quantity, the cost, the price. I'm going to go with the main measure. This is going to be the line total. So let's drag and drop it to our card. So my friends, this is the number and we have to protect this. Anything that we combine, we add to this fact table, it always should result exactly to this same number. If something changed, then we have an issue. So we have to know this number by heart until the end of the project. This number should be correct. Okay, so now we have the number. Now let's go back to Power Query and start adding things. So back to the fact sales. Now what we're going to do in order to bring the other dimensions to our facts, we're going to go and add the header. So we do that by doing a merge query. We're going to go to the orders that we have prepared. It is over here. And how we're going to combine it by the order ID. And of course, very important, the left outer join. Okay. Now, of course, we have to expand. And here we have a lot of things. I will not now judge everything. I'm just going to go and remove the order ID that we just used because we have it already. And let's go and add all the things. We can always remove later. So now we have everything from the header, the order. And of course, now the the big question is, do we have any changes for the numbers? So let's go and close and apply and wait a second until it's loaded. So keep focusing on the number. Any changes? Well, nothing changed. This is perfect. We still have the total sales. Of course, there are like different methods on how to test. Like for example, you can go and build a relationship between them and see whether it is one to many. So you can do like different ways of testing before merging. This is one of them. So that was successful. Now let's go back to the Power Query. Let's go back to the fact sales. Okay, so with this we have done the big merge between the details and the sales safely. And now we can go to the next steps. Like for example, we have to go and build the keys inside the fact. You know, each fact has a lot of keys in order to connect things to the dimensions. And our fact is not ready yet. So now instead of having the product names, we're gonna go and have the product key. Same thing for the customer. So let's do that. Let's bring the IDs and the keys and we can start with the customer. Now what we're gonna do, we call it something like lookup. So that means I'm gonna go and merge this to the dimension only to get the IDs. And again, since we are merging, we have to be very careful. So we're gonna go and merge a query again, but this time we are merging with the dimensions. So we're gonna go over here and find the dimension customer. So now this is our target to get the customer ID, but of course we cannot now connect using IDs. We have to do something scary. We're gonna go and use the text, the customer name. And this can open the door for many mistakes. So we have to really to check after that. So customer name, left join. This is, my friends, a lookup. So let's go and hit OK. Now what we're going to do, how we're going to expand. Of course, we will not go and bring now all the columns from the dimension. We just want one thing, the customer ID. So this one we need and hit OK. So now what I like to do next is to just bring the ID on the starts so that we have a real fact table. So it's going to be somewhere here. Now, of course, before we do anything else, we have to go and test. So I'm going to go and close and apply and keep my eye on this number. Well, nothing changed. That was a successful merge between those two tables and there is no risk about it. Now let's go and do the same thing for the products. So let's go back to the fact sales. Same thing. We have here the product name. We need the product ID or key. So merge, and now same thing, we're gonna go to that dimension product over here. We join, my friends, using the product name. So it's not the product code, which is really scary. So let's go and hit OK. And we just need a lookup. So that means we need the product key. Perfect. Now let's go as well, bring it to the start side by side with the other keys somewhere here. Now, before we touch anything, we have to go and test. Let's close and apply. Keep our eye on the numbers. Did the numbers just changed? Now we have way more total sales than before. Oh no, that was not successful merge with the products. We have something wrong and we have to protect the original number. So yeah, we have to do something. So let's go back to Power Query and see what is going on. So let's go back to the fact sales. Well, what we can do, we can go and check up actually which order have an issue. So if you select those two and say, okay, let's go and group by, I imagine those two should be unique. So let's go and count the rows for that. So now we see a lot of ones, but we see two, right? So here we have an issue. You can see those orders are fanning out. So we are getting like duplicates. And let's go and check something like, for example, the order number 25, and then go and remove this test. So now what we're going to do, we're going to go and search for this order. It was the 25. All right, look at this. We have the same order. The product name is identical, but they have different keys, which is really bad. Of course, the rest is going to be like identical. It is getting like fanning out. So this product has an issue. The same product name, but different keys. And this is a typical issue. If we are joining using like names and text, things can go quickly wrong. So that means we have to go and check the dimension products. So it was the kitchen something, right? So let's just search for it. This is the first one. And look at this, we have duplicates actually inside the dimension products. So we have different codes for the same product. And if you scroll to the right side, you can see one of them is actually have more data than the other. So here we have like brand and the other row doesn't have brand. Same thing for the price and the supplier. Of course, this is a data quality issue that came from the source system. And here we have like two options. Either we're going to go to the source system and tell them, hey guys, you have like wrong stuff. You have the same product twice. Go and clean up the data and then everything gonna be fine here. Or you're gonna go and manually start removing things. But of course, this is no guarantee that later we'll not get any like quality issues. Now, if the source system don't want to clean the data and they're gonna leave it as it is, then either you're gonna go and now like clean things manually, or what is way better, we usually build like a data warehouse where we build pipelines and quality gates in order to detect and fix those issues. But now for this project, since we don't have like a lot of products, we're gonna go and manually remove those bad rows. So here we have to decide which version should stay. And of course, it's going to be the one with more infos. So that means with the nulls should be dropped out of our dimension. Now, of course, we have to detect how many other like scenarios like this. So I will just remove this filter. Select all. Now how we're going to do it, we're going to go and just group by the product names. So we're going to go and say, based on the product name, go and count the rows and change the filter to 2. You can see we have the issue with 2 products, the kitchen and the audio. So it is not that a big deal. What we're going to do, we're going to go remove this test. Of course, now the question is how we're going to remove those 2 rows. I will not do it like as a last step inside our dimension. I'm going to go way back, maybe at this step, filtering the rows as we remove the one bad row where the product key is equal to ZZZ. So now, of course, the question is, where are those stuff? Well, it is the last 2 rows. You can see here, we don't have brands for them. We don't have a unit price. And now I remember we had like a really nice column for the source ID. So you can see here, we have like a source ID, a row identifier for each one of them. And we can use it in order to filter the data out. So this is one bad ID. I'm going to go and copy the value and then use it in order to filter the data. So I will check this out. Same thing for the last row. So I'm going to go and copy this as well and as well use it in order to filter the data out. All right, so as you can see now in our filter, we have 3 things. We are filtering the data based on the product code and based on the source ID. So now let's go and check again. We have to group up the data by the product name. So group by, insert, and product name. Now let's check the filter. Yes, we have only 1. So that means, my friends, our product names are actually unique, but be careful now to just remove the test. All right, now we go to the last step to make sure that everything is working correctly. Nice. So now let's go and save and check again our numbers. So come on. Yes, we got back our number. With that, we protected the number and the facts, and it was successful merge to the product. So we can now go and continue. Let's go back to the Power Query. So where is our fact table? So with this, now we got the 2 big dimensions, the product key, the customer ID. Now what is left is actually the junk, right? So we have those 3 columns and we have to connect the junk to it. Now I see already that we have an issue for the lookup. We need all those 3 in order to join it with the dimension, but we just removed the order channel, right? So if I go now and merge, it will not work. That means I'm gonna take it back. I'm gonna go to the junk and I'm gonna go and bring the ID back. So I believe this was the step. So let's go and bring it back. Yes. So we need those stuff. I'm gonna go and rename it. This is the channel code. Now let's go back to the fact sales. And let's do the merge with the junk dimension. So we need it. It is over here, the order flags. Now we're going to go and mark all those stuff, but not the channel itself because it has no idea about it. It is something that we added. Then we're going to go to the right side and select those 3. So now things should work and in the correct order, by the way. So the order channel, the status, and the priority. Same thing from the dimension. Left join. Okay. Now the next step, we're going to go and expand. Since it is only a lookup, we just need the key. So okay, yes, we got the junk flag. Let's go and do it side by side with the others. And of course, the big question, do we have issues with our number? So I'm gonna go and close and apply. Well, look at this, it is safe. So our number is protected. Let's go back. I know we are jumping between, but this is part of the job. We have to do things like carefully. All right, so with this now we got all the keys, all the IDs inside our fact, and it is ready to get connected to the dimensions. And now we're gonna go to the next phase where I like to go and drop things and polish the facts in order to follow the standards and the rules that we have added at the beginning. So now we're gonna start with the first thing. Do we really need all those columns inside our facts? So let's do it step by step. The line ID we need, the order ID as well, in order to count how many orders inside the fact. The product name, we don't need it anymore. We just used it in order to build the keys. So we're gonna go and remove it. Then we have the keys. That's of course what you need. And then we have the numbers. We need all the stuff in the facts. Now we come to something that is really important to understand. Now the thing is, in transactional source systems, they usually store the same informations over and over in different tables, just in order to optimize the performance of their UI and applications. And this is of course a big issue for us because then we're gonna have like the same information everywhere inside our data model, and this is gonna make a big confusion on how to build the reports. So that means, my friends, you have to protect the data model by having like one single point of truth for each info. So that means if I have the customer city inside the dimension customer, I don't need it somewhere else. This is gonna be the dimension customer is the single point of truth for the cities of the customers. So I don't have to leave it in like another dimension or to leave it in the facts. So always try to reduce the noise that we inherited from the source systems and make a decision where you're gonna store what, but only once.
I said I was only going to say it once.
So that means, my friends, we will not leave the customer city inside our facts. We have it already inside our dimension. Look at this. We have here the city of our customers. So that means we don't need this extra noise that we have in the facts. We will just go and remove it. By the way, this is one of the things that I have noticed a lot. People are gonna say, you know what, we might need it. So you really have to take a hard decision and start removing things that you don't need and keep it only in one place. Same thing as well for the region name. It as well belongs to the customer dimension. So let's go and remove. And now here's something interesting to what we said. We have here the ship to city and bill to city. This is different information than we had in the dimension customer. This belongs to the transaction, to the order. So for each order, we have the city where it is shipped to. And here the customers might change from one order to another to which city or to which location the order should be delivered. So the city here belongs to the transaction, to the event. It is not like master data of the customer. So that means this has different meaning than the cities that we have inside the dimension. It is something here transactional and could change from one order to another. So that's why I will not go and remove those informations, because this belongs to the event, to the transaction. So it's always really important to understand the business, to understand the domain, how things works. So let's keep going. The order date, of course, we need it. Now we have a lot of things that we don't need anymore because they were only here in order to do a lookup. So I'm gonna go and remove those stuff that were belonging to the junk. And now we come to something really interesting, the total sales in the header. So here as well, we have to decide, because now we have two things. Look at this. We have the total sales for the whole order. And here we have like the sales for each item, each line in the order. Now, of course, if everything is clean, the sum of the line of totals should be exactly the same value that we have here from the header. So that means the grain between those two are different. And now here, usually I decide on the following, where I say we go and remove any pre-aggregated values, because to be honest, I don't trust it. If I need the total sales for each order, actually I just go and summarize those values. So I have the data already available. I don't want to have like pre-aggregated things inside the data model that's maybe outdated, or maybe the calculation is not anymore correct. That's why I tend to remove any pre-aggregated things that I inherit from the source system, especially if I have the same information from another detailed measure. So that's why the order total that we got from the header, it is something unnecessary, and I'm gonna go and remove it. I can always get it back if it's needed. All right, my friends, so with this we have removed a lot of things from our fact table, and now things looks really good. Now I would like always to order my fact like this. We have always at the start all the IDs, and then all the dates, and at the end all the measures, all the numbers. It is not something that's very important, but I like to order it like this. So that's why I'm gonna go and grab all the context to the starts and just leave the numbers at the end. So now look at this. We have IDs everywhere. Then we have the cities. We have to do something about it. After that, we have the dates. We have only one. And at the end, we have the bundle of all measures and numbers that we have in the facts. So we are almost there, but to be honest, I'm still not happy about those two. So we have the ship to city and the bill to city. Now, of course, I can leave those informations like this, but we could build a dimension for it. So that we have like IDs instead of text here, which can reduce, of course, the size of the fact table. And at the same time, maybe I need more context to those cities, like for example, the region or the country and so on. So it's always better to convert those contexts to dimensions. So that means we have actually to construct a new dimension called dimension geo or locations or whatever you want to call it. Now, of course, the question is, what is the source for this new dimension? Should we get it from the fact, or do we have like some row tables that can help us with that? Well, remember we had really nice row table called cities. This is perfect. This is already like waiting for us to build a dimension for it. We just skipped it. As you can see, we cannot like think of everything at the start. As we progress in the data model, we can understand, okay, we need more things, and we always can go back to the raw data and make new dimensions. So now how we're gonna do it, this is gonna be very simple. We're gonna go and create a reference, and we're gonna drag this reference to the dimensions. We're gonna go and give it a name, them, geo. Now we have to make sure that this has no duplicates. I'm not really sure whether it has or not, so I'm gonna go and remove duplicates. Well, nothing changed, but I'm gonna leave it as a step. Maybe things changed. Of course, what is missing in this dimension? We need an ID, right? So we're gonna go and add a new index that starts from 1 and bring it to the top. So let's go and rename it. This is gonna be geo key, surrogate key. And the last thing that I'm gonna do, just rename things. So this is the city and this is the region. Perfect. Now we have new dimension. Of course, what is the next step? We're going to go and connect it to our fact sales. So over here using the city name. But my friends, we're going to go and connect it twice because here we have like 2 cities, right? They are different. The city for the shipment and another one for the bill. So let's go and do that. We're going to do it quickly. We're going to go and merge and then grab our new dimension. It's going to be, of course, the city. So, and then hit OK. Expand. We need only the key. All right. And then we're going to merge again for the other column. So same dimension. We need a city, but this time for the pill. All right. Expand as well. We need the key. Now, before we forget, we're going to go and rename things. So we're going to call it ship to city key. And the other one, pill to city key. All right. So now let's go and grab them to the other keys. So we can put it over here. And now we're going to go and remove those 2 cities. We have IDs. So remove. Perfect. Now let's have a final look. Look at this. We just have numbers. Now the last step that I'm going to do is that I'm going to go and just rename all the columns to follow our standards, the snake case. All right. So now I just went through all the columns and everything is renamed. Look at this. Everything looks perfect. We have only numbers and date. And this is exactly how the fact table is supposed to be. If you get it, my friend, like this, then congrats. We just built a perfect core fact table for our data model out of this complicated setup, the header and the details. Now I'm gonna say the fact is ready, and now we're gonna go to the satisfying part where we're gonna go and deactivate some raw tables, and then we're gonna go and connect the dimensions to our fact. Let's go and do that. I'm just going and deactivate now the orders, both of them, and as well the order line, and then close and apply. All right, so now what we're gonna do, let's go and make like 2 words. On the left side, it's gonna be this chaos, but on the right side, we're gonna have our new clean data model, the star schema. So this is our fact. And now let's go and bring our dimensions. So product, the geo, customers, and the junk dimension. So let's form the star and make sure we don't have any garbage like in our model. So now let's go and zoom in. We still have to do it carefully how we connect the dimensions to the fact, but the pattern, it's always the same. So we're gonna grab the customer ID and put it on the fact. Here, it's very important that you see one-to-many relationship and the filter is single. So never both, okay? So that's it. Let's save. This looks good. One-to-many and the arrow going to the fact. Same thing for the product key. So drag and drop, one-to-many, single, save. And for the junk, so we need flag key. This is over here. One-to-many, single. And now comes something, of course, really interesting. We have only one dimension, but we have to connect it twice to our fact table. One for the billing and another one for the shipment. Well, we're gonna do that. So the geo key goes to the shipment, one-to-many, single. This is gonna be the active one, and the second one gonna be the billing. So drag and drop, one-to-many and single. So save. So with that, my friend, our dimension geo is actually a role-playing dimension. We have 2 relationships to the fact table. One is active, that's going to be used all the time. And another one is inactive, that we have to use DAX in order to use this relationship, of course. But now you might say, okay, this is like way too more complicated than before. If we had like both of them inside the fact table, I can just go and use them inside my reports. Well, this is a fair point. If you never need like more geo informations, but if you start like needing the regions, the countries, and this geo is like getting bigger and bigger, then it makes no sense to leave it inside the fact. And as well, it makes no sense to go and duplicate the dimension twice. Those are all bad designs. So now, my friends, look at this. If I zoom out, you can see clearly the 2 words. On the left side, we have the full chaos, and on the right side, we start having the shape of our star schema, our goal, and things looks way more better than before. So this is exactly, my friends, how we migrate from bad data model to a new, better model that's gonna deliver only correct numbers, good performance, and as well reduce any confusion. Okay, so now we have to keep going, but this time I'm gonna go and pick something that is a little bit easy. So that we have break. I will not pick something complicated. We're gonna go this time with the inventories. This is an easy one. So let's go and do something about it. We're gonna go and enter the Power Query. So what do we have here? The inventories. Oh yes, we have here the product names. And for each month, we have the total amount of items that is planned. Well, of course, the first question is it a fact or dimension? Well, since we have numbers, we have dates, this is going to be a fact. So before we do anything, we're going to go and make a reference, then move it to our facts. This is our second fact. I'm going to go and call it fact inventory. And now we can start preparing the fact. Now, the first easy issue with that, the first column is not promoted as a header. So the column names are weird. That's why we're going to go and say use first row as header. Easy win. Now, by looking to this, you can see it is a really nice table for us, for humans to read, but this is very bad for data modeling because the date information is stored as a column name. We cannot use this, of course, in reporting. That's why we have to convert this from human ready to data module and reporting. And how we can do that? Using unpivot by turning the columns into rows. It is very simple what we're going to do. We can go to transform, then select all the columns. And here we have this nice function, unpivot. Look at this, like magic. Now all the column names are values inside my table, and this looks already like a fact table. And now after that, I think this is the data type text, right? So we can see here text. We have to go and convert this to a real date. Then it's going to be easier to use in the reporting. And same thing that we have done before, we have to go and get the product key. So we need a lookup, and how we can do it as usual, we go and merge with the dimension. So dimension product, connect the names and say, okay. Now after that, we're going to go and get only the key, bring it to the start and remove the product name. We don't need it anymore. So remove. And of course, my friends, you have to go and check things. And now I'm doing things quickly, but still we have to go to the report, make a card, go and calculate all the values. After merging, are we getting like any duplicates? But now in order to make things quicker, I will not do that, but you have to do it at your side. I would never trust that everything is okay now. So now the last step in our new fact, I'm going to go and rename things. So this is the product key. And this is gonna be, I'm gonna call it for now month, and instead of value, I'm gonna call it units. All right, friends, so actually that's it. With this, we got our second fact, and it is perfect. It has an ID, it has a date, and as well a measure. Now, before we go and start connecting things, I'm just gonna go and like deactivate. So the inventory should not be loaded. And actually, we have here a few things that we didn't deactivate before. So we have here the orders and as well the channels. So we don't need you. Okay, so now let's close and apply. You can see the chaos is getting reduced by the time. And here we got our new fact table. Let me just zoom in and have a look. Probably I done it correctly. I wanted to do that, but as you can see, we never connect the fact tables together. So there is no direct lines using the product key. We connect the fact tables always using the shared dimension, and this can be the dimension products. Of course, a quick look, it is one-to-many relationship and the direction is correct. As you can see, if you do things correctly, Power BI gonna love it and it's gonna build it for you correctly. So my friends, look at this. We are moving from star schema and now we are like building the galaxy, right? Which is of course still star schema. So my friends, that was a quick win. Alright friends, so that was the inventory. It was a little break. Now let's go back to something more advanced. Now we have to go and pick something from our data model. So we have invoices and stuff. I'm gonna say let's go and solve the campaign. So we have the campaign log and another one, the campaign SKUs. So it's time to solve this puzzle. As usual, we're gonna go inside Power Query. So let's go and do that. Okay, so let's go to the campaign log. So again, what do you have here? The campaign name, the channel, the start date and the end date of the campaign, the budget, date, and some nice numbers. So clearly this looks like a nice fact table, but still inside it we have some context about this fact. So the context is, my friend, the campaign itself. So it looks like a clear split between one dimension and one fact, right? And let's have a quick look to the other one, the campaign SKUs. We have here the campaign name and the product names as a list. So this sounds like the connection to the rest of our star schema, the products, the product code. So I think I got the full big picture. Now let's go and start building the dimension, the new one. All right, so as usual, we're gonna go and create a reference out of the row table. Now we're gonna start with the dimension. So that's why we're gonna bring it to the dimension folder and rename it. So this is gonna be the dimension campaign. All right, so now which column's gonna stay and which gonna leave? Well, my friends, we have here clear split. So all those columns are actually transactional columns that belongs to the fact, and the rest is gonna be the dimension. So let's get rid of those. Now, of course, as usual, we're gonna go and remove all the duplicates from those columns. So remove. With this, we got our 6 campaign that we have inside our data model. And now by looking to this, you might say, but wait a second, what is going on here? Actually, the fact always contains like dates and numbers, and this dimension looks like a fact. So why we are calling this a dimension campaign? Well, totally fair point. At the start, I was as well confused about this topic, but my friend, the dimensions and facts are not defined by the data type of the columns. Think about it. A dimension is just a context, a description for an event. And a fact table, it is the event itself. It is transaction. It is something that keep happening every day. So something that grows fast, right? So now by looking to this, my friends, this is not transactional. This is not an event. Yes, it has a start date and end date, but this is actually describing the campaign. It is more context, more info for the campaign itself. And the number budget over here, it is a fixed value that as well describe how big is our budget for this campaign. So yes, it looks like an event, but this is not transactional. Those are just describing the campaign. Now, in order to understand what is a real transaction, just go back to the original table. Look at this, what each row here is representing. So for the first row, for example, we have the campaign name, the channel, the start and ends, the budget, but here we have a real transaction with the date, so we can see every day what is happening. So in the first day, what happens? We spent so much, we got so much clicks and impressions. What happens in the next day for the same campaign? We spent less, but we got more clicks, and so on. So my friends, all those columns are actually transactional columns. Every day we are like getting something new about the campaign. And if you go to the left side, you're gonna see those informations are really static. So the budget will not change, the start and end will not change as well. And because, my friends, those informations are describing the event itself. So the left side is not changing so much. That's why it is a dimension. But on the right side, there is a lot of transactions and movement. And that's why, my friends, those 4 columns are a fact. I hope this makes sense, but this is how we define a dimension and a fact, not only based on the data types, but as well what is going on, how the transaction is happening, and by understanding the business itself. So that's why I decided on this split based actually on the data. Now let's go back to our dimension. We are not done yet. Of course, what is missing? We need an ID. So start from 1, move it to the left side, and actually that's it. The last thing that we have to do is to just go and rename things. So I will just do it quickly. This is the key. This is the name. This is the channel. Start date. Alright, so I can say our dimension is ready. Now let's go and create our fact table. So same thing, we're gonna go and create a reference. As you can see now, our work is repetitive, right? This is exactly how things works. So this is gonna be the fact campaign, but I'm gonna call it spend since we have the spending there. Alright, so now what we're gonna do, actually we don't need all those informations, we have them already in the dimension. That means we need now to do a lookup in order to get the campaign key. So as usual, we go and merge queries with our new dimension, the campaign. We join with the campaign name, it is unique in our dimension, and then say, okay, now since this is a lookup, we just need the key, we don't need all other informations. Drag it to the start because we have always the keys at the start, and get rid of all those things. Those are in our dimension. So now what is left? We have the date, impression, clicks spent, looks nice. The last step, we're gonna go and just rename things. So I'm gonna do it quickly. Campaign, key, and I'm gonna make everything lowered. My friends, so with this now we got our third fact inside our data model. Now let's go to the last table we have here, still the campaign SKUs. Now before we start working on this, we're gonna go and create a reference out of it. So reference. Now I'm gonna go and put it in the facts, but I'm gonna explain myself later, okay? Just stay with me. Now the first issue with that we have here, we don't have a column name, so that's why I'm gonna go and promote it as a header. Now what do you have here? We have like a list of product codes. This is of course a nice thing, but I cannot use it in reporting, right? I cannot go and connect it now to our model. So that's why we have to do something about it, and we call moving a list into rows and explode. So we have to explode it into multiple rows, and we can do that easily by going to the column and say split columns by delimiter, because we have here a comma. Let me just move it a little bit. So the delimiter is actually a comma. Now the thing is, I will not go and split by columns. I don't want each value to go in separate columns. This makes no sense. This time we are splitting by a row. So if you go to the advanced settings, you can see here we split by columns or rows. I'm gonna go with the rows. All right, so actually that's it. Let's go and hit OK. Look at this. Now each product code is now a new row. But now before we celebrate this, we have equality issue. If you see like some values are shifted a little bit to the right side, you can understand this if you go back to the original steps at the start. You can see the values are yes splitted by comma, but there is like after that a space. This is just like a cosmetic thing for us in order to read the list easier. But of course, this is causing an issue after we explode. So you see the first value has no space, but all other values are like moving to the right side because of the white space at the start. So how to solve this? It is very simple. We're gonna right click on it and then go to transform. And here we have the nice trim. Look at this, everything moved to the left side and we don't have any more empty space. Because my friends, we have always to take care of the values that are used for the merge later. Alright, so now what we're gonna do with this, my friends? Well, this is not like a dimension because it is like two different entities, right? The campaign and the products. And as well, you can see it in our dimensions. We have a dimension for the product, we have dimension for the campaign. And this is like just mapping between them. So I cannot go and put it in the dimension product or in the dimension campaign. And of course, it makes no sense to create like a third dimension called campaign product mapping because this is not one entity. So now in order to understand more what is this, let's go and convert those values to keys as we have done like in the facts. So now instead of the campaign name, I'm going to go and make a lookup and grab it from the dimension. So campaign, and we connect by the campaign name. All right, now let's go and grab the key. We're going to do the same thing as well for the products. So let's go and merge dimension product. This time we are connecting using the product code, not the product name. All right, now let's go and get the key, put them side by side and get rid of those two informations. So remove columns. Now the last thing, I'm just going to go and replace the names. So this is the campaign name and the other one is the product key. Now look at this, my friends. If you have a table that contains a lot of keys and you have the feeling this is like mapping or a bridge between multiple dimensions, this table has no numbers, just like collection of keys. Then my friend, welcome to a new type of facts. We call it the factless fact. A factless fact, it is like a classical fact table. It has a lot of IDs in order to connect multiple dimensions. It has as well dates, but the only difference is that it doesn't contain any numbers, so no measures. So that means with the factless facts, we are not measuring anything. So we are not interested about the how much. We are only tracking whether something happened or not. So it is very simple. If your fact has no measures, no numbers, then this is a factless fact. So in this example, it is a little bit weird, okay? It is not that like perfect fact that we usually have. We don't have a date, only the keys. And as well, we cannot turn this into dimension because this is not describing actually anything. If this keeps like really weird inside your data model, you can go and just get rid of it. But for now, we just build it. That's why I'm gonna go and call it the fact promotion coverage. Okay, so this is our weird fact, but of course we have way better fact here that we can do a lot of analysis using it. And we have our new dimension. So now next what we're gonna do with that, we're gonna go and deactivate things. We don't need them anymore. So disable load. Yes, same thing for the campaign SKUs. All right, so now let's go and close and apply. All right, so now we have here list things on the chaos world. We are moving to the right side and here we have our new stuff. So this is our factless facts. Let me zoom in. This is our new facts, the campaign spend. It is connected correctly to the dimension campaign. So one-to-many relationship and the arrow is correct. And the dimension campaign, it is a shared dimension to the factless facts, which is just playing the role as a bridge between the product and the campaign. Look at this, things are getting connected, yeah, slowly. So I will just move things a little bit closer. So now by looking to this, you can see our shared dimension, the product, is shared now by 3 facts. So it is a really very important one, of course. And this is of course a typical thing because in each business, the products are the most important things. So we are transitioning, right? All right, now my friends, we come as well to a point where it's gonna get a little bit heavy, but I'm gonna explain it step by step. So that means if you are watching and you didn't take a break, go take fresh air, make a cafe, and then we continue. This is gonna be a little bit tricky, but we're gonna see. Okay, let's go. So now, as I said, we have now some events that we're gonna tackle in one go. Of course, as usual, we're gonna go back to the Power Query in order to understand the content and reshape things later. So now, what else that we have inside our table? We have the invoices. So you can see we have an invoice ID, an order ID, the customer name, invoice date, amount. So this is as well transactional. This is an event. Now, if you go to the payments, you're gonna have the same feeling. We have the payment ID, the invoice ID, customer, payment day, and the amount. Now, if we go to the shipments, again, very close, shipment ID or the ID and so on. So my friends, all of those things are events and somehow they are all connected together. Now, in order to understand how to deal with this, we have first to understand the process. So the process is very simple. Like any order, we have a customer, which is the company. They go and place an order. So this is the first step. After that, we're gonna go and ship the products to the customer. So this is the second step. And of course, it's gonna follow up with a delivery. So this is gonna be the third step. So we can deliver. And after that, we're gonna issue an invoice. So this is number 4. And the last step, my friends, the payment's gonna happen. So pay. This is step number 5. So actually, this is the whole process of ordering something from our business. Now, of course, each step in our process is actually a transaction. So it has like a date, it has a number, so how much the total sales for this order. Same thing for the shipment, the delivery had as well date, invoice, and as well we have like some numbers on top of it, and how much the customer did pay. So each one of them has their own table and transactions, but everything is actually, my friends, are connected back to the order. This is the main trigger for the whole event. Now, of course, what are our options in order to build this process inside our data model? Either we're going to go like the source system where we're going to go and build a table for each step. So that means we're going to go and build like one fact table for each step. With that, we're going to get like 5 fact tables. We have already one for the orders, but for the rest, we have to go and build them. Well, this sounds smart and reasonable things to do. But now if you have like a deeper look to each of those steps, you're going to find that we are talking about the same money over and over. So the same number should be in the orders and as well in the invoice, and I hope in the payments. Now, of course, the big question is, do the business users really want all those numbers in our reports? Are there many use cases for all those numbers? Well, I'm gonna say no. Usually the business user is gonna ask us, okay, find me the total number of sales for the whole business, or maybe by the region or by the products. And for this, my friends, we have one single point of truth for that. It's gonna be the orders. So I'm gonna go and grab the number, the money from the order. So I would not go and start like showing all the numbers from each steps, because at the end it is the same money. So that means we will not get like a lot of use cases for those numbers that we're gonna have inside those facts. But actually, by looking to this, we're gonna get better questions from the business. They're gonna ask questions about the whole process itself. So they're gonna start asking questions actually not about the numbers but about the dates. So those informations are way more interesting than the numbers. Like for example, how long it takes from an order to delivery, or how long it takes from an order to the payment. So there will be a lot of questions. How long from the delivery to invoice, or invoice payment. So that means usually the business, and especially the process expert, they're gonna ask a lot of questions about the dates. So that means what is actually interesting from all those tables are actually the dates for the business intelligence. And now what we could do, instead of having like a fact for each step, we're gonna go and make like one fact table that's gonna put side by side all those dates inside this fact table. And once we have everything in one fact table, then we can answer many questions about the process. And of course, I'm not inventing here something. In business intelligence, in data modeling, this has a famous name. This is, my friend, a type of fact table called accumulating snapshots. So each row gonna represent like one event, one order that gonna hold all the milestone dates of the steps in our process. So this is the accumulating snapshot fact that we're gonna go now and build. Okay, so now since we have now special type of fact, it's gonna be as well special how to build it. It will not be like the others. Now, since we're gonna have like the whole process in one row, a lot of tables gonna be involved in building this fact. So this is gonna be something special. Now, how to build it? We usually start with the spine, and usually it is the first step in the process. It is the order. So that means, my friends, these orders that we build at the start where we combine things together, this is gonna be the starting point for our new fact. That means I'm gonna go and create a reference out of it. Then we're gonna go and drop it in the facts. So we can go and call it, for example, fact, order, process, or fulfillment, whatever. All right, so with this, we have now good starting point. This is the spine of our fact. Each row is one order. And now the question is, which column's gonna stay and which gonna leave? Now again, what is our purpose? We want to show for each order, for each customer, all the steps, dates for the whole process. So that means I don't actually need a lot of things over here. I just need the order dates. So that means I'm gonna go and remove all those stuff. Same thing for the junks over here. So let's just go and remove. Actually, that's all what I need. So order ID, customer name, and order date. This is the first step in the process. Now, of course, instead of having the customer name, in order to connect it to our data model, we're gonna go and make a lookup. So we're gonna go and join it with the dimension customer name, and then we're gonna go and get our key. Perfect. Go to the left side and remove the customer name. Perfect. Now we have the first step. Now we have to go and get the other steps of our process. What is the next one? We have the shipment. So we have the shipment ID, the order ID, the mode, the date, and the delivery date. So we have here 2 dates of the process, which is exactly what do we need. Now about the mode, we can include it or not. But for now, I will not include those stuff inside our fact. So I'm going to go back to the order process and then merge the shipment with our table. So it is somewhere over here, shipments. We join by the order ID and hit OK. Now we have to go and expand. We don't need the IDs, we have it already. We don't need the mode, I just need the dates. Perfect, look at this, we have the shipment date and the delivery. Now what is the next step? We need actually the invoice. So let's have a look to the invoices. So the invoice ID, again the order ID, this is our key. We have again the customer name, we don't need it, we have it already. We just need the invoice dates. The amount is gonna be like the total sales. So I'm just collecting the dates. Let's go back to our process and same thing, we can go and merge invoices, order ID. Okay, then we have to expand. So just give me the date. So now we are getting closer. Now the last step in our process is gonna be the payment, right? So over here, well, we don't have the order ID, we have an invoice ID. So we're gonna join using the invoice ID. We have it. We don't need the customer name, just give me the date. So let's go back to the process. Now, of course, I need the invoice ID. That's why I'm gonna go some steps back in order to expand correctly. So I need the invoice and as well the dates, otherwise I cannot join it. So actually now we have the ID and now we can do the merge. So we need the payments over here, this time the invoice ID with the invoice ID. Let's hit OK. Then the last expansion, we need the payment date. Now I can go and get rid of the invoice ID, I don't need it anymore, so remove. So now, do we have everything for our process? We have the order, the shipment, delivery, invoice, and payment. And this looks exactly like our business process. So this is, my friends, the fact that's called accumulating snapshots. For one event, you're gonna get all the dates of the process. Of course, I'm doing things very quickly. I usually do and test a lot. Each merge, I check whether we have duplicates or the numbers are correct. But now, in order to make things a little bit quicker, I'm just merging like crazy. So this looks really good. Now, what you're gonna do actually with the other tables? I'm gonna say we're gonna go and deactivate them because we have now the most important aspect of all those tables. And of course, if in the future we got like more specific things and more specific questions about, for example, the invoices, then we might go activate it again and build like special purpose fact for it. But actually we got the best of this table. So we connected is with the order, we have already the customers, the invoice dates, and the amount is not that important. We have it in the fact sales. So that's why, my friends, I'm gonna go and deactivate it from the model. Same things for the others. So let's go to the payments. The same money is just repeating over and over. So deactivate. Same thing for the shipment over here. Well, we can go and include the mode if it's really that important. But again, if we get like some specific use case for the shipment, we can go and activate it and add this column. This will not be now necessary for our data model. So we are deactivating a lot of things. Now, by looking to this, we still have the invoice lines. This is exactly the same setup like we had at the start. The invoice line is the details of the invoice and the invoices is the header. Again, if there is like special needs, special use case in order to analyze the invoices, we can go and always build a fact tables out of those stuff. But for now, I don't see it as a core thing inside our data model because again, the same money is repeating. So I'm gonna go and deactivate this as well. All right, now we have deactivated almost like everything. So let's go and save and see what do we have and look to our data model. So this should get really empty. Oh, wow. Look, we still have like 4 tables out of the chaos. And of course, everything went to the new data model. Now, of course, you might think now I'm trying to rush up the project in order to close things. But to be honest, this is exactly the way how I work. I don't go and push everything inside the data model in order to have everything just in case someone asks for something. I try to push really hard on the data model only to leave what is necessary. And I can tell you, after working in many projects, this is exactly the process. I understand the business cases and try to bring the core facts and the core dimensions to the data model. And if there is like 1 or 2 customers are asking very specific questions about like some weird tables, I would not go and destroy the data model, to be honest. I'm gonna go and build another Power BI model just for their purposes. So it's gonna be something quick just to make their analysis, and that's it. And try to protect the core data model from those edge use cases. So this is my style on how I do data modeling, but there are a lot of people that go and include everything inside the data model just in case. Well, if you do it like this, then you are including a lot of things that will never be used in reporting. And this is really waste of space, performance, and as well confuse a lot in reporting. All right, so now back to our data model. Now we have like new things. We have to be as well careful that the new core data model is not getting like full of chaos. So we have the order process. This is the accumulating snapshot type. And yes, it is connected with the customers, and that's it. So yes, we are getting a lot of facts, but we are making sure none of the facts are connecting to each other's. They always go through a shared dimension. Our shared dimension now is the customers and the products. And always the relationships are healthy. So we have here one-to-many relationship, and the direction is from the dimension to the facts. So this is not chaotic. This is very healthy. Okay, so now we are getting very close to end the migration. Look at this snaky table at the ends. Let's go ahead and put it here. So what do we have here? We have 5 tables yet to go. Now let's go to Power Query and start like investigating those stuff. Now I'm going to start with the very obvious one. Remember the sheet one? It is a complete duplicate of the shipments. So they are like identical tables. Think this is an import problem that happens maybe from the source system or the Excel. Of course, happens a lot in real projects where you import stuff that are actually not necessary inside the model. So what you can do, we can go and just delete it, not enable. So we remove it completely physically from our model. It is not something that we're gonna need later. Okay, so let's keep going. We have the exchange rate. Well, I'm thinking about this. We don't have like any relevance for this inside our data model. It is something transactional, maybe important for the interfaces in the source system. But for reporting, why do we need those informations? And actually, I cannot go and connect it to our data model. That's why I'm gonna say this is a standalone table that actually will not help us at all. So I'm gonna go actually and deactivate it. I will not like physically remove it. Maybe there is like use case for it. We cannot connect this anywhere. So deactivate. Now, what else? We have here the sales target. So here we have the target revenue and the period. So someone is like actually planning the target for each month. Well, this is like mini transactional table. This is not a dimension. That's why I'm gonna say, let's go and make small fact out of this. It will not hurt. So we're gonna go and bring it to the facts, rename it, of course. So rename fact. I'm gonna call it the sales targets. And what else we could do? We just go and maybe rename things to follow our standards. So the date and the target revenue. So actually that's it. It is a mini one that don't have really any like IDs to customers or dimensions, only has a date and a measure. So that's it. Let's go and deactivate this one. Disable load. Now, what else do we have? We have the security, and as well, we have a dimension underscore order. This is, of course, completely garbage table. So here we have just like a list of all orders, and this makes no sense. We have already better tables for this. So I'm going to say, I'm going to go and remove this completely physically from our data model. So delete, we will not deactivate. Perfect. Now, the last thing that is left is the security. Of course, my friends, we cannot leave the data model as it is. We have to make it secure following the standards, and here we have a very helpful table to let us know which user is allowed to see which region. But of course, we're going to do this in the last phase. So now what I'm going to say, actually we have covered everything. So let's go and close and apply and have a look. Yes, it is empty. I know we have the security. We can do this later. I'm going to bring it near to our data model here. And my friends, I can say the nightmare dataset just got cleaned up. So we have here a healthy star schema. Just enjoy this view. Have a look to this. We have a healthy data model. I think my camera gave up, so back. Now look at this, my friends. We don't have anything anymore from the old spider web, the nightmare dataset. Everything is migrated to a clean star schema, of course, a Galaxy one. So everything is connected using the best practices, and we have here only one fact table that stands alone and the security table. So just sit back and look at this. This is really satisfying, but of course we are not done yet. We still have the last phase. Alright friends, now the next phase, it's all about polishing the data model. So here we're gonna finalize our data model, we're gonna make it trustworthy before handing it over for the next phases. So we're gonna do things like, for example, we're gonna go and check again our standards, our rules, and check whether all the tables and the columns are following it, like the snake case, like the prefixes, suffixes, the keys, and so on. The second step that I usually do is that I go and create the dimension date. It is a special dimension that actually gonna be needed almost in all our facts. So we have to create it and connect it in the data model. This is one of the things that I do at the end. And after that, we're gonna build like a collection of measures. So we're gonna make like set of very obvious measures that's gonna be needed on top of this model. And after that, we're gonna make sure that our data model is secure. That means we're gonna apply on this model the row level security. This is like almost standards in any project. And after that, we do the final testing. So we go to the report level and we go and check only the big numbers and whether the dimensions are working correctly to make sure that everything is correct before handing over this data model for the others. Usually the last step is I go and make a meeting and talk to the others, show them the start schema and make a guide on how to use it for reporting. Alright my friends, so now let's deep dive in this phase.
Okay, let's do it.
Okay, so now let's start with the first step where we're gonna go and check whether our data model is following the standards and rules. I'm pretty sure that I have forgotten something during the building phase. We are at the end human and we might forget things. So now how I usually do it is that I go to the table view over here and have a quick check on the right side. So I can see that everything is sorted correctly using the prefix. So we have the dimensions and the facts and the last one is the security. So by looking through this, I can say all the names of our tables are following the standards. Then we go just quickly through all the tables one by one, just to have a quick look. Well, everything looks so far fine. Well, seems that I have followed all the rules. Well, not everywhere. So I have to fix here the naming conventions for this fact table. So we have to do it quickly to go to the Power Query. Okay, the fact order. So customer ID, order date, ship date. Okay, looks good. So I'm gonna go and close and apply. All right, so we are following the standards over here. Let's go and keep going. Looks good, as well good. The security gonna be at the end. Okay, so that means we are following all the rules for the table names and as well for the columns. Now there is another thing that I do, is that I go and check the date formats. Well, you can see here that in our dates we are using the full name, the full month. This looks really weird in reporting. If you have a lot of dates, it's gonna take a lot of space in the report level. So what I usually do is that I decide on one like smaller format and I stick to it for the whole data model. So now what I'm gonna do, I'm gonna go and first decide on the formats. So if you go over here to the column tools, you can see that we have format for the dates. And in Power BI, we have a lot of formats. I'm gonna say the standards is gonna be this one. So the year, then the month and day, depend of course on the region. But this one is compacted and small. Look at this, it is not taking so much space. So that means this is gonna be the standards on how to show the format inside the data model. Now we're gonna do very annoying task where I'm gonna go through the whole data model and make sure that all the dates are using this format. Now of course you can pause the video and do it. I'm gonna now fast forward just to make sure this video don't explode. So I'm gonna do this pretty fast. So let's go. So that was the last fact in our data model, and with that we have now the same format for the whole data model. Now there is another thing that I usually do at this phase as well, since we are now going through all tables. When Power BI sees a column as a number, it's gonna make it automatically like aggregatable. So that means if you use it inside your report, Power BI gonna automatically like summarize all the values. This is of course a nice thing, but sometimes we have numbers where it makes no sense to summarize. So it's really nice if you clean this in the data model before going to the next phase, so that people don't make any mistakes. So now what we're gonna do, we're gonna go through all the tables one by one and always keep your eye on this icon. That means this column could be aggregated. For example, here the budget. You can see here the summarizations, it is sum. If you don't want it to get summarized, you're gonna go over here and say don't summarize. So now you have to make decisions almost for all your numbers. I'm gonna say for the budget it makes sense of course to make maybe an average, so I'm gonna leave it as it is. For the customers, well, I'm gonna say maybe it makes sense to make an average out of this, so this is okay. So let's go through all the dimensions. Same things for the product. So that was the last table, the last column, and with that that all dates inside my data model is following the same format. Alright, so that's what the first step. We made sure that we are following the rules and the standards on the format and everything. Now we're gonna go to the next step that I usually do with that. I go and create the dimension date. There are many different ways on how to create this. I usually do that in the backend. So if I have a database or Databricks, I go and create the dimension there. But since now we are just doing Power BI, I'm gonna show you a way on how to create it directly in your data model. There is a really nice way, I'm gonna say very smart way actually from Power BI. Now I will not go and give you like a CSV file or a text with all dates inside it and say, hey, this is your dimension. But this time we're gonna go and create it by getting inspired from the data model. So how we're gonna do it, you're gonna go over here to the home, and here in the ribbon we have something called a new table. So what we are doing here, we are like creating a new table inside the data model, and we're gonna go and call it, since this is the dimension date. Now there is a very cool function in Power BI called calendar auto. So read this. It returns a table with one column of dates calculated from the model automatically. And this is exactly what it does. It go and scan the whole data model, understand the range of our business. So understand what is the earliest date and what is the latest date, and just create one column based on that. Very, very cool. So actually that's it. We don't have to give it any arguments, and hit enter. Amazing thing. So look at this. The earliest date is the 1st of January 2025, and the latest date is the end of 2026. And of course, this, my friends, gonna expand automatically as the business grow. So that means if the data sets like grow over the time and you have 2027, you don't have to deal with the dimension date because it's gonna grow automatically. So suddenly you can have as well in the dimension date 2027. I can tell you, this is magic really. In my old days, as I had done business intelligence with other tools, that was one of the biggest struggles, where I had like a manual table and I have to always add in new years and stuff like that. And I can tell you, many people forget to update their dimension date. And of course, this caused a lot of problems in the report, because almost on each report, you are doing like analysis over the time and you will be using this dimension. So this is one of the most important dimension compared to the others. And if you don't make sure it is always up to date, it's gonna be catastrophic. But now we don't have to deal with all this chaos. Power BI did solve this and everything now is automatic. Just some trauma from my old days. Alright, so now what do we have? We have only like one column, right? Now what you can do, you can go of course and change the format to our format. So we need only the date, we don't need the hours and time. And now of course, the next step, if you want to go and expand this dimension to add more columns, like for example the year, the month, the day, the full name of the day, the full name of the month. So you can add a lot of things to this dimension by just going and adding like a new column. Like for example, if I would like to get only the year, I'm gonna do something like this, year equal, and then use the function year and specify here the column. So this is gonna be our dimension date, and that's it. So with that, we have the column called year, and I can do the same thing. So I'm gonna go and duplicate it. So that we have the years, we can go and create another one for the month. Same story. So month equal the function month in order to extract this part, our column. So my friends, we have a lot of date functions that we could add in order to expand this dimension, but I'm gonna leave it like this now. Of course, the big question is how we're gonna connect this new dimension to our data model. So we have it over here, and there are like many places where we could connect this. Almost all our facts has dates, right? Now, the thing is, we have a lot of fact tables inside our data model that have a lot of date fields. And this dimension date can play a very important role in order to make the bridge between all those facts. This is gonna be a shared dimension that's gonna help us in order to compare all those numbers from different facts. So this is gonna be our biggest shared dimension in the whole model. So how we do it, it's very simple. We're gonna go through the facts one by one and start connecting it to our dimension. So here we have the fact sales target. We grab the date and connect it to our dimension date. Okay, same thing, we go to the next one. We have as well date, so we connect it to our dimension. All right, so now we have like a shared dimension between those two, and we can go and compare now the numbers between those two facts. Now we have here this factless fact. It is a little bit weird, we don't have a date, so that's why we will not connect anything here. Let's go to the next one. Here we have a month. As well, we can go and connect it to our dimension. Let's go. And of course, the most important one over here, we have the fact sales. So we have the order date. We go and connect it and say save. And the last fact table, here we have a lot of dates. So for example, I'm going to go and grab the order date to the dimension. So now look at this. Our dimension date is actually a big shared dimension between a lot of facts. Now this is amazing because now we can do a lot of analysis side by side from all those facts. Let me just show you an example. Let's go to the report view. So now how we're going to do it. Now very important, as usual, in order to build the visual, we start first from the dimension. So the dimension date, this is going to build the axis for our visual. And then after that, we start picking the measures from the different facts. Like for example, the fact sales. We can go and now grab the total sales and put it in the view. Perfect. Now we can go to another one. For example, the fact sales target. This one gonna be on the month level, so the visual gonna looks weird. But we can fix it if we just remove the day from our date so that everything is on the month level. Now we can go to a third fact, like for example, the inventories. So let's go and drop the stocks or the units. This is exactly, my friends, the power of the dimension date. We can go now and visit all the facts and compare things side by side very easily without losing the numbers. Like you can see here, the total sales is always protected, and you can do now a lot of correlations and comparison. So this is the main job of the dimension date inside our data model. Now, of course, what else we can do with the dimension date? We can use it in order to do role-playing dimension. Like for example, we have here a huge fact table with a lot of dates, right? So we have the order date, the invoice date, the pay date. Now we can go and connect our new dimension multiple times to this fact. Let me show you how to do it. So let me just bring this fact here. And now we just grab the date to the different columns. Like for example here, the pay date. Of course, this is gonna be inactive. Then one more time for the ship date and another one for the invoice date. And I think the last one gonna be the delivery date. So look at this. Our dimension date is playing 5 different roles for this fact. But of course, you're gonna do this only if you really need it. Otherwise, this is gonna look really ugly. So don't go randomly like connecting the date for every column. Sometimes we don't really need it. Like for example, if I'm just like analyzing the sales, I don't really always to go and get the dimension date. So actually I can go and build the visual completely based on the fact sales. I have there the order date, I have everything. So if your analysis is based only on one fact table, then we don't really need the dimension date. But only if you are like comparing multiple facts, then we go to the dimension, of course. And with that, my friends, means we don't have to go crazy and connect the dimension date every single date column that we have in the data model, only if it's needed. And if you create something like this, then you have to go and start like building DAX calculations for each inactive relationship so that you can use it actually in your reports. But if it is not needed, then don't go and create all those relations. Now, our dimension date looks crazy, and this is usually how this dimension looks like at the end. So my friends, this is the topic of the dimension date. I usually do it at the end just to have a big picture first about all my fact tables, and only then at the end I go and connect the dimension date. Okay, so now we come to a very important step in data modeling that a lot of people actually skip at this phase. We have to go and create the measures. Now the thing is, yes, we have a good star schema, we have good structure, everything is connected correctly, the filter direction and all those stuff. But now if you go and hand this over to your project team and everyone start like building on top of it reports and visuals, now what could happen is that multiple people gonna go and start creating multiple versions of calculations that actually are calculating the same thing over and over, and nobody gonna know which one is the right one for the data model. Now another thing that might happen is that people that are working with the data model, they might not yet develop like understanding of the grains of your facts. So for example, they might go to the fact sales and say, you know what, I have to go and calculate the total number of orders. So they go and create calculation where they're gonna count the order IDs, which is totally wrong. The grain there is the line of order. So in order to do it correctly, they have to do count distinct on the order ID. That means this is gonna lead to wrong number even if the data model is perfect. So that means in this phase, our job is not only to structure and build a perfect star schema, but as well we have to go and prepare the measures side by side with our data model just to make sure that we reduce the confusion. And of course, I'm not saying here we have to go and now create all the measures for everything that we have in the data model. We just have to go and create the core measurements, the thing that we are sure is going to be reused over and over in many reports. And by the way, not everyone is working in teams. If you are solo data analyst, this is as well good for you. I'm pretty sure over the time you're going to have like multiple Power BI projects and you're going to forget about the grains and the data model. So you protect yourself making different versions of calculations and as well making wrong calculations. So my friends, this is exactly what we have to do now. We have to go and create a bundle of measures. All right, so now how are we going to do it? There's like two ways. Either you're going to go to each fact and inside them, you're going to start create the individual measures. Or there is like another way that I like to do and many others as well, is to go and bundle, let's say, the major measurements inside one fake table. Let me show you how to do it. So we're going to go over here and say, okay, new table. Now I'm going to call it underscore in order to have it at the top. Then measures equal nothing. With this, we got like an empty table here on the top. And now inside it, we're going to go and start creating all the measures of the data model. So that during creating the reports, you're going to have it all in one place and it's going to be easy to go and drag and drop stuff. And if you want to update your measures, you go directly here and start updating. So now this is our new measure that we have. Of course, we will not connect it to anything. I'm just going to go and move it here side by side with the security so that we can see, okay, this is my star schema. And those are the, let's say, the add-ons on top of it. Now let's go to the maybe report view and create a new tab. I'll just start now and create like few major measures inside our data model. So let's start with the fact sales. Like for example here, it's very obvious that one of the major measures, it is the total sales, right? So how are we going to do it? We're going to go to the measures over here and right click on it and say new measure. Then we just create like very simple DAX calculations. So for example, total sales equal to the sum of the fact table sales. And now you pick the column, so line total, and actually that's it. Now what we do actually after that, we decide like on the format of this measure. Like for example, I'm gonna have the 1000 like separator. Actually I don't want it as a decimal number, so I just want it always to be a whole number, so that everything is formatted and is ready in order to be used in my reports. So now by just drag and drop from this measure, I'm gonna get the total sales without worrying about how this is calculated. So that was an obvious thing. Then we have to keep thinking, okay, what could we measure? Well, very important, the total number of orders. So we're gonna go and create a new measure, total orders equal. Now we want to count how many orders that we have in the business. So we're going to say, okay, count. But again, since the grain is line of total, we're going to go and use the distinct count. And we're going to say, okay, fact sales, the order ID. So actually that's it. Now, of course, we can think about how we're going to format it. So it's going to be as well, the 1000 is going to be separated and it is a whole number, which is correct. So if I go drag and drop, same thing, I got that total number of orders, which is correct. So as you can see, this is the whole job. We're going to go through all the facts one by one and we start creating those measures, but we have just to focus on the main things that we are sure that's going to be used in many reports. Like for example, we can go and count the total number of active customers. So there is like a difference between all the customers that we have inside the data model. For that, we can go and count it from the dimension customer. But if you want to know how many customers are actually ordering things, then you have to go to the fact sales. So we can go over here and say, okay, new measure, total active customers equal as well distinct count, because we're going to go to the fact table. So fact sales, and here we need the customer ID. So this is the count from the fact. Now we can go and create another one that is actually counting from the dimension. So base, maybe total customers equal. This time we can just go and use the count for the dimension because we don't have duplicates. Dimension, customer, and here we pick as well the ID. Over here, same thing. If you have a lot of customers, you can go and start like separating things with 1000. Now what else we can do, we can go to another fact. Like for example, here we have the fact order process. We can go and calculate the average number of days from the first step to the last step. So now how are we going to do this measure? First, we have to go and create maybe a column. Let me just go back over here to the table view. So look at this, we have all the steps. And I would like to go and calculate how many days that we have between the first step, the order date, and the last step, the pay date. And with that, we're going to get like a new measure for this fact. And on top of it, we're going to go and create a new calculation. So let's go and do that. First of all, we need a new column because we need calculation on the row level. So for example, this is going to be order to pay. Now we just want to find the differences between two dates. So there is a function called dateDiff. The first date is the order date. The second one is the last one. So it's going to be the pay date. And what is the difference? We are calculating how many days, not month or year. So this is the part that we are interested in. And actually that's it. So look at this. Now we are getting the total number of days that it took from the order to the payment. Now, the next step is very simple. We're going to go and create a new measure in our collection where we're going to say, like, for example, average order to pay equal average. Then we just go and pick our new measure. So it is the order to pay. So look at this. Now we have another measure based on another fact, but everything now together. So now if you are building a report, all what you have to do is to just go and open this one and start browsing all the measures of this data model. But of course, again, you don't have to go and sit and think about each single detail. Just create the obvious one, okay? Now I'm gonna say for now, I'm gonna stick with this. This is a good collection of measures that we can hand over together with the data model. Alright friends, now we are getting very close. We have now the last step in the last phase. We have to make sure that our data model is secure. So that means we have to go and apply the row level security mechanism on top of our data model. Let's go and do that. Okay, so now again, we have our star schema, we have those measures, and the last add-on that we have to add is the security. Now, first of all, to make sure that the security is ready, we have to go back to the Power Query and make sure that everything there is ready and clean. Okay, so this is gonna be our last table inside the stage, the security. Now, quickly by looking to this, you can see the header informations are not correct. So this should be the columns. And yes, we still have to follow the naming convention. So I'm going to go and rename things. This is the user email. And this is my friend, the region. All right. Now the last step is that I'm going to go and grab it actually to the other supports. So with that, I don't have anything more in the stage that I have to work on. Look at this. We have here the dimensions, we have the facts, and the support going to be the security table, since it doesn't belong to those two. All right, let's close and apply. All right, now look at this. It connects to our data model, but I have to make sure that it is correct. So let's go and just remove it. So we didn't need this relationship. And about this one is actually correct. So now again, let's first understand the security that we have here. So let's just talk about it. This is the security. Look at this. Here we have the user email addresses. Those are the employees of our business, and it looks like they are assigned to specific regions. Now, of course, in order to build this, we have to talk to the security officers of our company and understand how the security works. They might say, you know what, each employee in our company is allowed to see only specific region. Like for example, Nora can see only the North America. She is not allowed to see the sales that are happening in Europe or Middle East. Same thing for Hans. Hans can see only Europe sales. So we have to understand the security requirements before we start like connecting things. So we cannot go blindly like making a security concept for the data model, and only after understanding, then we can start connecting things together. And then of course, the next step is to think, okay, where are the region informations? In which facts, in which dimensions we can see that? Now, of course, it is very obvious. If you go to the dimension customers, you're going to find over here the region information. So this is a very good starting point. Of course, the question is, how are we going to connect this security to our data model? And we usually do it on top of dimensions, because dimensions anyway go and filter the fact tables, and the security table is going to be filtering this dimension. Now it's very obvious that we have the dimension customer where we have the region over here. So this is a perfect candidate where we're going to connect our security on top of this so that the user can see only specific customers, and this will be filtering as well our facts. So this is one way on how to create the security. There is another way on how to do it, is to go to the geographic dimension. As well, here we have regions, and this one is connecting as well directly to our fact, which is really as well good candidate that we could use in order to filter our data model based on the security. Now, how are we going to decide on this? Usually I do it like this. I go back to the data model and look to those two dimensions. So I can see here, for example, let me zoom in. This is the geo dimension, and you can see it is connected to the fact sales. So now if I put the security on top of this, it's going to go and filter only one fact table. But now the other one, the dimension customer, it is actually connected to two facts, the fact sales and the fact order process. So if I connect the security on top of this, I'm going to benefit in order to secure actually two facts, which is of course a nice thing. So I'm going to go and decide actually on connecting the security on top of the dimension customers, just because it secures more facts for me. But again, based on the requirements, we have to do those stuff. And now I saw like some weird scenarios where people can go and say, you know what, I want to secure the whole data model without any reason. So they start like forcing somehow the data model to use the security table on top of each fact. So they start like doing crazy things like by merging the facts just in order to get the region column inside each fact, and they destroy the grain because of this, just to add the security. At the end, maybe this is totally unnecessary. So always understand the security security requirements and only apply it when it's needed. You don't have to secure every single dimension and fact. Like for example, is it really bad to show the dimension products for all our employees? I think it is no harm if they see the whole data. So that means for our project, let's say that we can apply the security on top of those two facts, the sales and the orders. So now how are we going to do it? It's going to be very simple. We're going to go and build a relationship between the security and the dimension. So we're going to go over here and say, okay, region by region, one-to-many relationship, and the filter is single direction. We have to make sure it is going in the right direction, of course. Well, yes, look at this. The filter direction of the security is going to the dimension, and the filter direction of the customers is going to both the fact sales and the fact order process. So this looks perfect for security. Of course, the next step is that we're going to go and start creating the managed roles. Otherwise, this will not work. So it's going to be very simple. We're going to go and create a new role. Let's go and call it regional access. And of course, in which table we are building the security, it's going to be on the dimension customer. And we're going to write a DAX calculation in order to secure it. So we're going to go and switch to DAX. Okay, so this is going to be very simple. We are just writing the DAX filter expression where we're going to say, okay, I want to show only the rows where the region is matching the user region. So that means it has to go and find out what is the region for our current user. So it is inside the security table, the region. Then it should match the email address that we have in the security with the user, whoever is opening the Power BI reports. And for that, we have a nice function, the user principal name. So very simple thing. So it is not that hard. We are saying just check each row and ask this question. Does the region belong to the person that is looking at the report? If yes, then keep the row. Otherwise, go and drop it. So it is just a filter expression that's going to help us to filter the rows based on the region, of course. Actually, that's it. Let's go and save it. Very important that we are getting green. Now let's go and close it. All right. So with this, we have applied the role level security on top of our data model. But of course, we don't trust until we test. So how are we going to test it? I need one email like one of the employees. So for example, Nora, I'm going to go and copy its value, then go back to the model. And now we can try to view the model as Nora is opening the report and seeing it. How to do it? We can go over here and say view as, then we have to specify the rule that we just created. So the regional access, and we want to see it as another user, not as Baraa, because otherwise it's going to take the informations of my users, but we want to see it as Nora. Okay. So let's hit okay. Now you can see we can get like a warning. The regional access is activated and we are viewing the object as Nora email. So now let's go and test. Look at this. We are already seeing like less details than before. So the total sales is not anymore the total number of sales of the whole data model. And we are seeing only the total sales that is based on the Nora's region. Of course, we can test this as well by going to the dimension customer and let's go and grab the region. So you can see we are seeing only the North America. So my friends, that means the dimension is working. The fact table is as well working. And of course, the last test, let's go and remove this effect. So if I stop viewing, look at this, suddenly I'm going to see the total sale for everything. And as well, I'm going to see all the regions. Of course, now you can go and pick another email and test that. But for me, it is already working. And we have applied the role level security on top of our data model. All right, friends. Oh my God, I can say that we are done. We made it. Just sit back, look at this and enjoy it because this is awesome. And remember at the very beginning, I showed you this beautiful chaos and the nightmare data model where we had the many-to-many relationships everywhere. The filters are going from one table to another just in all directions. No star schema, nothing makes sense. Full chaos. But now look back to this. We have clean, healthy star schema, or let's say galaxy, where we have fact tables and surrounded with dimensions. Every relationship and every filter is going to the right direction. The numbers are protected and everything is friendly and easy to read. And I can tell you, this one was not an easy one. That was a really hard project and complicated. And if you stayed until the end and you built exactly this data model with me, then my friend, you should be proud of yourself. And I can say welcome to the club. With this, you went with me through the journey exactly like I do in my projects, in my companies. And I can tell you, over all projects, I just met like only few people that have this kind of skills where they can turn a chaos data model into a clean one, because most people actually don't know how to do data modeling and they skip it. But my friends, we are not one of them. We are the expert that can build a real data model. And this is really a rare skill that many companies need. So what I really recommend you is to go and make this project as your portfolio project. Of course, feel free to use it as your project. So go and share it as well with the others in LinkedIn, and you can tag me if you want. But what is way more important than this, if you are searching for a job and you got interviewed, make sure to talk about this project because this is really rare. It's gonna make you quickly stand out the crowd. And if you got hired or you are already at the company and you joined a new project where they have exactly the data model, the chaos that I showed you at the start, what's gonna happen? This time you will not panic. You're gonna look at it and smile because you're gonna remember exactly this project and you know what to do. So now, before we close this project, I would like to go through all the most important points that we have learned during the data modeling. So let's recap. The first point, before you build anything, always take time to analyze, explore, and understand. You have to understand the business, the processes, the data. The more you invest in exploring the data and understanding the business, the easier things gonna be during building the data model. Then the second point, always understand the grain of your tables, dimensions, and facts, and say it loudly what each row is representing. Once you know that, you will not make mistakes as you are connecting tables. Third point, always set rules and standards before you start the projects and always follow them until the end. All the naming conventions, the prefixes, and so on. Rule number 4. Always remove the unnecessary data from the data model. This is very important. Always ask, do we really need those informations for reporting? Is it really necessary? Never be the person that's gonna leave things just in case. And the next one, our goal is always to build the star schema. All BI projects loved it. It's just gonna make your life easier with the calculations. And of course, always avoid connecting fact tables together. Just use a shared dimension in between. And the filter directions are always from the dimensions to the facts. So my friends, that's it. Yes, this is the whole project. I really enjoyed making this project. For a while, I thought that I'm working at a company. I'm not recording a video and I'm talking to a colleague. I really had a lot of fun making this project. I really enjoyed it. Now it's time for you. So you have to go and practice on your own. Maybe go and grab any data model or your own data. Try to make a healthy data model out of it. So that's it, my friends. I hope you enjoyed this project with me. If yes, then support the channel by subscribing, liking, and commenting. Share it with the others in order to reach nice people like you. And I'm gonna say thank you so much for watching, and I'm gonna see you in the next project. Bye bye.
Catch you later, warehouse. See you on the flippity flip.